Hello, good evening, beta. I will wait for some 5 more minutes. Let others also join in. Then I will start the class. Okay. Hello, everyone. So, beta, today, this is the first class of basic maths for economic analysis. Now, the book that I will be following in this, that is A.C. Chiang. And I will be doing I will be starting with chapter 2 today. Okay, beta? The name of chapter 2 is called Economic Models. So, बेसिक एम क्या है इस चैप्टर का? एम ये है कि ये जाना जाए कि इकोनॉमिक मॉडल्स क्या होते हैं और कुछ कुछ इंपॉर्टेंट वर्ड्स, जैसे बेटा ये जाना जाए कि इक्वेशन क्या होता है, ये जाना जाए कि पैरामीटर क्या होता है। तो ये जो भी हमारे इंपॉर्टेंट एलिमेंट्स हैं, इनको आज हम समझेंगे। ठीक है, सबसे पहले आपको ये जानना बहुत जरूरी है कि एक मैथमेटिकल मॉडल के इकोनॉमिक इंग्रेडिएंट्स या इंग्रेडिएंट्स क्या होते हैं। तो बेटा, फर्स्ट टॉपिक दैट आई वांट टू स्टार्ट विद टुडे, प्लीज राइट डाउन, दैट इज कॉल्ड एज इंग्रेडिएंट्स ऑफ अ मैथमेटिकल मॉडल। एक मैथमेटिकल मॉडल के बहुत सारे इंग्रेडिएंट्स होते हैं, जिसमें सबसे पहली बात जो हमको समझनी होती है वो होती है इक्वेशंस। तो जब भी हम एक मॉडल लिखना शुरू करते हैं, उसमें इक्वेशंस बहुत इंपॉर्टेंट रोल प्ले करती है। जैसे फॉर एग्जांपल, लेट्स से दैट आई एम टॉकिंग अबाउट अ जीडीपी ऑफ द इकोनॉमी। तो बेटा, इफ यू नो, जीडीपी की इक्वेशन ऐसे लिखते हैं, y इज इक्वल टू c प्लस आई प्लस जी प्लस nx। So basically what we are going ahead and doing, we are going ahead and we are writing an equation, एक structure define कर रहे हैं हम मॉडल का। जिस चीज से मॉडल का स्ट्रक्चर डिफाइन होता है उसी को इक्वेशन बोलते हैं। जैसे फॉर एग्जांपल, बहुत बेसिक एग्जांपल है, मैं बोल देती हूँ कि मेरे को दो चीजों को ऐड करके 5 चाहिए, ये भी एक इक्वेशन हो गई। सपोज मैंने आपको बोल दिया कि बेटा फाइंड आउट द रिलेशनशिप बिटवीन, आई एम नॉट अ साइंस स्टूडेंट, बट जैसे मैं बोल दूं फाइंड आउट द रिलेशनशिप बिटवीन फ़ारेनहाइट एंड सेल्सियस, कि 9/5 से मल्टीप्लाई करके कैसे फ़ारेनहाइट आता है और कैसे सेल्सियस आता है। तो जो भी हम एक स्ट्रक्चर डिफाइन कर रहे हैं, व्हेनेवर वी डिफाइन स्ट्रक्चर ऑफ द मॉडल, दैट फॉर्म्स द इक्वेशन। क्लियर है ये बात एकदम सबको? सो इक्वेशन क्या हो गई? डिफाइनिंग structure of the model, is possible through equations. अब इसी से हमें एक इंपॉर्टेंट चीज समझनी होती है और उसे बोलते हैं वेरिएबल्स। अब वेरिएबल क्या चीज है बेटा? जो भी चीज वेरी करे, डेफिनेशन समझो, जो भी चीज वेरी करे मतलब जिसका भी मैग्नीट्यूड चेंज हो वो वेरिएबल। सो वेरिएबल इज एनीथिंग दैट कैन टेक different values. मतलब anything that is basically changing its magnitude. That means anything that can change magnitude. बेटा उसको वेरिएबल बोलते हैं। एग्जाम्पल देखो, पहले एक मैथमेटिकल एग्जाम्पल ले लेते हैं। अभी मैंने यहाँ पे इक्वेशन डिफाइन की और इक्वेशन को कैसे बोला? इक्वेशन इज x प्लस वाई इज इक्वल टू 5, है ना? सो बेटा x प्लस वाई 5 हो रहा है। अब x अगर वैल्यू 1 लेगा तो y 4 लेगा, अगर x वैल्यू 2 लेगा तो y 3 लेगा, अगर x वैल्यू 2.5 लेगा तो y 2.5 लेगा। ये हर पॉसिबल वैल्यू ऑफ x एंड y के लिए ये इक्वेशन सेटिस्फाई हो रही है ना? बट x एंड y अपनी वैल्यू चेंज कर पा रहे हैं तो ये वेरिएबल हो गए। एनीथिंग दैट इज एबल टू चेंज द वैल्यू, जो भी चीज जिसकी हम वैल्यू चेंज कर पाते हैं उसको हम वेरिएबल बोलते हैं। अब हम इकोनॉमिक्स की बात करते हैं। एग्जाम्पल, इकोनॉमिक्स की टर्म में एक वेरिएबल हो गया प्राइस, वेरिएबल हो गया रेवेन्यू, वेरिएबल हो गया कॉस्ट, वेरिएबल हो गया नेशनल इनकम, एक्सेट्रा। क्योंकि ये अपनी वैल्यू चेंज करते हैं। जैसे प्राइस की बात करते हैं बेटा, सपोज मैं बोलूं दैट ये जो प्राइस है ये डिमांड एंड सप्लाई से हम फाइंड आउट कर रहे हैं। सो दिस इज डिमांड, दिस इज सप्लाई, एंड वेरेवर डिमांड एंड सप्लाई मीट, जहां पे भी डिमांड और सप्लाई मीट कर रहे हैं वो प्राइस है और ये क्वांटिटी है। सो वेरिएबल मैंने कैसे डिफाइन किया? वेरेवर डिमांड एंड सप्लाई मीट, वहां पे हमारा प्राइस डिफाइन हो गया है। अब सपोजिटली बेटा लेट्स से दैट देयर इज इंक्रीज इन द डिमांड, तो बेटा जब डिमांड इंक्रीज होगी तो क्या होगा? प्राइस भी चेंज हो जाएगा और क्वांटिटी भी चेंज हो जाएगी। सो प्राइस इज चेंजिंग एज द डिमांड इज चेंजिंग, प्राइस इज वेरिंग द मैग्नीट्यूड, बेटा प्राइस बिकम्स अ वेरिएबल। क्लियर हुई बात? एनीथिंग दैट वेरीज, anything that changes its value, that is a variable. So beta here, because price is changing its value, it becomes a variable. So economics में ये सब के सब variable है। अब economics में और maths में एक concept आता है which is called freezing of variable. तो बेटा freezing of variable क्या है? फ्रीजिंग ऑफ वेरिएबल, फ्रीज करना मतलब क्या होता है? वैल्यू को फिक्स कर देना। तो जब मैं वैल्यू को फिक्स कर देती हूं, व्हेन वैल्यू ऑफ वेरिएबल इज फिक्स्ड, देन बेटा इट इज कॉल्ड फ्रीजिंग ऑफ वेरिएबल। जैसे फॉर एग्जाम्पल, आई एम फिक्सिंग that price will take the value 3 or cost will take the value 18. I am fixing the value now. So when I go ahead and I fix the value, then it is known as freezing of a variable. Okay? So we have understood what is a variable, what are equations. But now I want to distinguish between two kind of variables. अब दो तरीके के वेरिएबल्स हम पढ़ेंगे। ठीक है बेटा, पहला वेरिएबल जो होता है उसे बोलते हैं एग्जोजेनस वेरिएबल। और दूसरा वेरिएबल जो होता है उसे बोलते हैं एंडोजेनस वेरिएबल। ध्यान से समझो बेटा, एक्स मीन्स आउट, सो एक्सोजेनस मीन्स आउटसाइड द मॉडल। बेटा एंडो मतलब इनसाइड, सो एंडोजेनस मीन्स इनसाइड द मॉडल। सो जब भी हम किसी भी मॉडल को डिफाइन करते हैं, मतलब कोई भी इक्वेशन लिखते हैं, कुछ वेरिएबल्स होते हैं जो इक्वेशन के अंदर ही हमें फाइंड आउट करने होते हैं, उनकी वैल्यू निकालनी होती है। सो जिन वेरिएबल्स की वैल्यू हमें निकालनी होती है, द वेरिएबल्स whose value you want to find out, that is called endogenous variable. So you want to find out the value of endogenous variable. अभी एग्जाम्पल से समझेंगे। बट एक्सोजेनस वो वेरिएबल्स होते हैं जो आपको गिवन होते हैं, दे आर गिवन टू यू। ठीक है बेटा, एग्जाम्पल लेते हैं। जैसे फॉर एग्जाम्पल वी हैव समथिंग विच इज नोन एज इक्वेशन ऑफ अ बजट लाइन। इक्वेशन ऑफ बजट लाइन, समझो ध्यान से बेटा। सपोज मेरे को अपना सारा का सारा पैसा दो गुड्स पे खर्च करना है, से एप्पल्स एंड बुक्स। So either I can have apples, I can spend on apples or books. ठीक है बेटा। Price of each apple is PA. Price of each book is PB. And I am equating it to income of the consumer. इसको एक बारी समझ लेते हैं क्या मतलब है इसका। बेटा मैं A amount of apples consume कर रही हूं और हर एप्पल PA का है। I am consuming B amount of books और हर बुक PB वैल्यू की है। So बेटा this is my money spent on apples. Money on apples. ठीक है बेटा, this is my money on book. जितना मैं एप्पल पे खर्च करूं और जितना मैं बुक्स पे खर्च करूं, बेटा इन दोनों को मिलाकर आपको कंज्यूमर की इनकम मिलनी चाहिए। तो ये आपकी इनकम हो गई है। एक बार एग्जाम्पल को थोड़ा और समझते हैं। जैसे बेटा मैंने 5 यूनिट्स ऑफ एप्पल खरीदे और हर एक का प्राइस 3 रुपीज था। मैंने 10 यूनिट्स ऑफ बनानास खरीदे और हर एक का प्राइस 5 रुपीज था। तो मैंने एप्पल्स पे कितने रुपीज स्पेंड किए? 15। बनाना पे कितने रुपीज स्पेंड किए? 50। दिस इज प्लस, हाँ। और मेरी टोटल इनकम कितनी? व्हाट्स माय टोटल इनकम? 65। सो बेटा व्हाट यू स्पेंड, योर मनी दैट यू आर स्पेंडिंग ऑन एप्पल्स प्लस बनानास, दैट इज इक्वल टू इनकम ऑफ द कंज्यूमर। इस इक्वेशन में मेरा एम क्या है? आई वॉन्ट टू फाइंड आउट हाउ मेनी एप्पल्स एंड हाउ मेनी बुक्स आई विल कंज्यूम। मेरा एम है कि मैं ये निकालूं कि कितने एप्पल और कितनी बुक्स मैं कंज्यूम करूंगी। और मुझे गिवन क्या है? बेटा मुझे गिवन है कि मेरी इनकम कितनी है और दोनों गुड्स के प्राइजेस कितने हैं। ये मुझे ऑलरेडी गिवन है। सो वॉट एवर इज गिवन टू यू, यहां पे आपको गिवन थे प्राइजेस ऑफ द गुड्स एंड इनकम ऑफ द कंज्यूमर। वॉट एवर इज गिवन टू यू बेटा वो हो गया एक्सोजेनस वेरिएबल। वॉट यू आर फाइंडिंग विद इन द मॉडल, जो चीज आपने मॉडल के अंदर से निकाली वो हो गया एंडोजेनस वेरिएबल। तो मेरा एम है ये जानना कि कितने एप्पल और बुक्स कंज्यूम करूं, तो ये हो गए मेरे एंडोजेनस वेरिएबल। और मुझे गिवन है कि कितनी मेरी इनकम और प्राइसेस हैं, तो ये हो गए एक्सोजेनस वेरिएबल्स। ठीक है जी। अब एक बहुत इंपॉर्टेंट नोट समझो बेटा, जो वेरिएबल एक मॉडल के लिए एंडोजेनस है वो दूसरे के लिए एक्सोजेनस हो सकता है। द वेरिएबल दैट इज एंडोजेनस फॉर वन मॉडल कैन बी एक्सोजेनस फॉर द अदर मॉडल। समझे बात को? एक बार लिख लेते हैं। सो वेरिएबल एक्सोजेनस फॉर वन मॉडल कैन बी endogenous for other model। अब इसका क्या मतलब है? इसका ये मतलब है बेटा दैट यहां पर देखो हम फाइंड कर रहे थे कि कितने एप्पल और बुक्स कंज्यूम करने चाहिए, एंड आई वाज गिवन, मुझे गिवन थी इनकम और प्राइसेस की वैल्यूज। दिस वाज गिवन टू मी। ठीक है जी। बट सपोज बेटा अब मैं आपका एग्जाम्पल चेंज कर दूं और मैं क्या करूं, मैं आपको दो इक्वेशन दे दूं, एक डिमांड इक्वेशन और एक सप्लाई इक्वेशन। So now I change the model and I give you two equations बेटा। डिमांड की इक्वेशन हो गई Q is equal to A minus BP, एंड सप्लाई की इक्वेशन हो गई, सपोज ये गिवन है आपको C plus DP। Now I am giving you these two equations. So बेटा if I give you the demand and supply equation, इससे आप क्या फाइंड कर सकते हो? You can find the price and quantity। इन दो इक्वेशन से, एक मैंने आपको डिमांड की इक्वेशन दी है, एक मैंने आपको सप्लाई की इक्वेशन दी है। जब मैं इसको और इसको इक्वल करूंगी, जहां डिमांड और सप्लाई मीट कर रहे हैं, व्हेन आई विल इक्वेट डिमांड टू सप्लाई, तो बेटा इससे आपका इक्विलिब्रियम प्राइस और इक्विलिब्रियम क्वांटिटी आ जाएंगे, है कि नहीं है? So when you will equate demand to supply, you will get equilibrium price and equilibrium quantity. तो बेटा you are finding this price and quantity within the model ना, मॉडल से निकाल रहे हो ना इसे। तो that means that now price is endogenous। endogenous मतलब आप प्राइस को मॉडल से फाइंड आउट कर रहे हो। तो ये बात समझनी बहुत जरूरी है कि जो हमने ऊपर मॉडल डिफाइन किया था, द मॉडल आई डिफाइंड अबव, बेटा हियर प्राइस वाज एक्सोजेनस, प्राइस वाज डिटरमाइंड आउटसाइड द मॉडल, बट बेटा हियर प्राइस इज नाउ endogenous, price is determined within the model। I hope this is clear to you। So the same variable can be exogenous or the same variable can be endogenous also। Okay, beta? Now, I want to go ahead and I want to talk about one more thing here, which is known as a constant। What is a constant? Beta, a constant is a magnitude that is not changing. So, a magnitude that does not change, doesn't vary. Let me give you an example. But all of us know that the value of pi is 22/7. Right? The value of pi is 22/7. It cannot change. I cannot make pi as 4, 5, 10. ऐसा नहीं कर सकते ना? It is fixed. So beta, this is a constant. Anything whose value does not change becomes a constant. Now, when a constant is attached to a variable, बेटा जब एक कांस्टेंट को वेरिएबल के साथ लगाते हैं, when a constant is attached to a variable, it is called coefficient. It is called coefficient. Example. Suppose beta my variable is x. X can take any value, 4, 5, 10, 12, 15, any value. Now I attach a constant along with the variable. Instead of x, I write 7x. Then beta this 7, this is called coefficient. So when you attach a constant to a variable, then it becomes a coefficient. Now, बहुत ध्यान से समझना, ठीक है? Suppose, instead of writing a number here, नंबर की जगह पे ना मैं कुछ रैंडम कांस्टेंट लिखती हूँ, जैसे यहां लिखा था बेटा, हियर प्राइस इज अ वेरिएबल but A and B are constants. But A और B में तो कोई भी वैल्यू ले सकते हैं, 4, 5, 7, 10, 12 कुछ भी ले सकते हैं. So when, बहुत ध्यान से समझना है, when a constant can take different values. अब क्या करें? अगर कांस्टेंट भी डिफरेंट वैल्यूज लेगा तो वो तो वेरिएबल ही कहलाना चाहिए. नो, इफ अ कांस्टेंट टेक्स डिफरेंट वैल्यूज, then beta it is called a parameter. What is it called? It is called as a parameter. Take an example, bache. Example. When I write that the demand equation is A minus BP, beta quantity and price will change. Price can take value something, उसके हिसाब से quantity change होगी. These are variables. Try to identify. These are my variables. They mean something. Q means quantity demanded. P means price. They have some meaning attached to it. But this A, this B, these don't have any meaning attached to it. But they can also take some values. So beta, these are called as parameters. Is this clear? So under to identify this special status that this constant can also take some values, we call them as parameters. Clear? बहुत बच्चे बोलेंगे मैम ठीक है ये मॉडल में आइडेंटिफाई नहीं हो रहे तो इनको एक्सोजेनस बोल दो ना, exogenous variable. So yes, a lot of time a parameter resembles an exogenous variable also. Parameter और exogenous variable को एक ही माना जाता है बहुत बुक्स, ठीक है जी. Now, how do I represent a parameter? So a parameter can either be represented through small symbols like A, B, C, or you can also represent them through Greek alphabets like alpha, beta, gamma, and so on. So to write a parameter, either write ABC or write alpha, beta, gamma. Is that clear? Okay. Now, sometimes, so beta, I just gave you this example now. Just take here. Here, price was a variable in this equation, right? And here, price was a constant in this equation and it was exogenous. So I told you that the same variable can either become, the same variable can either be exogenous or endogenous. So in example 1, I showed you that price was exogenous. And in example 2, I showed you that price was defined within the model. It was endogenous. तो बेटा जब प्राइस एक्सोजेनस होता है, जब वो मॉडल के बाहर डिफाइन होता है, उसको नीचे वाले प्राइस से अलग करने के लिए this is represented as P naught. It's represented as P naught. So if you see P with this circle, it's called P naught. It means that This is an exogenous variable. ये आपको given value है. Given value. And beta, when you see just P, it means it is endogenous. That means beta, it is defined within, I mean, you have to find its value. This is an easier way to say this. So if it is with a subscript, that means that you have to go ahead and you are already given the value. And if it is without subscript, मतलब यार उस equation में उसी की value निकालनी है, वही वो value है जिसको आपको find out करना. Is this clear? Okay, now this comes a lot in exam. You should be able to distinguish between three types of equations. So beta, please write down the new topic as equations. There are three kinds of equations that you must study. But the first equation, that is known as definitional equation. The second equation is known as behavioral equations. And the third equation is known as equilibrium equations. Try to understand the first one. This is called as definitional equations. But definitional, matlab it comes from definition. What does it mean that it comes from definition? It comes from definition, matlab ki already definition defined hai. Jaise, we know better that revenue minus cost, this is profit. So whenever you have a definitional equation, that means that there is a definition attached. एक meaning है. ऐसे ही नहीं. So जैसे यहाँ पे था बेटा. Here I had written x plus y is equal to 5. है ना? Here we had written x plus y is equal to 5. There is no definition attached to it. इसका कोई मतलब नहीं है. मैंने ऐसे ही लिख दिया x plus y is equal to 5. But profit is equal to revenue minus cost. That is a definition, right? So whenever you have definition attached to it, actually, instead of using equal to, you should use 3 lines. And when you use these 3 lines, beta, this is read as identically equal to. इसको हम कैसे पढ़ते हैं? Identically equal to. Identically equal to का क्या मतलब है? कि ये एक identification है, ये एक definition है कि profit जो होता है वो revenue minus cost होता है. ठीक है? एक और identity equation लिखते हैं. Total cost is equal to total variable cost plus total fixed cost. So beta, I can use this sign. Because this is identically equal. This is a definition that I am writing. Okay, beta? So these are called as definitional equations. Beta, come to the second one. The second is known as behavioral equations. Behavioral equations are those equations which go ahead and change from time to time. So they can change. This will be beta in economics jaise. An equation can change as your technology changes, as your production function changes, your equation can change. है ना? So beta, these are equations which can change. एक example ले लेते हैं. Let me just. Okay, let me try and see if we can adjust here, huh? So behavioral equation का example हो गया. Just for example, let me take it here only. Let's say that you have cost is equal to 75 plus 10Q. But any cost has two components to it. This is the fixed component and this is the variable component. तो ये इक्वेशन क्या बोल रही है? ये बोल रही है कि देखो 75 तो फिक्स्ड है, इट इज नॉट डिपेंडेंट ऑन आउटपुट, और ये वाला जो पार्ट है ना, ये वेरिएबल है, ये चेंज करता रहता है, और ये जो वेरी कर रहा है ये आउटपुट के साथ डायरेक्टली वेरी कर रहा है. इट इज वेरिंग डायरेक्टली विद आउटपुट. Directly means when your output will be 1, then cost will be 75 plus 10 into 1. So cost will increase by 10. है कि नहीं? But when your output is 0, then cost will be 75. So when you increased your output to 1, cost is increasing by 10 now. 10 रुपए से बढ़ गई. When your output is 2, then better cost will increase by 20. Because you see here you will get 75, 85, and 95, and so on. So cost is increasing by 10 each. When output increases by 1 unit, cost increases by 10. Okay. But beta, suppose I write another way of equation. Suppose I tell you cost is equal to 110 plus Q square. So beta, now you have this as your fixed cost. Right? But now cost ये variable हो गई, but cost is affected by Q square. So beta, when your output is 0, then your cost is 110. When your output is 1, then your cost is 111. When your output is 2, then your cost is 114. So cost changed by 1, cost changed by 3, and so on. Cost is not here, cost was changing by 10 every time. हर बारी cost 10 से बढ़ी थी. But here cost is not changing by 10 every time. Here cost changed by 1, and then it changed by 3, and then it will change further, right? By 5, and so on. So you see that cost का जो function है, the way I write this function, that will define how cost will come. This equation will define. Suppose I change the equation. Beta, I write the equation like this: q cube plus q square plus q plus 4. Then the cost will be defined in very different way. So जैसे जैसे मैं ये equation को बदलती जाऊंगी, I will keep changing these equations. The way that cost will be defined will keep changing. Are you getting it? So when that happens, then beta, that is known as a behavioral equation. The behavior keeps changing based on the equation you write. जैसे आप equation लिखोगे, उसके basis पे behavior change होता जाएगा. That is known as behavioral equation. Are you clear? The first we defined, that is called as definitional equation. And the second one we defined, this is known as behavioral equation. Now beta, come to the third one, and that is known as equilibrium equation. Beta, equilibrium equation means wherever you equate two equations. जैसे we know that demand should be equal to supply. ये equilibrium equation हो गई. We know that savings should be equal to investment. ये equilibrium equation हो गई. So equilibrium equation are neither definitional nor behavioral. ना वो definition है, इसका कोई definition नहीं है. Demand equal to supply ये definition नहीं है ना? But profit डिमांड हर बारी सप्लाई के बराबर होती भी नहीं है. डिमांड इज नॉट ऑलवेज इक्वल टू सप्लाई ना बेटा. सो इफ यू हैव डिमांड हियर एंड यू हैव सप्लाई हियर, एट दिस पार्ट सप्लाई इज मोर देन डिमांड, एट दिस पार्ट डिमांड इज मोर देन सप्लाई. सो दे आर नॉट ऑलवेज इक्वल. वो हमेशा बराबर नहीं होते, बट जब हम उनको इक्वल कर दें, दैट मीन्स वी आर कॉजिंग एन इक्विलिब्रियम. बट दिस इज ऑलवेज इक्वल. ये हमेशा इक्वल होगा कि प्रॉफिट रेवेन्यू माइनस कॉस्ट ही होता है. That is how I've identified it. That's a way of identity. Are you getting it? That is why I'm using the identity sign here. है ना? So beta, we have studied the three kind of equations in this class. The first is called definitional equation. The second is known as behavioral equation. The third is known as equilibrium equation. I hope this is clear to you. Okay, beta. Write down the next topic now. And this is known as real number system. The real number system. In this, first of all, try and understand what is known as natural numbers. But natural numbers are all numbers which start from 1 and then 2, 3, 4, and so on. These are called as natural numbers. Okay, ji? Second, but we want to go ahead and we want to call something which is known as whole numbers. When in these natural numbers, I also include a 0, 0, 1, 2, 3, 4, and so on. Then beta with 0, 0 plus all natural numbers, that becomes a whole number. Okay. The third that we have, that is called as positive integers. But a positive integer matlab natural number only, positive values 1, 2, 3, 4, 5 and so on. ठीक है. फिर आते हैं negative integers. Better negative integers means negative values like -1, -2, -3, -4 and so on. Now, finally, suppose I want all integers. So beta positive integers, negative integers and 0 together is all integers. So integers में क्या क्या आ गए? Minus, यहाँ तक minus infinity तक जा रहे हो आप? 0, 1, 2, 3 till infinity. So taking all negative, all positive and 0 together, beta that forms as integers. Clear? Okay. Then the next that you have, beta that is called as rational numbers. Any number which is in the P by Q form, but Q should not be equal to 0, beta that is known as rational number. जैसे 5 can be written as 5 by 1, na? It's a rational number. 0 can be written as 0 by 1, na? It's a rational number. 1.5 can be written as 1.5 ka decimal hata do by 10. That means it is 15 by 10. It's a rational number. This is nothing but 3 by 2. It's a rational number. 2 by 3. It's a rational number. So anything which can be written in P by Q form becomes a rational number. Clear? Hai? Irrational number. Beta, irrational numbers are those numbers which cannot be represented in the ratio. Say, for example, root 2. Root 2 will be 1.4142, etc. It is a non-repeating, non-terminating number. Non-repeating मतलब कोई भी number repeat नहीं हो रहा. Repeating क्या होता है? जैसे ये 0.66666666 ये आता है 2 by 3 को. It is repeating itself, है ना? But it is ये repeat तो हो रहा है, but ये terminate नहीं हो रहा. So it is non-terminating. ये क्या है बेटा 3 by 2 is 1.5 तो ये रिपीट भी नहीं हो रहा है टर्मिनेट ही हो गया खत्म हो गया 0.5 पे सो बेटा दिस इज टर्मिनेटिंग इफ यू हैव टर्मिनेटिंग या रिपीटिंग बट नॉट टर्मिनेटिंग, खत्म नहीं हो रहा बट रिपीट कर रहे हैं, सो दे कैन बी रिप्रेजेंटेड इन रैशनल. But if you have any number which is non-repeating, non-terminating, मतलब repeat भी नहीं हो रहा, ये 4-1 है, ये 4-2 है, ये change होता जा रहा है, and खत्म भी नहीं हो रहा division, that is a irrational number. That is irrational number. एक और example दो, pi. Pi is beta 3.1415 and so on. So it is not repeating. Right? It is non-repeating and at the same time it is non-terminating. Khatam bhi nahi ho raha. Then beta these two properties make them as an irrational number. That forms an irrational number. Is this clear? So beta now, because we have done this, I will make a chart out of it. So beta integer comes from natural numbers and zero and negative numbers. Together, they form integers. Beta, these integers, they are part of the rational numbers. Integer हो गए 4, 5, 6, -4, -3. But fractions, जैसे 3/2, 2/3, they are also part of the rational numbers. Then beta you have irrational numbers. Irrational numbers कैसे define किया हमने? वो वाले numbers जिनको जब divide करो तो वो decimal तो दे रहा है, but that is not repeating and not terminating. ना ये खत्म हो रहा है, ये बढ़ता जा रहा है, बढ़ता जा रहा है, बढ़ता जा रहा है, और ना इनमें कुछ भी repeat हो रहा है. So बेटा non-repeating, non-terminating हो गए irrational numbers. Irrational number और rational number together, बेटा they form as real numbers. So irrational number plus rational number को मिलाकर हम real numbers बनाते हैं. एक unreal number भी होते हैं, imaginary भी होते हैं, है ना, complex numbers भी होते हैं, sorry, but that is not what I want to do for now. For now, I just want to go ahead and I want to stop here. And that is what the book also does. The book does not go further. The book does not talk about imaginary. The book stops here as of now. Clear है बेटा? Beta, good evening, everyone. Welcome to the second lecture of your basic maths for economic analysis. Beta, today we want to continue where we had stopped the last time. So if you remember, I had started with chapter 2 of AC Chiang. And in that chapter, I had gone ahead and I had started talking about what is an equation, what is a variable. ये सब छोटी-छोटी बातें हमने कर ली थी, है ना? अच्छा, today I will continue with that chapter and we will begin with the concept of sets. So please better write that down. The concept of sets. See, set हमने बहुत बारी class 11th, class 12th में भी सुना होगा, है ना? What is a set, बेटा? A set is a collection of distinct objects. बहुत important है ये definition समझना. It's very important to understand this definition. The first important thing that I want to focus here, beta, is collection. So I am collecting things, right? The second important thing is beta distinct, right? So it can distinct collection can be collection of numbers, collection of person, collection of food items, collection of anything, but they should be properly defined. So when I have a collection of items that is properly defined, but that becomes a set. Usko hum set bolte hain. Just for example, can I go ahead and say, I can say, na, write the set of first 5 natural numbers. ये लिख दिया मैंने. Write the set of first 5 natural numbers. तो क्या हो गया बेटा? 1, 2, 3, 4, 5. Beta, set is always represented using curly brackets. Okay? Set is always represented using curly brackets. This way of defining sets, it is called the method of enumeration. क्या कहते हैं इसे? Enumeration. Enumeration माने I am writing them like this. I am clearly telling what these numbers are. The second way of writing sets can be called as the method of description. बेटा, अगर आपने मेरी basic maths देखी होंगी, basic videos, please look at that playlist also. उसमें भी मैंने set theory explain किया है. That is from the point of view of class 11th and 12th. It will be useful for this, huh? तो वहां पे you will find that I did 2 things. One is called as the set builder format, and the other is known as roster format. हाँ, वही ये है. This becomes my enumeration now, and this becomes my description. So description में how can I write set beta? So I can say I want to define set A. ये set A कैसे हो गया? All elements. X इसका एक element है. Beta, what is an element? Ma'am, objects in the set are called elements. तो ये जो भी objects है ना, 1, 2, 3, 4, 5, ये सारे elements है. These are all elements. Huh? So I am saying X is such that X is first 5 natural numbers. So when I am writing X such that X becomes first 5 natural numbers, that is an enumeration. That is a descriptive way of telling this set. Clear हुआ बेटा? तो enumerative क्या हो गया? When you write it in terms of numbers. Descriptive क्या हो गया? When you write the description of the set. When you write the description of the set. अच्छा, ध्यान से समझना, हाँ बेटा. If I say give me set of top 5 cricketers, then beta these top 5 cricketers, they can differ. मेरी definition में it can differ for you. Like for example, I ask a maths teacher of a class that, sir, give me the top 5 students of your class. You know, the most obedient student of your class. He gives me a set of those 5 students. Now I ask the English teacher, ma'am, give me the first 5 students of your class. She also gives me the most loyal students of her class. But the point is, both of them will not give me the same students, even though I ask them the same question. So this is not well defined. मेरे लिए the best 5 students can differ as against you. So this is not well defined. Not well defined. But we want that a set should be well defined. हमें चाहिए कि एक set well defined हो. Just I ask you, give me the first 5 natural numbers. But you will also say 1, 2, 3, 4, 5. And I will also say 1, 2, 3, 4, 5. So the first 5 natural numbers will be the same. चाहे वो तुम्हारे लिए हो या मेरे लिए, whether it is for you or me. The first 5 natural numbers will remain the same. Are you getting it? That is a set. But this is not a set where it keeps on changing from one person to another. But now, I can define numbers in 2 ways. मैं numbers को ना 2 तरीके से लिख सकती हूँ. One can be called as the finite numbers. But the other can be called as infinite numbers. What is this called as, ma'am? This is called as finite numbers. This is called as infinite numbers. But what is a finite number? Finite, not numbers, my bad. You should write it as set. Huh? Finite set, infinite set. But what is a finite set? A finite set is always countable. An infinite set is non-countable. Jesse, if I ask you, give me the set of first 5 natural numbers. So, beta, you will be able to tell me na, that, ma'am, first 5 natural numbers are 1, 2, 3, 4, and 5. But, beta, if I tell you, give me the set of natural numbers. मैंने first 5 नहीं बोला. I just told you, give me the set of natural numbers. So, beta, in this case, you will not know what those natural numbers are. Ma'am, I will start from 1. 1, 2, 3, 4, 5, and so on. But I don't know where to stop. I don't know where the end is. So, whenever we talk about finite natural numbers, whenever I say first 5, first 10, it means that I can count those. They are countable. क्या होते हैं ये बेटा? Countable. मतलब इनके एलिमेंट्स को हम एक सीक्वेंस में रख के काउंट कर सकते हैं. I can count them. That, you know, if you're writing 5, I can count 1, 2, 3, 4, 5. If you are writing 10 elements, I can count 1, 2, 3, 4, 5, 6, 7. I can count on my fingers now. I can count them one by one now. So they are called countable. But a countable is also called as denumerable. Countable को और क्या बोलते हैं? Denumerable. Countable is also called as denumerable. Clear हुई बात? So, will it be right to say that a finite set is always countable? Yes, ma'am. I can always count it. This has 5 elements in it. You write another one, it will have some elements in it. I can count those. So, finite set is always countable, and a countable set is called as a denumerable set. क्या बोलते हैं इसको बेटा? Denumerable set. But here is the trick. When I talk about an infinite set, तो बेटा ये countable भी हो सकता है और non-countable भी हो सकता है. It can either be countable or non-countable. If countable, अगर हम उसको count कर पाएं, then बेटा it is called denumerable. And if non-countable, then beta it can be called as non-denumerable. Clear हुआ? Non-denumerable. Right? अब मैम countable कैसे हो सकता है? How is this countable? Infinite set जो होते हैं, it can be, I told you, it can be denumerable also or non-denumerable also. So how does that happen? We will talk about that in a while. But before that, and take that as homework, एक बारी पहले सोचो, give me the answer in the comment section. What do you think? How can an infinite set be countable? कौन सा वो infinite set है जिसे मैं count कर सकती हूँ? Which I can count? You need to go ahead and tell me that. Is that clear? Anyone who can tell me that? Let me give you an example. But when I say this set, x such that x is a positive number, तो infinite है, कितने भी positive numbers हम निकाल सकते हैं. I can write 1, 2, 3, 4, 5, 6. This is an infinite set. But beta, when I will write 6 numbers, suppose I write 6 only, till 6. You told me x such that x is a positive number. आपने बोला ऐसे number लिखो जो positive है. So I wrote from 1 to 6. So you could count now that there are 6 elements in it. But suppose I write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can count on my numbers because these are just numbers given here. तो ये हो गया countable but infinite set. क्योंकि मैं यहाँ पे बता पा रही हूँ, I can make a sequence of those. I can tell you that it will be 1, 2, 3 and so on. So because they can be counted one by one, इसको मैं count कर सकती हूँ अपने tips पे. that is a countable but infinite है, कितने भी आप elements add कर सकते हो. So it is a countable but infinite set. But let's take another example. Suppose I tell you J x such that x is between 2 and 5. अब तो मैम x कुछ भी हो सकता है. X can be 2, 2.1, 2.5, 2.8, 3.4, 3.7 and so on. This has decimals in it, na? Can I have 2.1 on my finger? No. Can I have 2.5 on my finger? No. So beta, this becomes uncountable set. Infinite to hai hi. There are infinite numbers between 2 and 5, na? 2.11111, ye bhi ek number hai between 2 and 5. 2.87432, ye bhi ek number hai between 2 and 5. 3.00009, ye bhi ek number hai between 2 and 5. You haven't told me I have to just write numbers. It can be an integer, it can be a real number. तो मैम कुछ भी तो लिख सकते हैं हम 2 और 5 के बीच में, right? So it becomes an uncountable set. What does this become? It becomes an uncountable set. I hope that this difference is absolutely clear to you. It can come in exam. But the next thing that I want to teach you here is called this sign, this Greek sign. And this Greek sign means belongs to. And the other sign is this beta. This means not belongs to. So just say, take an example, beta, I define a set. This set is first 5 even numbers, 2, 4, 6, 8, 10. So beta, can I say 2 belongs to this set? Yes, ma'am. 2 to ek element hai, I can see that. But beta, can I say that 3 belongs to this set? No, ma'am. 3 does not belongs to this set. So 3 set ko belong nahi karta hai. 3 does not belong to this set. Is this clear? Okay, beta. The next thing that you should understand is relationships between sets. Relationship between sets. Beta, 2 sets are said to be equal sets if they have the same elements. Kab hote 2 sets equal sets? They are called equal sets if they have same elements. Beta, order does not matter. Order se hame farak nahi padta. Order does not matter. It should just have identical elements. It should just have same elements in it. Let's take an example. So suppose I tell you set 1 beta. This is 2, 7, A and F. Set 2 lete hain. Beta, set 2 is 7, 2, F and 9. Right? So we are saying that set A has elements 2, 7, A and F, yeah, 2, 7, 9 and F, and the set B also has elements, beta. Now just see that they are not in the same order, but they are the same elements. Do you see here? This is 2, 2. Beta, this is 7, 7. Beta, this is 9, 9. This is F, F. They have the same elements. So we can say that S1 is equal to S2. Order does not matter. Clear? Achha. Now, the next definition that you have to understand, beta, usko bolte hai subset. Ma'am, ab subset kya hota hai? A set is called a subset of another set if every element of that set is in the other set. Kya bola maine? Ek set hai, ये दूसरे सेट का सबसेट तब होगा अगर इसका हर एलिमेंट, जो भी एलिमेंट S1 में है वो एलिमेंट S2 में है ही है. If this is the case, then I can go ahead and I can say that you have this as the subset. Is this clear? Is everyone clear with what I have said? So now let's take an example. But suppose I say that set 1 is 1, 2, 3, 7, 9. Set 2, beta, that is 3, 7. Can you see that set 2 का हर element set 1 में present है? Yes, ma'am. Every element of set 2 is present in set 1. So I can say set 2 is a subset of set 1. What can I say? Set 2 is a subset of set 1. Clear हुई ये बात? Everyone is clear with it? Okay. अब बेटा एक बार बहुत ध्यान से मेरी बात को समझने की कोशिश करो. बेटा suppose I say I have set 1 as 1, 2, 3, 7, 9. Set 2 as 3, 7, 1, 2 and 9. तो क्या set 1 set 2 का subset है? Yes, ma'am. Every element of set 1 is in set 2. So set 1 is subset of set 2. तो क्या set 2 set 1 का subset है? Yes, ma'am. Every element of set 2 is present in set 1. So set 2 is also a subset of set 1. Beta, when these two things hold together, कि 1 2 का subset है और 2 1 का subset है. When 1 is a subset of 2 and 2 is a subset of 1, then we can say that set 1 and set 2 are equal to each other. Is clear हुआ? So if set 1 is a subset of set 2 and set 2 is a subset of set 1, then set 1 is equal to set 2. Is this clear to everyone? Okay. Now, let us suppose I give you a set. मैंने ये set कैसे define किया? 1, 3, 5, 7, 9. But I am asking you how many subsets can you form? इसमें से हम कितने subsets बना सकते हैं? How many subsets can you form? So you have to try and understand that whenever I go ahead and I say a subset, तो subset इसका ही एक subset हो गया जिसमें सिर्फ 1 है. अगर एक set है A which only contains one element, 1. So 1 is contained in S. So A is a subset of S. Better consider 1 and 3. Suppose this is set B. This is also a subset of S. Better consider 3 and 5. इस C के भी सारे elements S में present है. All elements of C are in S. So can I say C is also a subset of S? Yes, ma'am. Better consider set D. 1, 3, 5, 7. All elements of D are also in A. That is also a subset. So जो भी मैं pair, triplet, quadruple, जो भी मैं बना पा रही हूँ, but all of these are subsets of the set S. ठीक है? But suppose there is a set E which has 1, 2, 3, 4. Sorry, 1, 3, 5, 7, 9. So बेटा E भी तो इसी का subset है because all elements of E are present in A, no doubt. They are equal to each other. But E is also a subset of A, ना? यही हमने यहाँ बताया. That this was a subset of this and this was a subset of this. So बेटा E itself is a subset of A. Clear हुई ये बात भी? अब बहुत ध्यान से समझो. एक और subset भी होता है. There is another subset that we have. What is that subset? That subset is basically called a null set. Null set is a subset of every set. Null set क्या हो गया? Null set माने no element. So null set is a subset of every set. ऐसा set जिसमें एक भी element नहीं है, तो वो भी तो subset हो गया. So this is two properties I want to write down. But a null set is a subset of every set, and that set itself, मतलब जिसमें सारे elements आ रहे हैं, that is also a subset of every set. ये अगर मैं यही set बना दूं, तो ये भी तो इसका subset होगा. So S, that means the entire set is also a subset of itself. So बेटा two things, दो प्रॉपर्टी हम समझने की कोशिश कर रहे हैं. अगर मैं आपको एक सेट दे दूं, if I give you a set 1, 2, how many subsets can be there? मैम एक तो इसका null अपने आप में एक subset है. Null set is a subset of every set. मैम दूसरा A itself is a subset of itself. मतलब अगर मेरा दूसरा सेट भी 1, 2 ही हो, it will be a subset of this. And मैम तीसरा क्या हो जाएगा? तीसरा अगर मेरा सेट सिर्फ 1 है, if my set is only 1, so 1 is contained within this big set. So 1 is a subset of 1, 2. And similarly, ma'am, 2 is also a subset of 1, 2. So, but if my bigger set is 1, 2, I am able to make 4 subsets out of it using the property that null is a subset of every set. A is a subset of set itself is a subset of every set, and बीच के दो भी मैंने बना दिए. So, beta, how many subsets could I create? Ma'am, I could create 4 subsets. है ना बेटा? Now, बहुत ध्यान से समझना है. The property that we have is that the number of subsets that can be created, beta, they are 2 to the power n, where n is the number of elements. तो इस A में कितने elements थे? How many elements were there in A? Ma'am, I could see that there were 2 elements in A. So how many can I create? Subsets 2 to the power 2, that means 4 subsets. On that same basis, but if I go ahead and I see here, there are 5 elements now. There are 5 elements in this. So how many subsets can I create? 2 to the power 5. That means 32 subsets can be created. Clear, Ruiba? 32 subsets can be created. But now I want to tell you what is a proper subset. A proper subset is any non-equal subset. Matlab, I have set A, which is 1, 2, 3. Suppose I tell you that E is 1, 2, 3. So E भी subset of S, तो E is a subset of A, na? Because E का हर element A में present है. But ma'am, E is also equal to A. So this is not a proper subset. This is not a proper subset. But let's take the set G. G is 1, 2. G के हर element A में present है. But G is not A itself, na? G is less than A. So, but G is a subset of A. This is a proper subset. They are not equal to each other. So, G is called a proper subset. It has elements less than A. उसके पास सारे A के elements नहीं हैं. But G का हर element A में present है. So, G is a subset of A. It is called a proper subset. But E is not a proper subset because E and A are the same only. They are equal. Clear हुई बात? Okay. Next, beta, suppose I tell you that this and this, are they equal? No. बेटा ये एक ऐसा सेट है जिसका जो एलिमेंट है वो 0 है. ये नल नहीं है. This is not null. This is a set, but its element is 0. And बेटा ये एक ऐसा set है जिसमें there is no element. It is a null set. So null set and set with 0 element are different. This is a set which has 0 element in it, but it is not empty. It is a non-empty set. And this is a set which has no element in it. So it is an empty set. Clear? One last definition I would like to do here, beta, for sets. That definition, उसको बोलते हैं बेटा disjoint sets. बड़ी simple है. Word में ही present है. Disjoint. That means not joined. That means nothing is common. So what is a disjoint set? बेटा वो sets जिनमें कुछ भी common ना हो, which have nothing common between them, they are called as disjoint sets. Clear हुआ? Any set which have nothing in common between them, they are called as disjoint sets. लिख लेते हैं बेटा जरा. Suppose set A is 1, 2, 3. Set B is 4, 5, 6. But do they have any common element? No. Nothing is common between them. So if there is nothing common between them, तो हो गए ना disjoint. Nothing is common between them, ना? So they are automatically disjoint sets. Clear हो गई बात? So this is lecture number 2 from ACGM chapter 2. In the next class, beta, we will do operations of set. I will try to come a little more often. थोड़ा break ज़्यादा हो गया था. I was doing classes with your semester 3 students, optimization classes. But now we will do more lectures on these basic maths. We will try to finish these. And we will also try to discuss the back questions of ACGM. ठीक है बेटा? तो जो भी पीछे के questions है ना, exercise questions, after we finish the chapters, we will also discuss those in the live lectures. Okay, beta, thank you so much for your time. I will meet you again with. We have A minus B. If I have to find A minus B, then it's like this. I have this set A, I have this set B, and I have to subtract the part of B from A. So if I just remove what part comes in A from B, that means I have to just remove this part of B from A. So I will be left up only with this part. This is that part of A which is after B has been removed. So I want those values of X such that it belongs to A, but it should not belong to B. So if you see this, then can I write that this A minus B will be A minus A intersection B? Because A intersection B was the area which was common between A and B, which means it would have belonged to B also. I don't want B, so I just remove this part from A, and the remaining part of A that I get, it's not common with B, so that would be the correct thing to do in that case. So A minus B can also be written as A minus A intersection B. Now in this case, if someone tells you that A and B are disjoint, they don't have anything in common, then I know that this will be A minus 5. There is nothing common between A and B. There are two different sets, so it will simply be A. A minus B will be A. If someone tells you that A and B are independent events, then mathematically speaking, the definition of independence is that A intersection B should be A into B in terms of probability. Probability A intersection B is probability A into probability B. So if someone asks you what is the probability that it occurs in event A and not in B, something like this, I will say it is probability of A minus probability of A intersection B. But if A and B occur independently, then I will simply say probability of A minus probability of A into probability of B. So I will keep altering my answers according to the information given to me in the question. If they tell me that they are independent, then A intersection B will be written as A into B. If they tell me that they are, disjoint, mutually exclusive, they don't have anything in common, then I will simply put their intersection as 0. And accordingly, I will get my answer. So that's the next thing, that A minus B is such that it belongs to A, but it does not belong to B. Now, we want to go ahead and do something which is called as complements.
For complements, we introduce the concept of sample space. Sample space is all possible outcomes. So, for example, when I just toss my coin once, my sample space can be head or tails. That's my sample space. If I toss it 2 times, then my sample space will be HH, PH, HT, and TT. This will be my sample space. If I toss it 3 times, it will be HHH, HTH, HTT. Are you getting it? There will be 8 such events. That will be my sample space. All possible outcomes together formulate a sample space. When we draw the Venn diagram, a sample space is usually drawn with a rectangle or a square. This is my entire set of possibilities. Now, A is one event. So maybe, if sample space is tossing 3 times, then my A event can be getting hit exactly 2 number of times. That's an event A. This event A will only have some of the part of the sample space. So, this event A, no. What you can say is so basically we can say that the sum of the exhaustive events, that is the sample space. That's how we can define sample space. So sample space is all samples together. Exhaustive events is what exhausts the entire sample space. So sum of exhaustive events is sample space. So we can say that this together are exhaustive events. And if I write it like this, then it is a sample space. That's the only difference. Now, when we go ahead and we say A complement, then A complement is everything in the sample space except A. So it's like this. Everything except A in the sample space. So in a way, what I can go ahead and I can do is I can simply say that A complement would be sample space minus A, or A plus A complement will be sample space. Now it depends. What exactly are you trying to find in your answer? So let's say that A is an event that exactly 2 heads occur. And let's say B is an event that 1 or more head occurs, right? Although this would be a different case altogether. So in this case, if you notice, A is that exact, so this is tossing a coin 3 times. So A is an event that exactly 2 heads occur. So I'm going to have H, H, T, T, H, H, T, H, T, H, like this, 3 events. B is 1 or more heads occur. So this will have 7 out of 8. It will not include T, T, T. Otherwise, it will include all 7 outcomes that at least one time head is coming. So ideally in this is my B. This is either head happens 1 time or 2 times or 3 times. This is my A, that only 2 times. So in this case, A is completely contained within B. So I'm saying A is a subset of B. So if A is a subset of B, then if you want to find B minus A, it would be this. So ideally this says 1 or more head, this says 2 head. So B minus A will have those outcomes which have exactly 1 head or 3 head, right? If I want to go ahead and find B complement, then it would be this part. But if I want to go ahead and find A complement, it will include some part of B also, because then I'm going to go ahead and subtract from A. But anyways, whether I find A complement or B complement, note that B plus B complement will also be sample space and A plus A complement will also be sample space. This still remains true, that you have a set A and its complement together, it will always give you sample space. Even if A is contained within B, does not matter. If I find the complement of A, it will be all this region now. So A plus A complement is also the entire sample space. And instead, if I find complement of B, it would still be all the region. So it will be here. And it will be all the region. B plus B complement will also be the sample space. So is it correct that exhaustive events are subsets of the sample space? Ideally, yes, you can say it in a way, because when we talk about exhaustive events, they are the events which exhaust the entire sample space. This is how we usually frame it grammatically. So you can say that all exhaustive events together combine and form the sample space. Okay. So here I was saying that this is one thing, that A is contained within B. But what if someone asks you something like this? This is my sample space. This is event A and this is event B. And I want to find, so I want to go ahead and find out the complement of A intersection B. So I want to find A intersection B complement. It would be, A union B complement. A union B complement, this is going to be this region. Now, by definition of A union B, we said that A union B is that it happens at least one. So what will be its reverse? What will be sample space minus A union B? That it happens never, none of the times. Because union tells me that it happens at least once. So this is not happening in A, neither is it happening in B, which means it is not happening any time. That will be the complement of A. That will be of A union B. So you have to be very thorough with what the question is going to ask you. There are many laws related to complements also that we will just see. Now just talk about the algebra of sets. The first is called commutative law, very, very simple. Whether I find A union B or B union A, it's the same thing. Whether I find A intersection B or B intersection A, it's the same thing. Whether I first find A union B, then union C, or B union C, then union A, it's the same thing. So it's like this. I have this A, B, and C. So whether I first find B union C and then I add A to it, or I first find A union B and then I add C to it, it's the same thing. That's the basic associative law. The same is true for intersection also. Then you have distributive law. This is interesting. See that when I find A intersection B union C, it is equivalent to A intersection B union A intersection C. And how can you see this? So you can go ahead and you can formulate A, B, and C. B intersection C means I have to take common between B and C, which means this area. And if I have, I'm doing this one. B intersection C means I have to take common between B and C. So I took this area. And now I have to take its union with C, with A. So which means that I will include everything of A with it. This means that it happens in both B and C. This means that either it happens in A or it happens both in B and C. So read out the sentence now. Either it happens completely in A or it should be both B and C. So it's like this. If in exam, you're given many criteria, suppose the question says that in order to get through the entrance exam, the following must be true. 1, you must have marks plus 60% and you must have top 10 rank, or you must have 90 percentile in undergrad. Something like this. So when I talk about this condition, I have to fulfill both of them. This and this. So B and C or 90%. That is what this means. Now when I open it, I go ahead and I take this union here, this union with A and C, and then I find the common area between the two. I can go ahead and try this here also. So for example, if I have A, B and C, A union B will be this. And A union C will be this. Let me mark it with a separate color. And now I'm checking what is the area which is common between them, the area which gets colored with both of them. That is going to be the same thing. So you will never get this part. This will not come and this will not come. So it will be the same thing, that either this criteria of A should be satisfied or both B and C together should be satisfied. So this is your distributive law. Then you have your complementary law, that A and A complement together make the sample space. There is nothing common between A and A complement, so their intersection will be null. And then you have that A union with sample space is the sample space, and A's commonality with the sample space, that is going to be your A. So now you can have this difference law. This is A minus B is A intersection B complement. You can just keep proving these things. So you have A, you have B. What is B complement? B complement is everything except B. So it is going to be here. Everything except B. This part. And now I want to find its commonality with A. So what area will I get? Only this part is common with A. And if I go ahead and instead find A minus B, suppose I now just find A minus B, I get the same answer. This is entire A, and I'm subtracting the part of B from it, so I will only get this much part. So A minus B can be written as A common with B complement. Similarly, A minus B can be written as A minus A intersection B. And this can also be written as A union B, everything A between A and B, minus you remove the B part. So you will get only that A which is not common with B. Now you have something which is known as De Morgan's law. These two laws are important. So the De Morgan law states that A union B complement is A complement intersection B complement. Again, for us, it is enough to just see through the Venn diagram. So we will try and see that. So this is A, this is B. I find their union, which means the entire area. And then the complement of that, which means everything except A union B. This part. And the other says A complement. So this is A, this is B. A complement means everything other than A. And B complement means everything other than B. And if you see what's the common between the two where both the colors are coming, you will see exactly this region. Right? So same thing. Either you find A union B complement or A complement intersection B complement, you get the same answer. Now this is the reverse of it. So here what has happened is, instead of union, I have taken intersection, and instead of intersection, I have taken union. You can try to prove it yourself through the Venn diagram. Then we have something which is known as the involution law, which says A complement complement is A. So this is very simple. See, A complement complement is nothing but, what's A complement? Sample space minus A complement. So this is going to be complement of the sample space minus complement of A. Now just think about this. When I go ahead and I find the complement of the sample space, it's like saying that there is nothing left. It's the opposite. Sample space consisted of everything. If I'm going ahead and finding the complement of sample space, I will be left up with a null set. There is nothing left with me. And from that null set, if I subtract the complement of A, I should be only left up with A. So A is just going to be, so in a way, the sample space is consisting of only two parts, A complement and A. So if I just exhaust the entire sample space, I have two parts to it, and I'm subtracting A complement from it. So I should just be getting A from it. In order to prove this using Venn diagram, you can just try it. This is A. The complement of A will be this. It is sample space minus A. And then I am again finding the complement of this. So I will be just left up with whatever is inner to this, which is again A. So this is what the basic rule says. A union A. Everything between A is common with A, so it's A. And A intersection A. Everything is common between the same set, so it will be A. There are two additional definitions that you should know. One is called a ring. A ring is non-empty class of set which is closed under formation of infinite union and differences. So anything is called a ring if it satisfies these two things. If A belongs to ring and B belongs to ring, this is only true if I find their union and it belongs to ring, and I find their difference and that also belongs to ring. Let me give you an example. Suppose A is a set of 1, 2, 3, 4, 5, and B is a set of 4 and 5. So A union B will be 1, 2, 3, 4, 5. A minus B will be 1, 2, 3. If I define a ring, which is first 10 natural numbers. Suppose I say this is defined by first 10 natural numbers. A belongs to that. B also belongs to that. A union B also belongs to that. A minus B also belongs to that. All of them will belong to first 10 natural number set. So then R is called a ring. So it is called a ring if you have union and differences possible. Those union and differences, if they can be found within that set, then it's called a ring. The other definition is a field. Field basically is by forming union and complements. So same, let's define A as 1, 2, 3, 4. Let's define B as 7, 8, 4. So let's define our field as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First 10 natural numbers. What will be complement of A? Complement of A will be 5, 6, 7, 8, 9, 10. I have defined my sample space also with first 10 natural numbers. So complement of A will be 5 to 10. A complement will belong to F. A belongs to F. B belongs to F. B complement belongs to F. So if all possible union and complement belongs to a particular set, then it is called a field. It's not very useful for you. You will appreciate field and ring only when you do your masters in economics. In that statistics class, when you will formulate the field, you will understand why they are important. But for now, this definition will suffice. So we have done what is sample spaces, the totality of all possible outcomes of an experiment together constitute the sample space. We did what an event is. So event is just the outcome. Like, you know, I throw a dice, I toss a coin, right? So that's my event. And we have various statements that you may want to understand. The first one is called at least one of the two things. So whenever you see at least, you will find union. At least find the probability of at least one head. Find the probability of at least the sum being 5. Whenever you see at least, it means union. Whenever you see the probability of both, find intersection. Neither nor, find intersection between the complements. So when I say neither A nor B, it's this. This is my sample space. This is A, this is B. I want neither A nor B. So it should be this area. Neither A nor B. So I can say that because I want neither A nor B, it is sample minus A union B. But if I find A and B, then the complement of A will be this. Complement of B will be this. And the common area between the two will be this. So this is exactly the same thing. So in terms of probability, you can say that, so neither A nor B, it can be written as probability of sample minus probability of both A and B, either A or B. And probability of sample, all the events together. It's sum of exhaustive events. So probability of sample will always be 1. So it is 1 minus probability of A union B. So if someone says find probability that neither A nor B occurs, it will be 1 minus either A or B occurs, and it will be 1 minus probability A union B. If you want, find this, or simply find the probability of A complement intersection B complement. I find this easier, right? So either A occurs and B doesn't occur. So A is occurring and is represented by intersection. B is not occurring, so complement of B. Not more than one of the events occur. This will also be coming in exam. So they will ask you, find what's the probability that, either A wins and B loses, or B wins and A loses in a gamble. Both cannot win together. So which means at any point of time, one event can occur. If A occurs, then B cannot occur. So I have to put an and in between the two. A occurs and B doesn't occur. So A wins and B doesn't win. Or I can have A intersection common union B. So A doesn't win and B wins. Sometimes they will say that find that not more than one event occurs, which means either one of them occurs or none of them occurs. So sometimes you may want to add that none of them occurs. It depends on the question and the statement. So they may ask you what's the probability that A wins and B loses and B wins, A loses, or what's the probability that not more than one person wins. So not more than one person means both can lose also, but more than one will not win. A will win or B will win or none will win. So accordingly, you will formulate your sentences, right? If A occurs, so does B. So occurrence of A is sufficient to tell us that B will definitely occur, which means A must be a subset of B. It must be included in B. So A is a subset of B. I've tried to include as many sentences as possible. Event A and B are mutually exclusive. It means they have nothing in common. So fine. Now let's talk about some of the properties of a probability function. The first property is that your probability should always be greater than or equal to 0. Probability of sample is 1. And probability of unions, whenever you see disjoint events, the probability of unions is just the sum of individual events. It's like this. Imagine this is event A, B, C, and they have nothing in common. So if you ask me what is A union B union C, I will say A union B union C, which means I will add A plus B plus C. So if you ask me what is the probability that one of them will occur, but there is nothing common between them, I will simply add the probability of individual events. Probability of A1 plus A2 and so on. Just add them. This is only true if they're disjoint, if there is nothing common between them. So for mutually exclusive event, probability of A union B is probability of A plus probability of B. Otherwise, we will write probability of A union B as A plus B minus A intersection B. So we will subtract the part which is coming common between A and B. Why? Because imagine that I added everything from A. This is everything from A. This is everything from B. But this part, this is getting added twice. So because this came twice, I must subtract it at least once. So I subtract this part once and I get A union B. But if they are disjoint, they have nothing in common, this will be 0. So it will automatically give me PA plus BP. What if they're independent? Then probability of A intersection B will be A into B. So we will have probability of A union B as PA plus PB minus PA PB. Right? So this is what can happen in this case. So now, if B is a subset of B, just correct this. I think this should have been if B is a subset of A. If B is contained within A, then it is asking what is common between A intersection B complement. We know it's this area. So it will be A minus B. sometimes this may come in exam. This is when A, B, and C, all three are involved. So probability of A union B union C is A plus B plus C minus A intersection B, B intersection C, C intersection A plus A intersection B intersection C. If you want, please try and prove this using Venn diagram. Add A to B, then add C to it. See that these will be coming twice, so we are subtracting it once. But when we subtract, this will be subtracted, so we add this back again.
So बेटा हमने already sets तो पढ़ लिया है ना? Set क्या था? It was a group of elements, right? Now from set, I want to go ahead and I want to talk about something which is known as a Cartesian product of sets. Cartesian product of sets. So you already have two sets with you, right? Now from these two sets that you have with you, you want to go ahead and you want to form something which is known as a Cartesian product. What is the Cartesian product? A Cartesian product basically helps you to get one element of set A mapped to all elements of set B. एक element हम लेंगे set A का और उसे हम मैप करेंगे बाकी सारे एलिमेंट सेट बी के. फिर नेक्स्ट एलिमेंट लेंगे सेट ए का, उसे मैप करेंगे सारे एलिमेंट सेट बी के. सो व्हेन वी गो अहेड एंड वी डू दैट, दैट इज नोन एज कार्टेशियन प्रोडक्ट ऑफ सेट्स. सो जस्ट थिंक अबाउट दिस. आई हैव ए एंड ए इज रेड comma blue. This is a set. And then I have B. B is B, comma C, comma S. This is another set beta. If I want to go ahead and I want to ask how many pairs can you create? कितने pairs हम बना सकते हैं इसमें से, है ना? तो सब ये पेयर, जैसे अगर मैं बोलूं कि बेटा ये बैग के कलर्स हैं और ये बैग के अंदर जो ऑब्जेक्ट्स चल सकते हैं वो हैं. अब रेड बैग में बी ऑब्जेक्ट जा सकता है, रेड बैग में सी भी जा सकता है, रेड बैग में एस भी जा सकता है, ब्लू बैग में बी ऑब्जेक्ट जा सकता है, ब्लू बैग में सी भी जा सकता है और ब्लू बैग में एस भी जा सकता है. So how many pairs of colored objects can be made from these two sets? What will you say? You will say, ma'am, red bag can be with B, right? Red bag can be with C, right? Red bag can be with S. Then you can say that a blue bag can be with B, blue bag can be with C, and blue bag can be with S. These are the 6 distinct objects that you can get. This is called as Cartesian product. इसको हम Cartesian product बोलते हैं. So let us write down the formal definition of this. Definition. So what will be the definition, beta? I can say that given two non-empty sets P and Q, the Cartesian product P cross Q is the set of all, बेटा बहुत इंपॉर्टेंट वर्ड है ये, ordered pair. Ordered pair का क्या मतलब है? That if I am doing P cross Q, then I will first write the element of P and then the element of Q. तो order सही होना चाहिए. It should be an ordered pair, right? So ordered pair of elements from P and Q. ठीक है? So देख लेते हैं एक बारी. What am I saying? P cross Q क्या हो गया? Element of P first and element of Q later, है ना? तो P should belong to P and Q should belong to Q. ध्यान से समझना. यहाँ पे this was given to me ना, A and B. So beta, when I did A cross B, when I did A cross B, तो A का element पहले लिखा गया है हर जगह पे. I have written the element of A first, and I have written the element of B later. This is B now, so I have written the element of B after that. So that means it is an ordered pair. I am writing them in a particular order. एक order में उनको लिख रहे हैं. So an ordered pair means you should first write the element of P and then you should write the element of Q. Clear हुआ? Okay. So now we want to go ahead and we want to write down some important remarks. So लिखो please बेटा, remark number 1. देखो, दो ordered pair equal तब होते हैं अगर corresponding first element corresponding अगर उनके corresponding elements equal हो, है ना? So for example, अगर मैं कह रही हूं 3,1, ये एक ordered pair है. This is an ordered pair. And then beta I'm saying 1,3. ये भी एक ordered pair है. This is also an ordered pair. Right? This has elements 3 and 1 in it. This has elements 1 and 3 in it. This is not equal. ये दोनों equal नहीं हैं. Why? Because its first element is 3. इसका पहला element 3 है. And its first element is 1. इसका पहला element 1 है. So the first element are not the same. So these two are not equal ordered pair. But अगर ये set होता ना 1,3, beta this curve shows me that this is a set. So if this is a set 1,3 and this is a set 3,1, then they are equal. Because set only considers element. Set is not an order. Set को order से कोई फर्क नहीं पड़ता. Set को सिर्फ element से फर्क पड़ता है. But ordered pair को order से फर्क पड़ता है. Ordered pair is affected by the order. So what is my remark that I want to give you, beta? That two ordered pair are equal if and only if the corresponding first elements are equal and second elements are also equal. Is that clear? एक क्वेश्चन ले लेते हैं इस पे. Let's take a question. So question. Beta, suppose I am saying that x plus 1, comma, y minus 2 is equal to 3, 1. X plus 1, comma, y minus 2 is equal to 3, 1. Beta, ये ordered pair है. So इसका first element इससे equal होना चाहिए क्योंकि ये equal लगा हुआ है. और second element इससे equal होना चाहिए क्योंकि equal लगा हुआ है. So this implies that x plus 1 should be equal to 3. मतलब x आ गया 3 minus 1, that means 2. And it means that beta y minus 2 should be equal to 1. That means y will be 1 plus 2. It means y will be 3. So when they are equal to each other, it means this thing. That's my first remark. I hope this is clear. You have to go ahead and you have to ensure that the order is maintained. Okay, remark number 2. Okay. So suppose beta you have a set A and the number of elements in set A, this is P. You have set B and number of elements in set B is Q. So set A है, A में P elements है. Set B है, B में Q elements है. तो बेटा A cross B में कितने elements होंगे? P into Q. A cross B will have how many elements? P into Q. ठीक है? एक example ले लेते हैं. Question लिखो. Please write down the question. So P is given to you as A, B, and C, right? Q is given to you as R, right? Form the set P cross Q and Q cross P. ये दो sets बनाना है आपको. P cross Q and Q cross P. Also check whether the two are equal. Is P cross Q and Q cross P equal or not? You have to check that also. है ना बेटा? अच्छा, let's start. So now just think. P has how many elements? 1, 2, 3. Q has how many elements? 1. So number of elements in P, they are 3. Number of elements in Q beta are 1. So P cross Q में कितने elements हो जाएंगे? 3 into 1. That means you will have 3 elements. Clear? अब P cross Q निकालो. Find out P cross Q. So order में रखना है. P cross Q has to come in the order. So you will take A, comma R, B, comma R, C, comma R. The first element will be of P because we have to see that this is P cross Q. So P का element पहले रखना है. We have to keep the first element of P. So beta, this will be P cross Q. I hope this is clear to you. Now, you just write this inside a set. Now find out beta Q cross P. So first element will be of Q. So R, comma A, R, comma B, R, comma C. This will be Q cross P. Are the two equal to each other? They are not. So इसका element R, A, R है और इसका element R, A है. ये दोनों same नहीं होते हैं. Remember? That is my first remark. The two are not equal to each other. So therefore, P cross Q is not equal to Q cross P. These two are not equal to each other. I hope that is clear to you. Okay, beta. Now, I want to go ahead and I want to talk about remark 3. Listen to me. Suppose A and B, you have these two as sets. And one of them is infinite set. A और B दो सेट है और इसमें से एक सेट इनफाइनाइट सेट है. If that is the case, तो बेटा A cross B automatically infinite हो जाएगा, है कि नहीं है? Just take an example. Suppose I tell you A has its first 5 natural numbers. A is first 5 natural numbers. Beta B is all natural numbers. तो A में कितने एलिमेंट हुए? 5. A is first 5 natural number 1, 2, 3, 4, 5. बेटा B में कितने एलिमेंट हुए? Infinite. We don't know how many natural numbers exist. है ना? There are infinite natural numbers. So बेटा number of elements in A cross B कितना होता है? Number of elements in A into number of elements in B. So anything into infinity will be what? Infinity. तो जब हम इनका कार्टेशियन प्रोडक्ट निकालेंगे, when we will find the Cartesian product, that will be infinite. Is this clear? Okay. Wait, a last remark. Remark 4. कभी कभी पेयर की जगह ट्रिपलेट भी निकाल सकते हैं. So there is something which is known as ordered triplet. कुछ नहीं करना. If it is a triplet, तो मतलब 3 एलिमेंट्स रहे होंगे. So which means that it is something like A cross B cross C. So suppose I tell you A is 1, 2. Beta B is 4, 7, 9. C is 6. So A cross B cross C means what? You will take the first element of A, then B, then C. So you will get this as 1, 4, 6. फिर A का फर्स्ट एलिमेंट, B का नेक्स्ट, इसका नेक्स्ट 6, 1, 7, 6. फिर 1, 9, 6. फिर 2, 4, 6. 2, 7, 6. And 2, 9, 6. So order has to be maintained. What is my order? My order is that the first element should be of A, then B, then C. A, B, C. A, B, C. And there are 3 elements in one bracket now. So it is called a triplet. It is called a triplet. Clear ho beta? Okay. Next question, please. Take the next question. So you have A, beta, and A is 1, 2, and 3. And you have B. as 3, 4, and you have C as 4, 5, and 6. ठीक है? Question लिखो. Find A cross B intersection C. Find A cross B intersection C. है ना? Let's start this. So, beta B intersection C, what will that be? Take common between B and C. So, B intersection C will be 4. Only 4 is common between the two, na? So, I can name this set as D. Now, my set D is only 4 and set A is 1, 2, 3. Now, I have to do A cross D. इसको मैंने D बना लिया. So the first element that should come should be of A, है ना? So A का element हो गया 1, D का element है 4, A का element 2, D का element 4, A का element 3, D का element 4. So beta you will go ahead and you will get A cross D like this: 1, 4, 2, 4, 3, 4. Okay. Okay. Take the next question. So it says P is 1, 2. Find P cross P cross P. So you have to find P cross P cross P. Okay. So that means beta first element, this is P cross P cross P. है ना? So you will start with the first element of the first P, first element of the second P, first element of the third P. Then keep this here only. Keep this first element as it is, second element of this, and second element of this. Then keep this only, second element of this and first element of this. All possibilities, beta. Jitni bhi possibilities hain, you should write all of those down. Then you can take first element of this, combine it with the first element of this and the second element of this. Then take the second element of the first P, combine it with the first element of the second P and the first element of the third P. Second element of the first P, combine it with first element and second element. Second element, combine it with the second element and first element. Second element, combine it with the second element. All these will be your answer. Beta kitne elements hone chahiye? We have already done the formula. So the number of elements in P cross P cross P will be number of elements in P into number of elements in P into number of elements in P. So this is 2 into 2 into 2, which means 8. So beta there will be 8 elements in your P cross P cross P. Okay. Yes, beta, we will try and cover the entire maths of the basic maths. I will try and cover entire that. So let's see the pace. It is going to be there on every Monday, and we will move on to integration also, and we will move on to log also. Don't worry. Log, integration, differentiation, ye sare topics bhi we will cover. And at the end, I will be talking about tips and tricks also. So, you know, once try to give the tests that I keep after every chapter. So what tests there, those tests will be discussed in the video session that we are doing. Like we have already done a test on set theory. Then once we finish the relation and function, I will be doing a test on relation and function also. So try to catch up with those tests also. They will be useful. ठीक है, अगर वो टेस्ट हम स्पीड से कर पाएंगे, it will help you gain the speed also. Okay, let's go to the next question now. So my next question is, if R is set of all real numbers, right? What does R cross R represent? And what does R cross R cross R represent? Okay beta, these two questions you have to understand. तो ये कह रहा है R is set of all real numbers. Real numbers मतलब कि it's my entire number line. माइनस इंफिनिटी से लेके इंफिनिटी तक सारे नंबर्स, दैट इज व्हाट R is ना. इट इज ऑल रियल नंबर्स. सो बेटा R क्रॉस R मतलब क्या? आई एम मेकिंग अ कार्टेशियन प्रोडक्ट. सो सपोज R में एक एलिमेंट है 1, 2, 3. दीज आर ऑल एलिमेंट्स ऑफ R. 1.5, 1.7 ये सारे एलिमेंट्स है R के. दूसरे R के भी यही सारे एलिमेंट्स होंगे. सो R क्रॉस R विल बी 1,1, 1,2 ऐसे एलिमेंट्स बनेंगे R क्रॉस R के, राइट? सो R क्रॉस R विल बी, how can I write that mathematically? Beta, I can write R cross R will be X comma Y such that X and Y belong to real numbers. So I have two elements now. Two elements मतलब क्या हो गया? If I were to plot this diagrammatically, then those two elements would have meant कि एक लाइन यहां से निकल रही होगी. ये देखो यहाँ पे एक नंबर, ये देखो एक कोऑर्डिनेट देखो, ये 1,1 है. सो ये भी एक रियल नंबर है और ये भी एक रियल नंबर है. तो व्हेन आई से R क्रॉस R, it means that I have these xy such that both x and y belong to R. What is this? This is a two-dimensional space. ये एक 2D space हो गई. This can come in exam. बहुत important MCQ है. So if R represents the real numbers, R cross R represents a two-dimensional space. Similarly, if I go ahead and I do R cross R cross R, तो क्या हो जाएगा बेटा? 3-dimensional space हो गई. ये सारे real numbers हैं, ये भी सारे real numbers हैं और ये भी सारे real numbers हैं. So if imagine your room, it's 3D. Now take a point in the room. It has some value of x, y, and z. It has this x, comma y, comma z, such that all three are real numbers. So to be very precise, R cross R cross R is nothing but it is going to be your coordinate. I hope this is clear to you. ये 3-dimensional coordinate और वो 2-dimensional. So that is what you can write, that this is a 2D coordinate in the real space and this is a 3D coordinate in the real space. Okay, write down the next question, please. So the next question that I have is the following. If A cross B, it is with a P comma Q, P comma R, M comma Q, M comma R, find A and B. A cross B is already given to you. Cartesian product दिया हुआ है इस केस में और वो ये बोल रहे हैं कि A और B निकाल. तो बेटा ये A cross B मतलब it's an ordered pair. तो जो भी फर्स्ट एलिमेंट आ रहे होंगे वो A के होंगे. फर्स्ट एलिमेंट क्या आ रहे हैं? P and Q. मतलब ये A रहा होगा. एंड जो भी सेकंड एलिमेंट आ रहे हैं वो B के होंगे. So what are the second elements that you see? Q and R. So beta B would be definitely Q comma R. So if you are given the Cartesian product, अगर Cartesian product दिया हुआ है, you can go back and you can find the elements also. Is this clear? ठीक है. इसके साथ हमारा ये first topic relation and function का, which is Cartesian product, it is over. And now in the next class, I will start with relations. ठीक है. कुछ questions बेटा, homework, practice. Question number 1. You must practice this, okay? X by 3 plus 1, comma y minus 2 by 3 is equal to 5 by 3, comma 1 by 3. Find X and Y. That's your first question. Question number 2. G is equal to 7, comma 8. H is equal to 5, comma 4, comma 2. Find G cross H and H cross G. This is your second question. ठीक है बेटा. Question number 3. If A and B are non-empty sets, then A cross B is also non-empty set with pair XY such that X belongs to A and Y belongs to B. You have to tell me, beta, whether this is true or false. This is the third question. ठीक है जी? अच्छा, last question एक लिख लो. Question number 4. The Cartesian product A cross A has 9 elements found to be -1, 0 and 0, 1. Find the set A and remaining elements of A cross A. The Cartesian product A cross A has 9 elements, among which are found to be -1, 0 and 0, 1. Find the entire set A and the remaining elements of A cross A. This is your last question. So let us start by understanding what are relations. Relations, okay? बेटा, for relation to be built, खुद देखो, एक normal life में समझो, whenever you want to go ahead and build a relationship between two people, what do you want? You need two people. It cannot be a one-sided thing, right? Same is with maths. If I want to work with relations, I need two sets. So let us go ahead and consider two sets. First I'm saying is set P and other set is Q. We know that we write set like this now. So set A can have elements beta A, B, C, and so on. Beta set Q can also have elements, let's say some names, Ali, Bhanu, Binoy, Chandra, Divya. These are two sets that I have. Now tell me something from our last class that I taught you. Beta, what is a Cartesian product? We all know. Sorry. If we were to go ahead and make a Cartesian product P cross Q, what would you have done? Beta, you could have taken the first element of this and mapped it to each element of Q. Then you would have taken the second element of this and mapped this to each element of Q. Then you would have taken the third element of this and mapped this to each element of Q. And in that ways, you would have got 15 numbers in your 15 elements in your Cartesian product. You remember this? We did it in the last class. So if I were to create a Cartesian product, it would have looked something like this, beta. A comma Ali, A comma Bhanu, and so on. ऐसे करते जाते. Then B comma Ali, B comma Bhanu, and then you could have mapped B to everything. And then beta C comma Ali, C comma Bhanu, and you could have mapped C to everything. So you would have got 15 elements. Now today, I want to take one step ahead and I want to define a relation. So let me first write the formal definition. To likho, a relation R. It is from non-empty set A to non-empty set B. So I have a non-empty set A. A empty nahi hona chahiye. It should have some elements. Dusra set B should have some elements. It should not be empty. So a relation R from non-empty set A to non-empty set B is a subset of Cartesian product A cross B. तो बेटा इसमें कितने एलिमेंट्स हैं कार्टेशियन प्रोडक्ट में? हाउ मेनी एलिमेंट्स डू आई हैव इन दिस कार्टेशियन प्रोडक्ट? मैम 15. बेटा हाउ डू आई नो आई विल हैव 15 एलिमेंट्स? मैम P has 3 elements ना, and Q has 5 elements. So 3 into 5 माने 15. So I will have 15 elements in this Cartesian product. Now, if I take beta a subset of this, माने सारे नहीं लेने हैं. I take any subset. Like for example, इसमें से मैंने एक element ले लिया A, Ali. I took this element. Then beta I took the other element as B, Bhanu. Right, beta? I took one more element. Say I took another element, say B, the third one was Binoy. So यहाँ पे B, Binoy रहा होगा ना? Say I take that element also, beta, B, Binoy. And then say यहाँ पे somewhere here, last element would have been C, Divya. I take that also, beta. So out of those 15 elements which are created in the Cartesian product, I taught you how to make Cartesian product in the last class. So out of those 15 elements that are there in the Cartesian product, but I am going ahead and I am taking 4 elements. मैंने 4 elements उठा ली Cartesian product से. Then this itself, this is called as relation. This is called as relation. Is this clear to everyone? So when I have, so a relation is what? It is from non-empty set A to non-empty set B, and it should be a subset of this Cartesian product. Is Cartesian product का subset होता है वो. Is this clear? Okay. Now let's consider this further. Huh? The second element, जैसे ये second element है ना इसका, हर कार्टेशियन प्रोडक्ट में बेटा ये सेकंड है अली, ए फर्स्ट है, भानु सेकंड है, बी फर्स्ट है, बिनॉय सेकंड है, बी फर्स्ट है. दिस वन इज कॉल्ड इमेज ऑफ द फर्स्ट एलिमेंट. दिस इज कॉल्ड एज इमेज ऑफ द फर्स्ट एलिमेंट. बहुत ध्यान से समझना है ये. दिस विल सेट द बेस फॉर रेंज एंड डोमेन. आई वांट यू टू अंडरस्टैंड वेरी वेरी केयरफुली टू व्हाट आई एम डूइंग. सो बेटा हाउ डिड आई डिफाइन अ रिलेशन? मैम रिलेशन हो गया x, y. X is the element that was belonging to P and y हो गया element and that element मैम it belong to Q. जब हमने ऐसा कुछ लिखा, when I wrote x, y, x belong to P, y belong to Q, that became an element. दूसरी definition क्या है? When I take a subset of the Cartesian product, we did Cartesian product in the last class. We know how to create a Cartesian product. Yes, ma'am, we know that. So out of that Cartesian product, if I take a subset beta, that can also be called as a relation. In this relation, I can say that beta y is an image of x. What can I say? Y is an image of x. I hope this is clear to you. Okay, beta. अब आगे समझो. Now, I want to define domain today. Ma'am, what is domain? The set of all first elements of the ordered pair in a relation R from set A to B is called domain of relation R. अभी समझ लेते हैं 1 मिनट में what is domain. बेटा I am saying कि ये जितने भी x's होंगे ये मेरा एक ordered pair है. Why ordered? Because this has an order in it. We know what is an ordered pair from our previous classes. We know x, y is not same as y, x. दोनों चीजें बहुत ही अलग होती है, right? We know the difference between x, y and y, x. Now, beta, what am I saying? I am saying that these first parts, A, B, C, these are called the domain of the relation. इनको क्या बोलते हैं बेटा? Domain of the relation. Is this clear? Okay, better next definition, please write it down. Now I want to talk about the range. ध्यान से लिखना है, हाँ? The set of all the second elements in a relation are from set A to set B is called range of relation R. बेटा जो मेरे यहां आ रहे हैं, अली, भानु, बिनोय, दिव्या, whatever I am able to get, right, whatever second elements I am getting from the relation R, but that the second element that you get, that basically is called as the range of the relation. Okay, beta, write down. Entire set B, that is called as codomain. तो बेटा वी कैन से दैट रेंज, देखो सेट बी में क्या क्या आया समझने की कोशिश करो. सेट बी एक पूरा सेट है. सेट बी में ये सारे एलिमेंट्स थे मेरे बच्चों. सेट बी हैड अली, भानु, बिनोय, चंद्रा, दिव्या. दिस इज माय कोडोमेन. बट इनमें से कौन कौन से एक्स के साथ कनेक्ट हो पाए, कौन कौन से became an image, which of the following? Ali, Bhanu, Binoy, and Divya. I cannot go ahead and I cannot see Chandra anywhere. So this entire is my codomain, but my range is 4 elements. Are you clear with it? So range is a little less than codomain a lot of times. So I can say better that range is a subset of codomain. Range is a subset of codomain. Is this clear? Absolutely clear. Should I move on to the questions? Any doubt anyone has? Okay, let's move on to the questions now. Now, a relation can be shown in the roster method. A relation can be shown by the set builder method. A visual relation can be shown through the arrow diagram, like I showed here. It can be shown through this, like an arrow diagram. This is a visual way of showing the relation. Huh? Okay, let's take some questions. It will make things easier for you. So, beta, pehla question likho. Let A be 1, 2, 3, 4, 5, and 6. Define relation R from A to A such that relation is all elements xy such that y is x plus 1. Relation is all elements xy and y is x plus 1. ध्यान से समझने की कोशिश करते हैं. So बेटा अगर मैं A बनाती हूँ, then A will be 1, 2, 3, 4, 5 and 6. ये A है. I have to create a relation from A to A, no doubt. But better the image that I have, it should be whatever element is there in A plus 1. So what will happen? Ma'am, 1 plus 1 will be 2, 2 plus 1 will be 3, 3 plus 1 will be 4, 4 plus 1 will be 5, 5 plus 1 will be 6, 6 plus 1 will be 7, and this is it. This will be, ma'am, x plus 1. Wrong. Why? But I cannot go ahead and I cannot exceed A. Kyun bhai? I have to create a relation from A to A. Mane, if A has from 1 to 6, I should not have 7 here. So I should not have 7 here. A is from 1 to 6, na? So better what I will write here will also be from 1 to 6. Yehi tricky part hai. The relation is between A and A. So on both the sides, I will have A. अब अगर मैं दोनों ही साइड पे A दिखाती हूँ, if I show A here and A here, then बेटा इसका क्या मतलब है? This is used to define your relation. यहाँ ए ही लिखना है, यहाँ ए ही लिखना है, बट किस नंबर को किससे मैप करना है, which number will be mapped to which, that is where this is going to help me. So it tells me that if x is 1, y will be x plus 1. That means y will be 2 now. So this implies 1 will be mapped to 2. Similarly, if x is 2, then beta y will be 2 plus 1, 3 now. So 2 will be mapped to 3. यहाँ पे भी a ही है, यहाँ पे भी a ही है. We are just trying to see what will be mapped to what. Are you getting it? Don't make this mistake of putting y here itself. Nana, here I have to put a and a. This is only helping me understand how I should be mapping. Similarly, beta, 3 will be mapped to 4, 4 will be mapped to 5, 5 to 6, and 6 to 7. But 7 to nahi hai na a mein. So I cannot have this. And I can just show this relationship by this. I can just show this relationship by this. Is this clear? Okay, that's the first part. Now, if I tell you, if I ask you beta that for this question that I have given you, depict or tell me what will be the domain, range, and codomain. So what are domain beta? Ma'am, domain is everything that has an image. Kis ki image hai? I have an image for 1, 2, 3, 4, and 5. I have an image for 1, 2, 3, 4, and 5. So beta, my domain will be 1, 2, 3, 4, 5. This will be my domain. Beta, what will be my range? Range is the images which exist. So 2, 5, 3, 4, and 6. So 2, 3, 4, 5, and 6. What is codomain? Codomain is entire of this set. This entire set on the right hand side. Beta, this is your codomain. So what will be codomain? Codomain will be 1, 2, 3, 4, 5, and 6. That will be your codomain. Is this clear? Everyone is clear with this? So please understand the difference between these things. I'm giving you one more question. Let us try to practice this. So write down that I'm giving you a set here. So write down that this is P. This is Q. This is 9, 4, 25, but a 5, 3, 2, 1, minus 2, minus 3, minus 5. I am linking 9 to 3, and I'm also linking 9 to minus 3. I am linking 4 to 2, and I am also linking 4 to minus 2. I am linking 25 to 5, and I'm also linking 25 to minus 5. Okay, beta. Question. Write this in the set builder form. Second question. Write this in the roster form. Third question. Give me the range, domain, and codomain. Give me the range, domain, and codomain. Clear हो बेटा? अच्छा, let's start. पहले हम लिखेंगे इसको roster form में. Roster form is the easiest, I feel. So beta 9 is linked to 3. 9 is linked to minus 3. Right? Beta 4 को मैंने link किया 2 से and minus 2 से. 4 is linked to 2. 4 is linked to minus 2. Beta 25 is linked to 5. And 25 is linked to minus 5. So this will be my roster form. This will be my roster form. Okay. Now just think about this. What's the next thing? What are we supposed to do? We are supposed to go ahead and write this in the set builder format. What happens in the set builder format? I can clearly see that 9 is square of 3 and 9 is square of minus 3. So x is square of y. So in the set builder format, but I will have relation given by x, y such that x is square of y, such that x is square of y. Clear what? And but x belongs to P, y belongs to Q. X belongs to P, y belongs to Q. Clear? Okay, beta. Domain का बताओ अब. Which are those which have an image? Image किस किस की है? 9, 4 and 25 की. So my domain will be 4, 9, 25. Clear? But which are those which are the image of the domain? कौन से number image में आ रहे हैं? 5, 3, 2, -2, 3 and 5. So the range will be these numbers. Please write them in the right order. Huh? That is better. You should always write like this. -2, and then you should write -3, -5, 2, 3, 5. It looks better visually कि हम ascending order में लिख रहे हैं. Not that it is required, but it's good. Huh? But what is codomain? Ma'am, codomain is everything in this side. Even I will include 1 also. Even though one is not an image of anything. One किसी की भी image नहीं है, but it will be part of the codomain. So all of these elements along with 1. Is this clear? That is the answer to your question. One more question, beta, I am giving you. A is given to you as 1, 2. B is given to you as 3, 4. Find number of relations between A and B. But a number of relation मतलब कितना हम Cartesian products बना सकते हैं in the most simple language. We have already done Cartesian product in the last class. So when I'm asking you, tell me the number of relations you can build, what will you do? You will tell me that the number of relations I can build. So if I just go ahead and do beta A cross B, A cross B will be 1, 3, 1, 4, 2, 3, 2, 4. This is my Cartesian product. I told you that a relation is defined as subset of the Cartesian product. Do you remember what was the definition I gave you? But we learned that a relation is a subset of the Cartesian product. यही तो हमने पढ़ा था. Here, it is a subset of the Cartesian product. तो यहाँ पे मैंने Cartesian बना लिया. अब relation इनमें से कुछ भी एक subset हो सकता है. So my relation can only be 1, 3. This can be my relation. My relation can be 1, 3 and 2, 3. Right? This can also be my relation. So any subset that I create of this Cartesian product, that is my relation. My relation can be 1, 3, 1, 4, 2, 4. That's also my relation. So how many subsets can I create? But you can create the number of subsets you can create will be 2 to the power n, where n is the elements in this Cartesian product. So it will be 2 to the power 4, which will be 16. So I can create 16 relations from A into B. This is a very important question, and I hope you understand how to do this. Okay. Okay, beta, with this, I complete the part of relations. In the next class, I will start with functions. Question likh lo homework ke liye. So A is given to you as 1, 2, 3 till 14. Define relation R from A to A given by R is x comma y such that 3x minus y is 0, x, y belongs to A. Define domain, codomain, and range. Everyone will do this homework. I have done a similar question in today's class. Everyone is supposed to practice.
Now, what are functions to first of all begin with? See, very loosely, in our day-to-day lives, we talk about functions. For example, if we start taking examples, a lot of times when whenever we deal with, let's say, economy as a whole, or whenever you're talking about employment of people, you come up and you say that, my employment depends on how the economy performs as a whole, or my employment or my salary depends on how much is the economy growing as a whole, right? Or, let's say that my pocket money, for that matter, depends on how much my family's income is. My education depends on how much my family income is. So very often we go ahead and we loosely speak about the relationship between two or more things. We kind of go ahead and say that, how much ever this economy is performing. And why I'm giving so much examples of economy, because you have to kind of relate this back to economics. This maths is actually mathematical methods for economics. How do I take it back to economics and apply it in economics? So, a lot of times we go ahead and say that, how my economy is going to perform is going to depend on what the government's expenditure is going to be, or what the fiscal deficit is going to be. So more often we kind of use these things very, vaguely or very loosely speaking. Now, when we try and give relationships a mathematical form, that is what forms my function. So what is my function? A function basically is when one thing depends on other factor. For example, my agricultural output depends on the rainfall. For example, the cost of a firm depends on the amount of labor that it has employed. So when one factor or one variable is dependent on the other variable, then that is what is known as a function. Usually, whenever we speak of functions, we always talk about two things. One is known as an independent variable, and the other is known as a dependent variable. Now, what is an independent variable? An independent variable is any variable where you are not going to derive the value, where the value of it would be given to you. For example, I cannot derive the value of the rainfall. You will give me the value of rainfall, and based on the value of rainfall, I will go ahead and I will tell you that this is the amount of agricultural yield that I have. So, the independent variable in economics, and because you have now done microeconomics and you understand what is exogenous variable, what is endogenous variable, the independent variable is an exogenous variable. It is determined outside the model. The value of it is given to you. And based on the independent variable, you derive the value of the dependent variable, which becomes endogenous variable, something which is determined within the model. So agricultural yield will be determined within the model and hence endogenous. Utility will be determined within the model and hence endogenous. Prices will be given to me when I talk about competitive equilibriums and hence exogenous. So, one activity that I kind of find very useful for you is for you to relate back economics and maths together. So here we are studying pure mathematical methods. But how does it really apply to economics, to the fundamentals of economics? That is what your interest should be. Because at the end of the day, you are going ahead and becoming an economist. So let's go ahead and see and deep dive a little into this. Now, what is a function to begin with? One variable is a function of another if the first variable is dependent on the other. So I can go ahead and form as many functions as I want. Agricultural yield is a function of rainfall. Your happiness is a function of your pocket money. Your parents' happiness is a function of your marks. Your educational level is a function of your determination. Salary is a function of gender. I can go ahead and form as many functions as I want to. What is the only thing that I want to understand? One thing depends on the other. One thing depends on the other. Salary depends on the gender. So what depends on the other is a function of the other thing. Let's see a few more examples from maths. So when I say y is equal to x squared, I am going ahead and saying that y is a function of x. When I say C is equal to 5 by 9 F minus 32, which is nothing but a relation between centigrade and Fahrenheit, I am again saying that centigrade is a function of Fahrenheit. You put in some value of Fahrenheit and you will get a corresponding value of centigrade. You put in a value of X and you will get a value of Y. So, these are the various examples that I'm talking about. Your utility is a function of your pocket money. So supposedly I tell you, let's go a little economical. And in economics, I tell you that your utility is, root of pocket money. Suppose. So you put in a value of pocket money. You put in 100 here. You find its root and you get utility. So your utility becomes 10. You put in another value of pocket money, 200, and you get 2 root 10. So different values of pocket money give you different values of utility, right? Similarly, I can say that cost is a function of labor employed. The more is the labor, the more is my cost, because more is the salary that I will be paying. So, one doesn't really always require maths or mathematical functions to work with. Individuals can go ahead and express this relationship using tables, using graphs, using charts, etc. So, for example, let's see this. This is a diagram that I picked up from Microeconomics, and this is a diagram for Laffer curve. Now, Laffer was an economist who came up with this curve, which said that as the government keeps on increasing the tax rate, as the government keeps on increasing the tax rate, the tax revenue will also increase. So tax revenue is tax rate into income. So if you are collecting 10% of your income, you're collecting a particular tax revenue. When you collect 20% of your income, you're collecting a particular tax revenue. When you collect 30% of your income, that becomes your tax revenue. So he said that as you increase your tax rate, the revenue will initially increase. It will reach a maximum. But supposedly the government tells you that I am going to go ahead and charge 100% of your income as tax. Will you work? No. If I earn 100 rupees and I have to pay 100 rupees as tax, I very well may not work. So, if the government charges exactly 100% as tax, then the tax that the government will collect will be zero, because nobody will work. If the government charges 90% also as tax, there will be so many people who will leave the labor market, because they will think, why work? Out of 190 government takes, I'm only left up with 10. There is no reason why I should work. So the Laffer curve suggested that as the tax rate increases, initially the tax revenue will increase. It will reach its maximum, but after that it will start decreasing. And now understand that here again I am expressing a function. I am saying that the tax revenue collected is a function of what the tax rate is. And because I am going ahead and giving a function for it, even without mathematical form, this is a function. Similarly, if I tell you that, this is my price and this is quantity demanded. And I tell you that when price is 10, quantity demanded is maybe 5. When price is 20, quantity demanded is 2. When price is 30, quantity demanded is 1. I am telling you a relationship that the quantity demanded depends on the price of the commodity. And as the price increases, the quantity demanded decreases. So there is this negative relationship between them. This is also a function. Price is independent. Quantity demanded is dependent on the price of the commodity. So I can represent the relationship in form of a table, in form of a chart, or very well in some mathematical format. Well, in this chapter, although I would be dealing with mathematical formats, it is advisable for you to, kind of think of everything that you do in micro or macro as functions. So whenever we say that consumption depends on disposable income, consumption is a function of disposable income, right? Okay. So now I want to kind of go ahead and talk about a rule here. So a definite rule. Now you have to understand that for now, I am saying that each value of the variable gives me a corresponding value of the function. Which means if I tell you my function is x square, I put a value here, I square that up, I get a value of the function. I put a value here, I square that up, I get a value of the function. So putting values for x gives me values of the function, right? So let's now formally define what this means. Let's see the definition of function. A function of a real variable x with domain D. I will talk about domain and range a little later in much detail. But for now, you just have to understand this right here. So a domain is a space to which my X belongs. So, I can go ahead and say that X is always a natural number. I can go ahead and say that X is always a real number, but positive real number. I can go ahead and say that X is a real number. I can go ahead and say that X is maybe integer or maybe rational number. I can define the space over which my X will exist. And that value that I'm defining over which my X will exist, that is known as my domain of X. We'll do it in detail, but for now, you just have to understand the space to which X belongs. That is the domain of X. Now, we are saying that we go ahead and we define this variable X, and this variable X is defined with a space. So we are saying that, you know what? This X belongs to this place. It belongs to natural numbers. Whenever you put in any value of X, it will always be positive. For example, price and quantity. Whenever you put in any value of price, it will always be positive. Whenever, for example, cost is a function of labor. Whenever you put in any value of labor, it will always be positive and discrete. Labor cannot be 1.5, 1.8, etc. So, unless you're finding labor in labor hours. So, I am saying that for each X, I have a domain over which it is defined. Now, we are saying a function of real variable X, you can put this in bracket with domain D, is a rule. So, a function is a rule. What does this rule do? This rule is very simple. It picks up the value of X and it assigns a unique real number to each value of X. Right? So, for example, please understand. For example, if I tell you that X is defined such that it can take 5 values, 1, 2, 3, 4, 5. And now I say that the function of X is nothing but the square of X. Then what is this rule going to do? This rule is, what is function going to do basically? It is going to pick up an X. It is going to plug this value of X inside this function. So it is going to plug 1 instead of X. It is going to get the answer for you. So the answer is 1. Again, it is going to pick up another value of X because X is defined over 5 values. For that value of X, it will give you the value of the function. So it can do it for all the values of X. It can give you the value of the function. So let's read this again. A function is nothing but a rule. It picks up values of X and it assigns unique number to the value of X. Whatever value of X you will pick up, corresponding to that value of X, the f of X thus defined will be unique. It will give you one answer for that. Now, this rule can be given by a formula, as I just said. Either you can represent it mathematically, or you can just say it in words, like the Laffer curve in words, like the law of demand in words, or you can define it by a table, like we just made a demand schedule, or you can illustrate it by a curve, like the Laffer curve. So, you can go ahead and define function in any of these ways. In case of a formula, in words, in table, in curve, etc. Now, a function is given by a lot of ways. One way to write the function is simply small f. So I can say y is a function of x. The other way is any small alphabet. I could have very well written y is a function of x, but instead of f, I would have used g. I could have written y is a function of x, but instead of G, I could have used an H. So anything is fine, any small alphabet. Similarly, I can also use any capital alphabet. So I could have written Y is a function of X. This is also one of the way to note this down. And you could have also gone ahead and represented by any symbol. That would have also been fine. So you could have written Y is a function of X. This would have been equally fine to work with. So you can go ahead and express the function using small alphabets, large alphabets, capital alphabets, or using these phi's or anything else. Any symbol can also be used. Now, you have to also understand that if I am saying that, whenever I'm representing f of x, then ideally, this is simply saying that f of x, this just is, how do you read this thing? This simply says f of x. So if I say gx, then this is g of x. That is how you're going to learn, how you're going to go in and mention this. When you read it out, this is how you're going to read it. So for example, let's say, if I say y is equal to hx, so I'm saying y is a function of x. But if I do not give you y and I just say hx, then you're going to say h of x. Okay. Now, let's go ahead and, this is something I've already mentioned to you, that x is always the independent variable and y is the dependent variable. So y depends on the value of x. X is exogenous. It is defined outside the model. So if I talk about maximizing utility subject to budget constraint, then price and income are exogenous. But x and y, how much of good x you will consume and how much of good y you will consume, that is endogenous. Right? Similarly, if I say maximizing profit, let's say subject to cost or subject to the level of output. Again, you can go ahead and define exogenous and endogenous. I'll do this. When I go to the production side, I will again come back to this part and I will tell you exogenous, endogenous, etc. So, you have to understand independent, exogenous, dependent, endogenous. Now, let's talk about certain functional notations. So this is one of the first examples. This says, let's see, very simple. Assign to any number the third power of that number. So I'm saying any number is the third power of the other number. So whenever you put a number here, its third power becomes the next number. Simple. I'm just saying y is equal to x cube or f of x is equal to x cube. That's it. You put 0, you get the answer as its third power. You put 1, you get the answer as its third power. You put -2, you get answer as its third power. -2 into -2 into -2. You put 1/4, you get answer as its third part. 1/4 into 1/4 into 1/4. You put a, and now this is a little tricky, and I want to kind of again hold you for a second. for us to understand a and 1 plus a. Now, please understand. If I put a in f of x, I will get a cube. If I put 1 plus a in f of x, I will get 1 plus a whole cube. And you can open this up. You know, all of us know the formula of a plus b whole cube. It's a cube plus 3a square b plus 3ab square plus b cube. That's fine. But this is what I want to highlight, that when you put a, you get a cube. And when you put 1 plus a, you get 1 plus a whole cube. A lot of students go ahead and instead of writing 1 plus a whole cube, actually write down a cube plus 1. This is wrong. 1 plus a, if you're putting it in the function, you have to replace x with 1 plus a and then cube it. I want to give one more moment to this thing, to this analysis. So consider the volume of a cube. The volume of a cube, the formula for volume of a cube is its side cube. So, you know, if the length, because for a cube, length, breadth, and height are the same. So if its side is valued at a, then the volume of the cube will be a into a into a. Simple. That's the volume of the cube. I want to give it a moment that, you know, a cube plus 1 and 1 plus a whole cube are not the same thing. So supposedly, I begin with the cube whose side is a. The value of the side is a for this cube. And now I tell you what will be the volume of the cube. You will tell me, okay, this is the cube and its volume will be simply a cube. You know, side into side into side. Now I'm saying, consider another cube whose value of the side is 1 plus a. Because now in the other question, I am saying that x is 1 plus a. So consider another cube whose side is 1 plus a. Then when its side is 1 plus a, length, breadth, and height, all three of these values are increasing by 1. Are you getting it? So actually, this is like this. Each side, whether it is length, whether it is breadth, whether it is height, is getting increased by 1. Each side. So now for this cube, this length is actually 1 plus a, breadth is also 1 plus a, and height is also 1 plus a. If I ask you what will be its volume, you will tell me 1 plus a whole cube. If I ask you what will be this volume plus 1, it will be a cube plus 1. So a cube plus 1 is volume of cube which has the side as a, and you're just adding 1 to it, which means nothing. And here you're finding the volume of the cube whose side is 1 plus a. The two things are very, very different. Okay, so you know, a cube plus 1 is just implies volume increasing by 1 unit, but the side is still a and not 1 plus a. So make sure that you put this in the right part. You know, you have to put 1 plus a instead of x. That is important, and not just add 1 to it. Okay, now, you know, this is another question which is given to us. Let's try and solve this, and then I'll give you one for practice. So, you know, this says that the cost function is given by 100x root x plus 500. and they're asking you to do 4 things with it. The first is find what happens when the units are 16. Very simple. Instead of x, you substitute 16 and you just get an answer. So this is 100, 16, 4 plus 500. So this is 6400 plus 500, 6900, and solve. Then it says put 100. What is the cost if you're producing 100 units? So instead of x, you will put 100. If you put 100, what will you get? 100, 100, root 100 plus 500. You solve this, you'll get 1, 0, 0, 0, 0 plus 500. So if you solve this, you will simply get this. Then this asks you, what is the cost of producing A units? If you have to find the cost of producing A units, then what will you do? Then instead of x, you will put A. So, you know, cost of producing A units will be 100 A root A plus 500 and solved. Now it asks you, what is the increase in cost when you produce an additional unit, when initially you were producing 100 units? So it says initially the firm was producing 100 units, but now supposedly the firm produces A units, but now the firm produces 1 plus A units. So what is the cost for 1 plus A? We just mentioned, you don't just add 1 to it. This is wrong. You have to replace A with 1 plus A. So, you know, 100, 1 plus A, root 1 plus A plus 500. This is the cost of producing 1 plus A units. Now the question is asking, what is the additional cost? What is the extra cost you incurred? So this is the cost of producing 1 plus A units. This is the cost of producing A units. What is the extra cost that you had to incur? C of 1 plus A minus C of A. You just subtract this and you will get 100, 1 plus A root 1 plus A minus A root A. Because 500 and 500 will get cancelled. So the additional cost, and I'll share this also with you assignment. So the additional cost will be the cost of producing 1 plus A units minus the cost of producing A units. And if you go ahead and you subtract and you find the difference, well, you know, 500 and 500 gets cancelled. So it will be just this minus this. You can take 100 common and this will be your answer. Now, in microeconomics, we refer to this as marginal cost. What is the additional cost that you incurred when you increased your output? But we are going to argue that, you know, this is actually known as incremental cost. So, you know, after some time, give me some time, when I progress few lectures later in maths, I will go ahead and I will distinguish between incremental and marginal cost. Although in microeconomics, you use them interchangeably, but in maths, incremental and marginal cost actually mean different things. So what they mean, I would be taking that in a few lectures, not now. So for now, you just have to solve this usually and get the answer. Now, you know, one more thing that I want to kind of highlight is that always we write y is a function of x. Y can be a function of t. Y can be a function of h. Anything. Need not be the case that my independent variable is always represented by x. It can be represented by t. It can be represented by h or by any other thing. So, you know, this is just saying I can, if I'm writing the function as this, Instead of x, I can replace it with t. I can replace it with any symbol, and I can replace it with just dots also. Where dots represent that you can replace it with any number possible and any variable possible. So, this is no convention that only x will be used to represent independent variable. You can use any alphabet to represent independent variable.
तो बेटा look at this first question. बेटा ये देखो क्वेश्चन क्या बोल रहा है. For the function fx is equal to ln 4 minus x square, find the domain and find the asymptotes. Find the domain and find the asymptotes. देखते हैं बेटा क्वेश्चन को ध्यान से. So पहला हमें we need to understand how a log function looks. ठीक है बेटा, whenever we have y is equal to ln x to the base e या कोई और बेस भी हो, whenever you have a log function, then this log function is defined only when x can take positive values for all values of x greater than 0. ये log function कैसे defined है? It is defined for all values of x greater than 0. माने if I were to plot this log function, this is y is equal to ln x. It is only defined as long as the x is greater than 0 for positive values of x. ठीक है बेटा, now try to see that in this function log x नहीं है. What is there inside log? ये वाला part 4 minus x square है ना, तो log of 4 minus x square है. So whatever comes inside this log, जिस भी चीज का हम log निकाल रहे हैं, that thing needs to be positive. That thing needs to be greater than 0. ठीक है बेटा. बेटा 4 minus x square can be written as, अगर मैं इसका फॉर्मूला यूज करूं a square minus b square, it can be written as a minus b into a plus b. So I can write this as 2 minus x into 2 plus x greater than 0. 2 minus x into 2 plus x greater than 0. ठीक है बेटा, अब हमने chapter of inequality we know that the product of two things is positive. दो चीजों का प्रोडक्ट कब पॉजिटिव होता है? इफ बोथ आर पॉजिटिव और बोथ आर नेगेटिव. नेगेटिव इंटू नेगेटिव भी पॉजिटिव है, पॉजिटिव इंटू पॉजिटिव भी पॉजिटिव है. सो इफ बोथ आर पॉजिटिव और बोथ आर नेगेटिव, तो बेटा यहां पे देखो बोथ आर पॉजिटिव. बोथ आर पॉजिटिव का मतलब हो गया कि 2 minus x greater than 0 and 2 plus x greater than 0. So 2 greater than x and 2 greater than, और उल्टा कर देते हैं, 2 को we can take on the other side, x greater than minus 2. ठीक है, तो बेटा if I go ahead and if I solve this, इसको हम नंबर लाइन पे प्लग इन करें अगर एक बारी, what will I get? यहाँ पे हो गया -2, -1, 0, 1, 2. x लेस देन 2 आ रहा है यहां से, है ना, x लेस देन 2, और यहां से आ रहा है x ग्रेटर देन -2. तो बेटा व्हाट इज द कॉमन रीजन बिटवीन द टू? दिस रीजन, है ना. इट मीन्स दैट x विल बिलोंग टू -2 to 2. ठीक है, x बिलोंग्स बिटवीन -2 to 2. तो ये हमने कर दिया कि इफ बोथ ऑफ देम आर पॉजिटिव. बेटा अब नेक्स्ट देखते हैं, इफ बोथ आर नेगेटिव, माने 2 minus x लेस देन 0 एंड 2 plus x लेस देन 0. तो यहां से क्या आ जाएगा? 2 लेस देन x एंड x लेस देन -2. तो यहां से इफ आई प्लॉट दिस ऑन द नंबर लाइन बेटा, तो ये हो गया -2, -1, 0, 1, 2. x लेस देन -2 माने ये, x greater than 2 माने ये. Is there any common region between the two? No common region. no common region, है ना बेटा? It means that because there is no common region, यहाँ से we cannot solve this equation. So the only answer that I have is x belongs to -2 to 2. 2 -2 और 2 include नहीं हो रहे हैं. Log is only defined when x takes positive values, not at x equal to 0. जब x 0 होगा तो log minus infinity को approach करेगा. It will approach minus infinity. It's not defined जब जो भी हम जिस भी चीज का log निकाल रहे हैं वो 0 हो ना. It is only defined as long as it is greater than 0. So equal to sign नहीं था. So there is no equal to sign. So -2 and 2 are not included here. ठीक है बेटा? The values that x take is called the domain of the function. तो इस केस में what is going to be the domain of the function? The domain of the function will be x between -2 to 2. Will be x between -2 to 2. Is this clear, beta? So this is how you can find the domain of the function. ठीक है बेटा? Okay. Okay. Beta, now look at the next type of question. So what we want to do is हमें यहाँ पे एक function दिया हुआ है and we want to go ahead and we want to find the asymptotes of this function. We want to find the asymptotes of this function. Now we know already that the domain of this function, क्या है इसका domain बेटा? Whenever x belongs between -2 to 2. That is the domain of this function. What I want to do is I want to find the asymptote of this function. So there are two kinds of asymptotes, beta. Two kinds of asymptotes. Number one is called as a vertical asymptote. Number two is called as a horizontal asymptote. ठीक है बेटा? वर्टिकल एसिम्प्टोट का क्या मतलब है? व्हाट डज अ वर्टिकल एसिम्प्टोट लुक लाइक? इट लुक्स लाइक दिस. सपोज दिस इज अ वर्टिकल एसिम्प्टोट. सो योर फंक्शन will never have this x value included. मतलब आपका फंक्शन इस x वैल्यू की तरफ तो जाएगा बट इस x वैल्यू को इंक्लूड नहीं करेगा. Am I clear with this? So function will never include this x value. ठीक है? मतलब what we are saying is that suppose this x, यहाँ पे value of x is a. So जैसे ही x will go towards a, जैसे ही function you are going towards a, of course you are going towards a from the right hand side, तो a plus ले लेते हैं. What will happen? आपका जो function है it is approaching minus infinity या plus infinity. In this case ये minus infinity की तरफ जा रहा है. It's approaching minus infinity. It can approach plus infinity also. जैसे for example, I can go ahead and I can draw something like this. कि if this is my vertical asymptote, है ना, और मेरा function कुछ ऐसा है, so it means that as I am approaching this value of x, यहाँ पे कुछ एक x ले लेते हैं. Suppose x is equal to a. So as I am going towards a, the function is going towards infinity. It's going towards infinity. ठीक है? But now let's think about the log function. हमारा जो usual log function होता है. So y is equal to ln 4 minus x square की जगह पे first I am just thinking y is equal to ln x. ठीक है? But how can I plot this y is equal to ln x? It looks like this. है ना? माने as my x is approaching 0, my function is approaching minus infinity, right? So as x is approaching 0, my function is approaching minus infinity. So at x equal to 0, I have a vertical asymptote. मेरा एक vertical asymptote है. Now, but the function that is given to you, that is y is equal to ln 4 minus x square. We have already learned how to find the domain of this function and we found out in the previous question. हमने ये देखा कि इसका जो domain आया है वो आया है -2 and 2 with -2 and 2 not included. माने what is happening basically is that what is happening basically is that if I have this, है ना, और यहाँ पे मेरा 0 है and this is -1 and this is -2 and this is 1 and this is 2. So what I have seen is that x can only take values between -2 and 2. x सिर्फ इनके बीच का values ही ले सकता है. And also what I have seen is that if x will be exactly -2, अगर x exactly -2 होगा, so what will be my function beta? Y is equal to ln 4 minus -2 square, माने y is equal to ln 0 हो जाएगा. And ln 0 is not defined. देखो, जब जो भी यहाँ अगर ये मेरा log function था, y is equal to ln x, and when x was 0, so it was going towards minus infinity. It was approaching minus infinity. है कि नहीं है? It was approaching minus infinity. And here, when is it becoming ln 0? कब ये ln 0 बन रहा है? When x is -2. Similarly, if x will be 2 beta, अगर x 2 होगा, so what will happen? Y is equal to ln 4 minus 2 square is equal to ln 4 minus 4 equal to ln 0. Again, ln 0 is not defined. ln 0 defined ही नहीं है. But we are saying that if we approach -2 or 2, then the function will approach this value. And ln 0, जब 0 पे होता है, not 0, exactly 0 पे तो defined ही नहीं है, but as we approach 0, the value of the function approaches minus infinity. So as we will approach 0, when will we approach 0 beta? कब ln 0 बनेगा? When x is going towards -2 or 2, then the function will go towards minus infinity. Then the function will go towards minus infinity. माने यहाँ कहीं पे will be your vertical asymptote. Is this making some sense? Where you will find vertical asymptote beta? So to find vertical asymptote, you will see कि function का value infinity या minus infinity को कब tend करता है. When the value of the function is going towards minus infinity, function is going towards infinity, when that will happen, that is what you have to go ahead and you have to look for. Is this clear beta? Is this clear everyone? ठीक है. अच्छा, now what we can go ahead and we can do is, because I have already made this thing, so I can go ahead and I can also graph this. Graph करने का आपको जरूरत नहीं है, but if you will try and you will graph this, you will find out कि function ऐसा कुछ लगेगा. It has to cut the x-axis also. तो x-axis को कट करने के लिए y का 0 होना जरूरी है. I'm just going one step ahead beta. So if y is 0, you will have ln 4 minus x square. ठीक है, ये clear हुआ? अच्छा, this is log to the base e. This is log to the base e. ठीक है, तो what we can do is, हम ना दोनों साइड पे we can take e. ठीक है, और ये क्या हो जाएगा ना, this will become e to the power 0 is 1, और e और log can be removed and this will be 4 minus x square. तो ये हो जाएगा 4 minus 1 equal to x square equal to 3, x will be plus minus root 3. x will be plus minus root 3, मतलब 1.7 something. हाँ, तो माने यहाँ कहीं पे it will be cutting the x-axis. So actually if you try plotting it, ये function कुछ ऐसा बन के आएगा. It will turn out something like this. And as x is going towards -2 and 2, the function will go and approach towards minus infinity. So this is the answer to this question. So how we can go ahead and how we can show this beta? Vertical asymptote के लिए, you can just show this thing that when x is approaching 2, then you will approach minus infinity. ये आपका एक vertical asymptote हो गया. And when x is approaching -2, then also it will become log 0, ln 0, and hence it will approach minus infinity. So you will have your vertical asymptote at 2 and -2. ये बात समझ में हुई? You will have your vertical asymptote at 2 and -2. But now let's talk about horizontal asymptotes. So horizontal asymptote के लिए what we can go ahead and have is a line like this. Function का value को constant रखना है, and we need to check what happens as x goes towards infinity. what value will we approach. तो हम किस वैल्यू को अप्रोच करेंगे जैसे x इंफिनिटी की तरफ जाए, as x goes towards infinity, what value will we attain? Will we attain a particular value? क्या हम एक particular value की तरफ जाएंगे या नहीं जाएंगे? That is my horizontal asymptote, right? So as x goes towards infinity or x goes towards minus infinity, which value of the function will you obtain? That is what is your horizontal asymptote. But beta, in this case, the domain of the function is only -2 से 2 तक. The domain of the function is only from -2 to 2. That means x cannot approach infinity or minus infinity. So if x cannot approach infinity or minus infinity, and I showed you the diagram of the function also, graph of the function looks like this. X to infinity या minus infinity की तरफ जा ही नहीं सकता. X cannot approach that. So it means that there is no horizontal asymptote. So there is no horizontal asymptote. है ना बेटा? तो vertical asymptote तो exist कर रहा है, but there is no horizontal asymptote of this function. Is this clear बेटा? Okay बेटा, thank you. Welcome to the next lecture. बेटा आज हम बात करेंगे about the graph of the function. We'll be talking about the graph of the functions, right? Now, when we talk about the graph of the function, so let us go ahead and let us understand what is a graph. Graph means I am showing something diagrammatically. Okay. Graph of functions can have any shape. मेरा ग्राफ ऐसा भी दिख सकता है, ग्राफ ऐसा भी दिख सकता है. Graph can have any shape, right? But what is a graph? A graph is basically when I represent y as a function of x. और हमने function का क्या property है हमारे functions का बेटा? Whenever I talk about a function, right, then each point x, it corresponds to a point y. Each point x corresponds to a point y. ठीक है? Like, for example, let us go ahead and let us plot the first kind of function. Suppose if I tell you beta कि मुझे plot करना है fx is equal to x square minus 3x को. I want to plot fx is equal to x square minus 3x. तो इसको हम कैसे plot कर सकते हैं? How can we plot this? तो बेटा when x is 0, अगर मैं x को 0 plug in करूं तो f of 0 will become 0 square minus 3 into 0, it means 0. बेटा when x is 1, f of 1 will become 1 square minus 3 into 1, that means minus 2. When we put x as minus 1, f of minus 1 will become minus 1 square minus 3 of minus 1, 1 plus 3, 4. अगर आप इसकी, if you look at the plot of this ना, because it is square, it means it will be a parabola. क्योंकि ये एक square है तो ये एक parabola तो होगा ही होगा. So if we go ahead and if we look, what will happen is that when x is 0, हाँ, y is also 0. When x is 0, y is 0. तो अब हम इसका अगर minimum point निकालें, what will be the minimum point? बेटा f dash x will become 2x minus 3. And if I put this equal to 0, right? Let's equate this to 0. So what will I go ahead and what will I get? I will get x is equal to 3 by 2. That means 1.5. Okay. And f double dash x will become 2, which is greater than 0, which means minima. जब भी डबल डेरिवेटिव पॉजिटिव होता है तो मिनिमा होता है. We'll talk about this जब हम डिफरेंशिएशन की बात करेंगे. We'll talk about this in detail. But यहां से अभी के लिए I understand that when x is 1.5, I am achieving a minima. तो ये हो गया 1, ये हो गया 2 और ये हो गया 1.5. इस पॉइंट पे हमारे पास एक मिनिमम है. ठीक है. अच्छा, let's put x as 3 बेटा. तो f of 3 will become 3 square minus 3 into 3, that means 0. तो यहाँ पे जब x 3 है तो भी y 0 है. So you will see that the graph looks something like this. ऐसा कुछ ग्राफ बनेगा. ठीक है। इस ग्राफ की एक प्रॉपर्टी है, क्या प्रॉपर्टी है कि जब भी मैं एक वर्टिकल लाइन ड्रॉ करूंगी इट विल कट द ग्राफ एग्जैक्टली वंस। देख लो, कहीं पे भी एक वर्टिकल लाइन ड्रॉ करो तो ये ग्राफ को एग्जैक्टली वंस काटती है, isn't it? So this has a property that whenever I draw a vertical line it will cut the graph exactly once. और ये फंक्शन होने के लिए जरूरी है, बिकॉज व्हाट वाज अ फंक्शन? अ फंक्शन, जब हम एक फंक्शन बना रहे थे तो फंक्शन के लिए बहुत ही जरूरी था कि जो भी वाइज हैं वो एक्सेस से कनेक्टेड हों। और वो ग्राफ में हम कैसे इंश्योर करते हैं? वी इंश्योर दैट बाय ड्रॉइंग अ वर्टिकल लाइन। तो हम ये बोल सकते हैं कि अगर अगर हमें चेक करना है दैट इट इज द ग्राफ ऑफ अ फंक्शन और नॉट, ये एक फंक्शन को रिप्रेजेंट करता है या नहीं, सो ग्राफ ऑफ अ फंक्शन, हाँ, इट हैज प्रॉपर्टी दैट अ वर्टिकल लाइन थ्रू एनी पॉइंट on x-axis has at most maximum one point of intersection. Has at most one point of intersection. तो अब एक बात बताओ, is this graph of a function? क्या ये फंक्शन का ग्राफ है? ट्राई टू ड्रॉ वर्टिकल लाइन, इट इज कटिंग ट्वाइस, सो नो, इट डजंट रिप्रेजेंट अ फंक्शन, क्योंकि एक ही एक्स दो अलग वाई दे रहा है। और अगर एक एक्स दो अलग वाई दे, एक एक्स दो अलग वाई दे, y1 y2, then it's not a function, तो ये फंक्शन नहीं होता, राइट? अच्छा, नाउ लेट्स टेक वन मोर, let us go ahead and let us take one more graph, हाँ? तो supposedly I tell you that I want to plot the graph. अच्छा, you're given something like this, हाँ? That this is the graph. ये है 20, बेटा ये है 50, ये है 5, ये है 15. Some graph is given to you. ठीक है, and this graph actually shows income tax for different slabs. और यहाँ पे है income and here you have tax collected. Is this a function? Draw a vertical line. Cutting the graph exactly once. So yes, it represents function of a graph of a function. ठीक है, ऐसे मेजॉरिटी टाइम्स एक सिंपल क्वेश्चन ये आता ही है कि सपोज इफ आई ड्रॉ लाइक दिस, इज दिस अ फंक्शन? ड्रॉ वर्टिकल लाइन, एग्जैक्टली वन टाइम काट रहा है, सो यस इट इज अ फंक्शन। ठीक है, इट इज अ फंक्शन। नाउ वी वांट टू टॉक अबाउट शिफ्टिंग ग्राफ्स। अब हम बात करते हैं शिफ्टिंग ग्राफ्स होते क्या है। ठीक है बेटा, अच्छा फर्स्ट आता है एफ एक्स प्लस सी, सेकेंड है बेटा एफ ऑफ एक्स प्लस सी, थर्ड है माइनस एफ एक्स, एंड फोर्थ है, अभी आपको सब समझ में आ जाएगा, यू विल अंडरस्टैंड इट वेल, एफ ऑफ माइनस एक्स। ठीक है, लेट मी एक्सप्लेन टू यू ऑल दीज फोर केसेस बाय वन फंक्शन। सो सपोज हमने फंक्शन ले लिया एफ एक्स इज इक्वल टू एक्स स्क्वायर। ठीक है, लेट्स से आई हैव टेकन द फंक्शन एफ एक्स इज इक्वल टू एक्स स्क्वायर। ठीक है, अब बेटा पहला बोलता है कि मेरे को इस चीज का ग्राफ बनाना है, एफ एक्स प्लस सी का, माने मेरा एक न्यू फंक्शन है जी एक्स एंड दिस इज एक्स स्क्वायर प्लस 2। मैंने कुछ कांस्टेंट इसमें ऐड किया, आई एडेड सम कांस्टेंट हियर, ठीक है। सो हाउ विल यू प्लॉट दिस, इसको कैसे प्लॉट करोगे? इफ यू प्लॉट दिस इट विल कम आउट लाइक दिस, इट्स अ पैराबोला, ऐसे आएगा। हाँ, यू कैन ट्राई दिस। तो क्या कर सकते हो, पुट x as 0, fx will be 0, put x as -1, fx will be 1, put x as 1, fx will be 1। अलग अलग वैल्यूज के लिए यू, फॉर डिफरेंट वैल्यूज यू कैन टेस्ट। हाँ, तो 0 1 -1 1 हो गया, -2 2 4 हो गया। अच्छा, अब नेक्स्ट दैट वी गेट बेटा दैट इज x² + 2। तो माने व्हेन x इज 0, तो बेटा gx का वैल्यू क्या आ जाएगा, 0² + 2, विच मीन्स आई विल गेट 2। तो gx इज नॉट 0, gx इज 2 व्हेन x इज 0। माने जब x को 0 डालते हैं, x को 0 डालते हैं तो फंक्शन का वैल्यू 2 आता है। सो इफ यू नोटिस ना, ये ग्राफ ऐसा बनता है, when x is 0 y is 2, when x is 1 y is 1² + 2 3। तो यहाँ पे when x was 1 y was 1, अब when x is 1 y is 3, माने दिस इज शिफ्टेड अपवर्ड्स बाय 2। इसको हमने 2 से अपवर्ड, हर जगह पे 2 से ये कर्व शिफ्ट अपवर्ड्स हो गया, अपवर्ड शिफ्ट ऑफ द कर्व। अपवर्ड शिफ्ट ऑफ द कर्व। सिमिलरली बेटा सपोज कुछ सब्ट्रैक्ट हो रहा होता, सो सपोज इफ आई मेक अनदर फंक्शन hx एंड hx इज x² - 2, तो इसको हम कैसे प्लॉट कर सकते हैं? सो व्हेन x इज 0 hx विल बी -2, तो y -2 होगा जब x 0 है, दिस। सो कर्व विल कम लाइक दिस। इट मीन्स दैट देयर इज अ डाउनवर्ड शिफ्ट ऑफ द फंक्शन। जब हमने व्हेन वी प्लॉटेड x², this was fx equal to x², this is x² - 2, this is x² + 2। so what we notice is that when we have this c, depending on whether it is positive or negative, ये positive है या negative है, it will either lead to upward or downward shift of the function, या upward shift हो जाएगा या downward। बेटा नेक्स्ट देखो, इस तरीके से f of x + c, माने अगर पहले मेरा फंक्शन था x², तो मेरा जो न्यू फंक्शन है वो है x + 2² x को रिप्लेस किया है x + c से फंक्शन के अंदर, 2 बाहर नहीं है, इट्स अ पार्ट ऑफ द फंक्शन। अब अगर मैं इसको प्लॉट करती हूँ, आई नो इट्स प्लॉटिंग, इट विल बी लाइक दिस, ये तो सेम ही है प्लॉटिंग। बट अब इसकी प्लॉटिंग देखो बेटा, व्हेन x विल बी -2, तो gx क्या आ जाएगा, -2 + 2² 0। तो इफ आई हैव टू प्लॉट दिस, जब x -2 है, माने x -2 है, -1 -2, तब y 0 है। तो ये कर्व ऐसा बन जाएगा, दिस कर्व विल बिकम लाइक दिस। सो व्हाट वी गो अहेड एंड नोटिस इज दैट दिस हैज शिफ्टेड लेफ्टवर्ड्स, ठीक है। सिमिलरली सपोज बेटा इफ आई टेल यू कि आई हैव टू प्लॉट gx इक्वल टू x - 2², तो फिर से देखो कि व्हेन x इज 2, तो gx विल बिकम 2 - 2² दैट मीन्स 0। तो हम ये बोल सकते हैं कि जब x 2 होगा तो gx 0 हो जाएगा, सो कर्व विल शिफ्ट हियर। तो हियर curve is shifting rightwards, here curve is shifting leftwards। So when this plus c is inside the function f of x plus c है, it leads to leftward or rightward shift of the function। ये बात समझ में आती है? ठीक है ना, तो कुछ नहीं करना, आपको सिर्फ प्लॉट करके देखना है बेटा। f of minus f of x, ठीक है, तो एक मेरा फंक्शन है एक्स स्क्वायर एंड दूसरा मेरा फंक्शन मुझे प्लॉट करना है माइनस एक्स स्क्वायर। एक्स स्क्वायर ऐसे प्लॉटेड था बेटा। अच्छा, ये बहुत इजी है समझना। देखो जी एक्स इज माइनस एक्स स्क्वायर, तो व्हेन आई डू जी डैश एक्स ये हो जाएगा -2x इक्वल टू 0, तो यहां से x आ गया 0। माने इस फंक्शन का भी x इक्वल टू 0 पे या मैक्सिमा होगा या मिनिमा होगा। अब मैंने g डबल डैश x किया एंड आई गेट -2 विच इज लेस देन 0। तो जब सेकेंड डेरिवेटिव नेगेटिव होता है वी गेट अ मैक्सिमा। मतलब अब x इक्वल टू 0 पे वी गेट अ मैक्सिमा ऑफ द फंक्शन। मिनिमा नहीं आ रहा है, अब मैक्सिमा आ रहा है। अगर मुझे इसको प्लॉट करना है तो मेरा फंक्शन ऐसा हो जाएगा, फंक्शन का मैक्सिमा आएगा। सो द फंक्शन हैज इन्वर्टेड इटसेल्फ। ठीक है, अब बेटा f ऑफ माइनस एक्स, तो यहां देखो मेरा है f ऑफ x था एक्स स्क्वायर, f ऑफ माइनस एक्स हो जाएगा माइनस एक्स होल स्क्वायर विच इज एक्स स्क्वायर। इन दिस केस नॉट अफेक्टेड, क्योंकि स्क्वायर ऑफ द फंक्शन था ना, तो कोई असर नहीं है। बट कोई और फंक्शन लेके देखते हैं। सो लेट्स से माय फंक्शन इज एक्स क्यूब। सपोज फंक्शन एक्स क्यूब होता, या उससे भी सिंपल है, सपोज फंक्शन एक्स प्लस, सपोज फंक्शन एक्स ही होता। मोस्ट सिंपल, लेट द फंक्शन बी एक्स। सो इफ द फंक्शन इज एक्स, so f of minus x will be what beta? Minus x, है ना? ट्राई टू डू इट विद डिफरेंट थिंग्स। हाँ, तो या फंक्शन को x प्लस 2 ले लो। f ऑफ माइनस एक्स का क्या मतलब है कि जो भी फंक्शन था उसको हम रिप्लेस कर रहे हैं माइनस वैल्यू से, सो इट विल बी माइनस एक्स प्लस 2। ठीक, प्लॉट दीज टू बेटा, इनको प्लॉट कर लो। ठीक है, तो जब हम x प्लस 2 को प्लॉट करेंगे व्हेन x इज 0 y इज 2, राइट? When x is 0, y is 2. When x is 1, y is 3. When x is minus 1, y is 1. Yes, आ गया. Now try to plot this one. Minus x plus 2. When x is 0, y is 2. When x is 0, y is 2. But when x is 1, y will be 2 minus 1, 1. When x is minus 1, y will be 2 minus minus 1, 3. तो माने it will be like this. So the function flips itself, it inverts itself. ये ऐसे था, इसी की मिरर इमेज ऐसे हो गई। So we can say mirror image. Is it clear? So what we are noticing here beta is that depending on what is happening to our function, we can go ahead and we can get different graphs of the function. ये बहुत ही important aspect है exam point of view से, right? Okay beta, thank you. Now today we are going to go ahead and talk about linear function. बेटा linear function क्या होते हैं ध्यान से देखो। y is equal to ax plus b, where a and b are constants, then this is called as a linear function. अब इसमें we have to understand why it is a linear function. It is a linear function because जो x का power है, that power of x is 1. So when power of x is 1, it becomes a linear function. There are two important aspects in this linear function. एक है मेरा a and एक है b. Let us try to understand what this a and what this b are. a को देखो एक बारी. If I put a as 0, leave a first. Let's talk about b first. Beta, if I put x as 0, अगर हम यहाँ पे 0 डाल देते हैं, so what will I get? y is equal to a into 0 plus b, which is called b. माने when x is 0, y is b. जब x 0 है तो y b है. This is called as intercept term. इसको हम intercept term बोल देते हैं. जब x 0 है तो y b है, इसको हमने बोला बेटा intercept term. ये बात सुनना है, y intercept. ठीक है, माने if I have to show this x y, when x is 0, y का वैल्यू आ रहा है b. बेटा ये पॉइंट है 0, b.
ठीक है, देखो y इज इक्वल टू ए एक्स प्लस बी। तो बेटा इफ आई डू dy by dx I'll get a. if I do dy by dx I'll get a. माने dy by dx क्या होता है? dy by dx is slope. ये बता रहा है how y changes as x changes. ये इस लाइन का स्लोप है, how y changes as x changes, एंड उस स्लोप का वैल्यू ये a आ रहा है। अच्छा बेटा if a is positive it means it will be upward sloping. If a is 0 माने it will be horizontal, क्योंकि a क्या था? a था dy by dx। तो 0 का मतलब ये हो गया कि there is no change in y as x changes. जैसे जैसे x चेंज होगा y चेंज नहीं होगा, y का वैल्यू कांस्टेंट हो गया। एंड बेटा a लेस देन 0 it means it is negatively sloped. It is negatively sloped. तो अपवर्ड स्लोपिंग हो गया ये, ठीक है बेटा। हियर a is greater than 0. डाउनवर्ड्स हर एक में इंटरसेप्ट b ही है, हाँ, क्योंकि when we plug x as 0 y is b. When a is negative we get this. This is when a is less than 0, ठीक है। And when a is 0 so we get this. This is when a is equal to 0. a is equal to 0. ये बात समझ में आती है? Okay, let's take a question on this. So find and interpret slope. C is equal to 55.73x plus 182.100.000. C is total cost in dollar per year, and X is production of steel in ton per year. ठीक है, देखो ध्यान से बेटा, इफ x is 0, अगर मैं यहाँ पे 0 प्लग इन करती हूँ, c will be 182.100.000, right? माने this is going to be the total cost when there is no production. अगर कोई प्रोडक्शन नहीं है तो कॉस्ट इतनी होगी, राइट? अच्छा, नाउ फाइंड dc by dx. It is 55.73. माने if I put change in x by 1, suppose डिनोमिनेटर को 1 प्लग इन करते हैं, लुक हियर, हाँ ध्यान से देखना बेटा, dc by dx is 55.73. Suppose I put dx as 1, it means that increase in production. ये क्या था? ये क्या बताता है? It tells us change in production. Change in x है ना, and x is production, so change in production, and ये +1 है, so माने increase हुआ, so increase in production by 1 unit. और इससे numerator is what बेटा? dc means change in cost. So cost में कितने से change आया? 55.73. So slope of 55.73 means that if production increases by 1 ton, cost increases by $55.73. ठीक है, अच्छा एक और क्वेश्चन देखते हैं. So Q is equal to minus 0.1p
plus 0.14. Okay. But again, we will be focusing on this negative slope. Huh? So dq by dp is minus 0.15. So beta, if dp is 1, माने price is changing by 1, so dq हो जाएगा minus 0.15. तो हम बोल सकते हैं कि if price increases by 1 unit, quantity demanded decreases by 0.15 units. Quantity demanded decreases by 0.15 unit. ये बात समझ में आती है? अच्छा, अब ये जो स्लोप ऑफ स्ट्रेट लाइन है बेटा, इसको निकालने का देयर इज अनदर फॉर्मूला. स्लोप ऑफ स्ट्रेट लाइन. बेटा फॉर्मूला इज a is equal to y2 minus y1 by x2 minus x1. A is equal to y2 minus y1 by x2 minus x1. जैसे for example, बेटा this is a line. दो पॉइंट्स ले लेते हैं हम, पॉइंट A, पॉइंट B. पॉइंट A है x1 यहाँ पे एंड y1 यहाँ पे. पॉइंट B है x2 यहाँ पे एंड y2 यहाँ पे. सो बेटा स्लोप हो जाता है परपेंडिकुलर बाय बेस. स्लोप इज परपेंडिकुलर बाय बेस. तो परपेंडिकुलर इज व्हाट बेटा? दिस. एंड बेस इज व्हाट? दिस. तो परपेंडिकुलर के लिए अगर मैं यहाँ पॉइंट, सपोज आई टेक पॉइंट सी, तो बेटा पॉइंट सी के कोऑर्डिनेट होंगे x2 y1. पॉइंट बी के कोऑर्डिनेट्स हैं x2 y2. पॉइंट ए के कोऑर्डिनेट्स हैं x1 y1. तो परपेंडिकुलर डिस्टेंस ये डिस्टेंस है, माने y2 माइनस y1. एंड बेस डिस्टेंस ये डिस्टेंस है, माने इट इज x2 माइनस x1. तो परपेंडिकुलर बाय बेस will be y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. Is it clear बेटा? बात क्लियर होती है? ठीक है. अब बहुत सिंपल है, मैं आपको कोई भी लाइन दे दूं, आप उसका स्लोप निकाल सकते हो. सो इफ आई गिव यू अ लाइन एंड पॉइंट P है 2 2 एंड पॉइंट Q है 4 एंड say let's say 3, so slope will be what beta? Perpendicular. That means 3 minus 2 upon base. That means 4 minus 2. So half. Right? It will be half. Clear? Okay beta. Likho. Find an expression for slope of line through 2 points. x0 square and x0 plus h, x0 plus h whole square. इसके थ्रू आपको स्लोप निकालना है. सो वेरी सिंपल बेटा, इट इज y2 minus y1 upon x2 minus x1. So y2 is x0 plus h whole square, y1 is x0 square, x2 is x0 plus h, x1 is x0. तो बेटा ये हो जाएगा, देखो यहाँ पे लगेगा फॉर्मूला a स्क्वायर माइनस b स्क्वायर का. सो इट विल बी a minus b, a plus b upon this and this will cancel by h. ठीक है बेटा, यहाँ पे ये कैंसिल हो जाएगा. सो h 2x0 plus h by h. बेटा 2x0 plus h. 2x0 plus h, ये बात समझ में आती है? Okay. Now we want to know what is point slope formula of straight line. Point slope formula of straight line. Point slope formula of straight line means what, beta? Find equation of straight line passing through a particular point. जैसे अगर मैं आपको बोल दूं कि एक लाइन है और ये लाइन इस पॉइंट से पास करती है and this point is x1 y1 and I tell you find the equation of this line. इस लाइन का इक्वेशन निकालना है आपने, तो कैसे होगा? The equation of any such line beta can be written as y minus y1 equal to a x minus x1, where a is the slope of the line, where a is the slope of the line. ठीक है? ओके, देखो बेटा क्वेश्चन देखते हैं. Find equation of line passing through -2, 3 with slope -4. Find the point at which line intersects x-axis. Find the point at which line intersects x-axis. तो बहुत simple है. What will be equation of line? y minus 3 equal to slope x minus -2. So y minus 3 equal to -4 x plus 2. Y minus 3 equal to -4x minus 8. Y equal to -4x minus 8 plus 3. Y equal to -4x minus 5. Now we have to check beta कि where it intersects the x-axis. ये line x-axis को कहाँ पे intersect कर रही है? To check where it intersects the x-axis, we have to put y as 0. You have to put y as 0. X-axis intercept के लिए y0 plug करोगे, y-axis intercept के लिए x को 0 करोगे. So if I put y as 0, I'll get 0 is equal to -4x minus 5. 5 is equal to -4x. X is equal to -5 by 4. X is equal to -5 by 4. So the coordinate of intersection will be -5 by 4, 0. इस पॉइंट पे ये x एक्सिस को इंटरसेप्ट करेगा. इज इट क्लियर? अच्छा बेटा, अब हमें पता है कि ये जो स्लोप है a, इसका हमने अपने आप में एक फॉर्मूला निकाला है y2 minus y1 अपॉन x2 minus x1. तो इसी इक्वेशन को आई कैन राइट इट अगेन एंड से कि y minus y1 will be y2 minus y1 x2 minus x1 x minus x1. This is another formula of line. Y minus y1 is equal to y2 minus y1 by x2 minus x1 x minus x1. ऐसे भी हम इसे लिख सकते हैं. Let's find out one question. Example. But find equation of line passing through -1, 3 and 5, -2. बेटा अब हमने इस पॉइंट को मान लिया y1, x1, y1. We make this point as x1, y1. And बेटा this point हम इसको कंसिडर कर रहे हैं x2, y2. What is the equation of line? Y minus y1 equal to y2 minus y1 x2 minus x1 x minus x1. ठीक है, तो what will we get? Y minus 3 equal to -2 minus 3 by 5 minus -1 x minus -1. So what will we get beta? Y minus 3 equal to -5 by 6 x plus 1. तो solve कर लेते हैं. Take 6 on the other side. 6y minus 18 equal to minus 5x plus 1. 6y minus 18 equal to minus 5x minus 5. 6y equal to minus 5x minus 5 plus 18. 6y equal to minus 5x plus 13. Y equal to minus 5x plus 13 divided by 6. Divided by 6. ऐसे भी लिख सकते हो कि 6y plus 5x equal to 13. ये इक्वेशन भी करेक्ट है. So this will be the equation of your line. ठीक है, this will be the equation of your line. ये समझ में आया? Okay beta, we'll end here. In the next class I will do the applications of these lines. ठीक है, हम application करेंगे, इनके साथ इनका general solution करेंगे, and we'll wrap up this topic of lines. Okay beta, thank you. बेटा गुड इवनिंग एवरीवन. बेटा आज हम लेक्चर में टुडे वी विल बी गोइंग अहेड एंड टॉकिंग अबाउट लीनियर मॉडल्स. हाँ, linear models. But when we apply linear relation to model, that is called as linear model. माने जब हम for example Celsius and Fahrenheit के बीच में relationship कर रहे हैं, so we are applying it to a model, right? जैसे for example, let's say if I tell you that in a United Nations report, you are told that the population in 1960, right, it was 641 million. 1960 में population 641 million थी, and 1970 में population 705 million है. ठीक है, and we have to create a linear function to and then we have to approximate population in 1930. कि 1930 में कितना population रहा होगा. तो हम कह सकते हैं कि population is a times t, t is the time plus b. एक लीनियर लाइन को हम ऐसे लिखते हैं ना, at plus b के फॉर्म में. फ्रॉम द लास्ट लेक्चर वी नो लाइन को हम at plus b फॉर्म में लिखते हैं बेटा, वेयर a इज द स्लोप, b इज द इंटरसेप्ट. a इज द स्लोप, b इज द इंटरसेप्ट. तो हमने ऐसे लिख दिया कि p इज इक्वल टू at plus b. ठीक है. अच्छा बेटा, अब अगर मुझे इस लाइन को डिराइव करना है, इफ आई हैव टू डिराइव दिस लाइन, तो ये लाइन कैसे डिराइव हो सकती है? हाउ कैन आई डिराइव दिस लाइन? वेरी सिंपल. हमें पता है कि द फॉर्मूला इज y माइनस y1 इज इक्वल टू y2 माइनस y1 अपॉन x2 माइनस x1 x माइनस x1. तो y माइनस, बेटा y इज द पॉपुलेशन हियर. ठीक है, तो पॉपुलेशन का फर्स्ट फिगर हमने ले लिया 641. So y minus 641. Y की जगह I can write P very well. हाँ, population is a function of time is equal to y2. y2 क्या है? 705 minus 641 upon x2. x2 था time, क्योंकि population is a function of time. So x variable जो independent variable है वो time है, और population dependent variable है because population depends on time. Right? So, beta, this will be 170, 1970, sorry, minus 1960, x minus x1. बेटा x1 क्या है? 1960. 1960. ठीक है. अब यहां पे थोड़ा सा एक इशू क्रिएट होता है हमारे लिए. क्या इशू क्रिएट होता है कि ईयर को 1960, 1970 लिखना ठीक है, कोई प्रॉब्लम नहीं है, बट एक और चीज की जा सकती है. वी कैन डू वन मोर थिंग जो हम यूजुअली इकोनॉमिक्स में करते हैं. हम क्या कर सकते हैं कि हम अपने बेस ईयर को टाइम पीरियड 0 बोल के चल सकते हैं टू सिंप्लीफाई द मॉडल. तो हमारा हम वी कैन नोटिस हियर कि 1960 को अगर हम अपना बेस माने, अगर हम अपना इनिशियल पीरियड माने और यहाँ पे t इक्वल टू 0 रखें, तो 1970 में t हो जाएगा 10, है ना, क्योंकि 10 इयर्स लेटर है. 1970 में t हो जाएगा 10. सो इफ वी वांट दैट, तो इस रिलेशनशिप को हम यहाँ पे 1970 1960 की जगह 10 माइनस 0 भी लिख सकते हैं, और यहाँ पर हम 0 भी लिख सकते हैं. बोथ आर फाइन, इशू किसी में नहीं है, बट दिस इज अ बेटर वे टू डी। मैं दोबारा रिपीट करती हूँ, देखो यहां पर हम एक लीनियर रिलेशनशिप बना रहे हैं बिटवीन पॉपुलेशन एंड टाइम। जो हमारा पॉपुलेशन है वो डिपेंडेंट वेरिएबल है, किस पे डिपेंड कर रहा है, टाइम पे। टाइम इज एन इंडिपेंडेंट वेरिएबल, ठीक है। तो जब हमने इस रिलेशनशिप को लिखा, व्हेन वी रोट दिस रिलेशनशिप, वी रोट p इज इक्वल टू a t प्लस b। हमने लिख दिया p इज इक्वल टू a t प्लस b। बेटा इसको हमने अगर लीनियर लाइन के फॉर्म में लिखना है तो हम लिख सकते हैं p माइनस पी नॉट इज इक्वल टू p माइनस पी वन इज इक्वल टू p2 माइनस पी वन अपॉन t2 माइनस t1 t माइनस t1, ठीक है। राइट साइड पे डिपेंडेंट वेरिएबल आता है, लेफ्ट पे इंडिपेंडेंट वेरिएबल। नाउ बेटा व्हाट हैज हैपेंड इज दैट, सो नाउ व्हाट हैज हैपेंड इज दैट ये जो टाइम है ना, दिस इज गिवन टू लाइक दिस, t2 is 1960, 1960 नहीं 1970 and t1 is 1960। बट ऐसे लिखने की जगह हम इसको बेस ईयर मान के 0 वैल्यू दे देते हैं, और ये क्योंकि 10 साल बाद है तो इसको हम 10 वैल्यू दे देते हैं। अच्छा, इस तरीके से अगर 1930 बाद में कहीं डालना हो तो ये 30 इयर्स बैक है तो उसका वैल्यू -30 हो जाएगा, जस्ट टेलिंग यू, ठीक है। अच्छा, नाउ वी सॉल्व दिस इक्वेशन। सो व्हेन आई सॉल्व दिस इक्वेशन, जब हम इसको सॉल्व करेंगे तो हमें मिलेगा p माइनस 641 इक्वल टू 464 बाई 10 t। x इज टाइम पीरियड हियर ना, ठीक है। सो p इज इक्वल टू 641 प्लस 6.4 t, ये हो गया। अब सपोज क्वेश्चन बोलता है कि कैलकुलेट पॉपुलेशन in 1930, कैलकुलेट पॉपुलेशन इन 1930। तो बेटा ध्यान से समझो, हमने t इक्वल टू 1960 को 0 लिया, 1970 में t का वैल्यू 10 हो गया, तो 1930 में हम 30 इयर्स बैक जा रहे हैं तो t विल बी -30। सो इफ आई प्लग t एज -30, I will get the value of population. So 641 में अगर हम -30 ये प्लग इन कर दें, so you can do 64 into 3, whatever answer you will get, ठीक है। I am leaving it to you, जो भी आपको यहाँ पे आंसर मिले that will be the answer to this question, ठीक है। 641 minus 64 into 3, ये बात समझ में आती है? Is it clear? अब हम बेटा डिफाइन करेंगे something called as consumption function because this is also linear. कंजम्पशन फंक्शन भी लीनियर ही होता है, इसलिए हम कंजम्पशन फंक्शंस को भी डिफाइन करेंगे। बेटा कंजम्पशन फंक्शन हो जाता है c इज इक्वल टू c बार प्लस स्मॉल cy, वेयर c बार इज ऑटोनॉमस कंजम्पशन। बेटा व्हाट वाज दिस, ये एक इंटरसेप्ट टर्म था। इंटरसेप्ट टर्म क्या होता है कि जब भी हम whenever we plug this independent variable 0, whatever value we get for dependent variable, that is the intercept term, ठीक है। यहाँ पे this y is the income of consumer and small c is called marginal propensity to consume। बेटा you remember ये था slope term, so this basically tells us how consumption changes as income changes, ये slope term है, and this is called as marginal propensity to consume। इसको हम क्या बोल देते हैं, इसको हम बोल देते हैं marginal propensity to consume, ठीक है। अच्छा बेटा अब हम इसमें बोल क्या रहे हैं, what are we going ahead and what are we saying? So basically we are going ahead and we are saying that marginal propensity to consume ये बताता है कि how consumption changes as income changes, how consumption changes as income changes, how consumption changes as income changes। क्लियर हुई बात? अच्छा, नाउ लेट अस ट्राई टू गो अहेड एंड टेक अ क्वेश्चन और उससे ये चीज आपको पूरी क्लियर हो जाएगी। So बेटा ईयर 1930, 1975, 2000, टाइम पीरियड -30, 15 and 40, ठीक है, and you are given that the consumption estimate, ठीक है, आपको कंजम्पशन का एक फंक्शन दिया हुआ है, कंजम्पशन फंक्शन है 95.05 प्लस 0.712 y, ये आपका एक कंजम्पशन फंक्शन दिया हुआ है, ठीक है बेटा। कंजम्पशन फंक्शन को पहले हम डिफाइन करते हैं कि ये क्या रहेगा, ये इसकी जरूरत नहीं है, डायरेक्टली वील वर्क विद कंजम्पशन फंक्शन। लेट अस ट्राई टू डिफाइन कि कंजम्पशन फंक्शन इसमें क्या रहेगा। बेटा इफ आई पुट इनकम एज 0, y को अगर हम 0 रखते हैं तो c will come as 95.05. So we can say that when income is 0, on an average जो हमारा कंजम्पशन है that is 95.05. बेटा you may ask me ma'am why you have used the word on an average. इसको समझने के लिए अभी हम थोड़ा अर्ली स्टेज पे हैं। ये वर्ड ऑन एन एवरेज क्यों यूज हुआ है ये हम इकोनोमेट्रिक्स में एक्सप्लेन करते हैं। तो अभी के लिए अगर बिकॉज यू आर न्यू टू इकोनॉमिक्स, अभी इकोनोमेट्रिक्स विल बी अ डिफिकल्ट थिंग, तो वी कैन जस्ट रिमूव दिस ऑल्सो। आप सिंपल समझो कि अगर हमने y को 0 प्लग इन किया तो कंजम्पशन 95.05 आ गई। सो व्हेन इनकम इज 0 कंजम्पशन इज 95.05। बेटा नाउ वी डू dc by dy एंड dc by dy आ जाता है 0.712। सो हम बोल सकते हैं कि एज इनकम इंक्रीजेस बाय 1 यूनिट, अगर चेंज इन इनकम 1 यूनिट से है, कंजम्पशन इंक्रीजेस बाय 0.712 यूनिट्स, कंजम्पशन इंक्रीजेस बाय 0.712 यूनिट्स, ठीक है। इज इट क्लियर बेटा, ये क्लियर हो गया, ठीक है। सो अब एक और क्वेश्चन ले लेते हैं। सो आपको एक डिमांड फंक्शन दिया हुआ है, वी नो डिमांड इज नेगेटिवली रिलेटेड टू प्राइस, इसीलिए यहाँ पे नेगेटिव साइन आ रहा है, एंड यू आर गिवन वन सप्लाई फंक्शन अल्फा प्लस बीटा वाई। We know supply is positively related to price, that's why there is a positive sign, here there is a negative sign. बेटा equilibrium कहाँ होता है? Equilibrium is where demand is equal to supply. So if I do A minus BP equal to alpha plus beta P and solve for P, P के लिए solve करो, इसको यहाँ ले जाओ, इसको यहाँ, so A minus alpha is equal to beta plus B times P, तो बेटा यहाँ से P आ जाएगा A minus alpha upon beta plus B, A minus alpha upon beta plus B. बेटा this is your equilibrium price, ये आपका equilibrium price हो गया। What your equilibrium price is telling? Wherever demand is equal to supply, that is what your equilibrium price is telling you. ये आपका इक्विलिब्रियम प्राइस हो गया। अब अगर इक्विलिब्रियम प्राइस आ गया है तो आप इक्विलिब्रियम क्वांटिटी भी निकाल सकते हो, है ना। अच्छा एक बात बताओ, इफ जस्ट थिंक अबाउट दिस, हाँ बेटा ये डिमांड है, ये सप्लाई है, ये इक्विलिब्रियम प्राइस आ गया, दिस इज पी स्टार। इफ प्राइस इज ग्रेटर देन इक्विलिब्रियम प्राइस तो क्या होगा हियर, माने सप्लाई विल बी मोर देन डिमांड। So supply will be more than demand, which means beta there will be excess supply. And if price will be less than equilibrium price, which means here, so beta demand will be more than supply, which means excess demand, which means excess demand. ठीक है? Is it clear? Okay. Now we will talk about the general equation for a straight line. general equation for straight line. Beta, the general equation of straight line looks like this. Ax plus by plus c equal to 0. Ax plus by plus c equal to 0. ठीक है. अब अगर इसको आई सॉल्व इट फॉर y तो क्या आ जाएगा? by equal to minus ax minus c. y equal to minus a by b x minus c by b. बेटा यही तो, अगर मैं इसको कंपेयर करूं y is equal to ax plus b से, तो यही तो स्लोप हो गया एंड ये इंटरसेप्ट हो गया, है ना. So we can say that if the equation of line is given in this format, अगर इस format में equation of line given है, तो slope will be minus a by b, intercept will be minus c by b. समझ गए? Okay. Question. Solve the equation graphically. Solve the pair of equation graphically. X plus y equal to 5, x minus y equal to minus 1. Beta, we have to solve these two pair of equations graphically. हमें graphically solve करना है. ठीक, तो बहुत ही सिंपल है. हमें पॉइंट ऑफ इंटरसेक्शन तो निकालना है, बट हमें ग्राफ प्लॉट करना है. तो देखो बेटा, x प्लस वाई इक्वल टू 5 माने x प्लस वाई माइनस 5 इक्वल टू 0. तो बेटा व्हाट विल बी द इंटरसेप्ट ऑफ दिस लाइन? Intercept will be minus c by b. Minus c is what? Minus 5. And b is what? 1. तो intercept हो गया 5. And slope is what? बेटा slope है minus a by b. a is what? 1. b is what? 1 minus 1. माने ये जो लाइन है, this line has an intercept of 5 and slope of 1. Slope of 1 माने perpendicular by base will be 1. तो माने अगर ये 5 है तो ये भी 5 ही होगा. This will be my line. ठीक है. स्लोप 1 माने जब ये 4 होगा ये 1 होगा, ये 3 होगा ये 2 होगा, ये 2 होगा ये 3 होगा, ये 1 होगा ये 4 होगा. 1 1 से इंक्रीमेंट करेगा. नाउ लुक एट द सेकेंड वन. x माइनस वाई इक्वल टू माइनस 1. बेटा ये हो गया x माइनस वाई प्लस 1 इक्वल टू 0. तो व्हाट विल बी द स्लोप ऑफ दिस लाइन? माइनस a बाई b. a है 1, b है माइनस 1. And what will be the intercept? Minus c by b माने 1. तो इंटरसेप्ट ऑन द y एक्सिस 1 है एंड स्लोप क्या है? स्लोप पॉजिटिव 1 है. स्लोप पॉजिटिव 1 है तो माने दिस. ठीक है, माने दिस. सो ट्राई टू अंडरस्टैंड. इंटरसेप्ट 1 है, फिर नेक्स्ट पॉइंट क्या होगा? ये 1 से बढ़ेगा तो ये भी 1 से, ये 1 से बढ़ेगा तो ये भी 1 से, ये 1 से इंक्रीज होगा तो ये भी 1 से. दिस विल बी द कोऑर्डिनेट्स ऑफ दिस लाइन. स्लोप इज 1. परपेंडिकुलर और बेस दोनों 1 1 से चेंज हो रहे हैं और दोनों इंक्रीज हो रहे हैं बिकॉज स्लोप इज प्लस 1. स्लोप इज प्लस 1 माने अगर पहला कोऑर्डिनेट यहाँ पे 1,0 है तो नेक्स्ट कोऑर्डिनेट अगर यहाँ पे मैं पॉइंट 1 लेती हूँ तो यहाँ पे 2 लेना पड़ेगा, यहाँ पे 2 लेती हूँ तो यहाँ पे 3 लेना पड़ेगा, यहाँ पे 3 तो यहाँ पे 4. दिस इज द लाइन. यहाँ स्लोप -1 का था माने अगर यहाँ पे 5 लेते हैं तो अगर यहाँ 1 लेंगे तो यहाँ 4 लेंगे, यहाँ पे 1 डिक्रीज होगा तो यहाँ 1 इंक्रीज. Here if I take 2, here I will take 3. Here if I take 3, here I will take 2. So it has to decrease. If 1 is increasing, other will decrease by 1. So where do I see the intersection? X is 2 and y is 3. X is 2 and y is 3. तो बेटा इक्विलिब्रियम क्या आ गया? x equal to 2 and y equal to 3. Clear हुई बात? Okay. At last, beta, I want to talk about linear inequalities. Linear inequalities. Linear inequalities को plot करने के लिए what we do is we have to put, first we have to plot the line, beta. Then we put x and y as 0. If the statement is true, then we will shade towards origin. And if the statement is false, then we will shade away from origin. ठीक है, let's see कैसे होगा. 2x Hmm. 2x plus y less than equal to 4. पहले we draw the line. बेटा लाइन को ड्रॉ करने के लिए पुट x as, लाइन क्या होगी इसकी कॉरेस्पॉन्डिंग 2x plus y equal to 4. Put x as 0. y क्या आ रहा है? If I put x as 0, y will be 4. Put y as 0. अगर यहाँ 0 प्लग इन किया, so 2x equal to 4, so x will be 2. तो एक कोऑर्डिनेट आ जाता है x2 y0, एक कोऑर्डिनेट आ जाता है x0 y4. ये हो गई हमारी लाइन. दिस विल बी अवर लाइन. नाउ we have to see where the shaded area will be. So we will put x0, y0. So we are getting 0 less than equal to 4. क्या ये true है कि 0 is less than 4? Yes. If it is true, you will shade towards the origin. If it is true, you will shade towards the origin. So this will be your area. ठीक है? Is this clear, beta? Good. So I hope that you are clear with linear lines, linear equality, linear inequality. इसी के साथ ये टॉपिक खत्म होता है बेटा. In the next session, I will begin with polynomials, exponentials and powers. Okay, beta. Thank you. हेलो बेटा, गुड इवनिंग एवरीवन. बेटा आज हम बात करेंगे क्वाड्रेटिक इक्वेशंस की. We'll be talking about quadratic equations today. बेटा क्वाड्रेटिक इक्वेशंस को हम कैसे लिख सकते हैं? What is the form of quadratic equation? Quadratic equation can be written like this. fx is equal to ax square plus bx plus c, where a, b and c they are some constants. a, b और c कुछ constants हैं और ये हमारा फंक्शन है fx is equal to ax square plus bx plus c. ठीक है बेटा, whenever you see a square term and that's the highest power, माने 2 highest power है, तो the shape of the function will be a parabola. फंक्शन एक पैराबोला हो जाएगा, राइट? अब दिस पैराबोला कैन बी एनीथिंग. हाँ, ये भी एक पैराबोला है, ये भी एक पैराबोला है, ये भी एक पैराबोला है. तो पैराबोला तो कुछ भी हो सकता है, राइट? सो व्हेनेवर यू गो अहेड एंड व्हेनेवर यू सी अ स्क्वायर टर्म, जब भी आप एक स्क्वायर टर्म देखते हो तो आप जो द whenever you see the highest power as 2, तो we are clear that it is going to be a parabola. वो एक पैराबोला होगा, ठीक है? बट व्हाट एग्जैक्टली विल बी द शेप ऑफ द पैराबोला? उस पैराबोला की शेप क्या होगी? दैट वी कैन नो ओनली बाय अंडरस्टैंडिंग द वैल्यूज ऑफ ए, बी एंड सी. वो हमें सिर्फ तब पता चल सकती हैं कि हाउ ऐसा दिखेगा, ऐसा दिखेगा, ऐसा दिखेगा, इंटरसेप्ट कहां पे होगा, वो ए, बी एंड सी का वैल्यू से हमें पता चलेगा. इज इट क्लियर? सो देयर आर डिफरेंट केसेस दैट वी हैव, ठीक है? वो केसेस के थ्रू वी विल अंडरस्टैंड द शेप ऑफ द पैराबोला. सो केस नंबर 1 बेटा, इफ a is less than 0 and b is greater than 0, a parabola looks like this. if a is greater than 0, b is less than 0, parabola looks like this. If a is greater than 0 and b is greater than 0, a parabola looks like this, but with intercept on the x-axis. With intercept on the x-axis. यहाँ पे intercept x-axis पे नहीं है. Intercept is not on the x-axis, right? अब ये कैसे पता चलेगा? मैम, इट इज सो डिफिकल्ट, इसको हम याद थोड़ी रख सकते हैं. वी कैन नॉट मेमोराइज, दिस इज मैथ्स. No problem. We can go ahead and we can learn, we can understand this. कि ये कैसे हो रहा है. In order to understand this thing, but first of all, we need to understand what is called as the roots of quadratic equation. पहले हमें ये समझना पड़ेगा कि quadratic equation के roots क्या होते हैं. Roots of quadratic equation. ठीक है बेटा, if I have a quadratic equation ax square plus bx plus c, so those x's which solve this equation equal to 0, वो वाले x जिनको अगर हम प्लग इन करें तो ax square plus bx plus c 0 हो जाए, उन x's को हम रूट of quadratic equation बोलते हैं. They are called as root of quadratic equation. So what is the root of a quadratic equation? Those x's such that the quadratic equation becomes 0. वो x's जिस तरह से, ऐसे x's जिसकी वजह से quadratic equation 0 हो जाए, तो उन x's को हम root of quadratic equation बोल सकते हैं. उन x's को हम रूट ऑफ क्वाड्रेटिक इक्वेशन बोल सकते हैं. इज इट क्लियर? ठीक है. तो अब वो एक्सेस हम कैसे निकाल सकते हैं? देयर आर टू मेथड्स बेटा. देयर आर टू मेथड्स. ठीक है. मेथड नंबर 1 इज वेरी सिंपल कि इसका एक फॉर्मूला है, x इज इक्वल टू माइनस बी प्लस माइनस रूट बी स्क्वायर माइनस 4ac बाई 2a. सिंपल, ये फॉर्मूला. बेटा मेथड नंबर 2 एक्चुअली इस फॉर्मूला का डेरिवेशन है, विच इज कॉल्ड एज कंप्लीटिंग द स्क्वायर मेथड. तो कंप्लीटिंग द स्क्वायर मेथड से ये फॉर्मूला भी डिराइव होता है. वी डिराइव दिस फॉर्मूला यूजिंग कंप्लीटिंग द स्क्वायर मेथड एंड उससे भी रूट्स ऑफ इक्वेशन निकलते हैं. सो लेट्स गो अहेड एंड से fx इज इक्वल टू ax स्क्वायर प्लस bx प्लस c. बेटा हम क्या करेंगे? वी विल गो अहेड एंड वी विल टेक a कॉमन. जैसे हमने a कॉमन लिया, वी विल गेट x स्क्वायर प्लस b बाय ए एक्स प्लस c बाय a. ध्यान से सुनो मेरी बात, क्या कर रही हूं मैं बेटा. इफ यू रिमेंबर, a प्लस b होल स्क्वायर होता है a स्क्वायर प्लस b स्क्वायर प्लस 2ab. तो यहां पे हमारा एक 2 का फैक्टर आता है. वी हैव अ फैक्टर ऑफ 2. वही फैक्टर मुझे यहां पे चाहिए. आई नीड अ फैक्टर ऑफ दैट हियर. हाँ, तो क्योंकि आई नीड अ फैक्टर ऑफ 2 हियर, मुझे एक 2 का फैक्टर चाहिए. व्हाट आई एम गोइंग टू गो एंड डू इज, ये b बाय a है ना, आई विल डिवाइड एंड मल्टीप्लाई विद 2. आई विल डिवाइड एंड मल्टीप्लाई विद 2. इतना बात समझ में आती है? इज इट क्लियर? सो दिस विल बिकम a x square plus 2 b by 2a into x plus c by a. अच्छा, अब लिसन टू मी अगेन. देखो बेटा, जो भी यहां फैक्टर आता है, जैसे इफ आई अगेन गो बैक टू a प्लस बी होल स्क्वायर, दैट इज a स्क्वायर प्लस b स्क्वायर प्लस 2ab. तो अगर हम इसको a स्क्वायर माने और इसको 2ab माने, तो हमें एक b स्क्वायर का टर्म चाहिए होगा. वी वुड नीड वन b स्क्वायर टर्म. वी आर जस्ट कंपेयरिंग इट विद द एक्चुअल फॉर्मूला. इफ आई कंसिडर x स्क्वायर एज a स्क्वायर, राइट, देन x इज a. 2 का 2 I have been able to get here. So this is my b term. So I need a plus b square here. तो what I will do now बेटा, b क्या है? b by 2a. ये वाला टर्म इसके अकॉर्डिंग b वाला टर्म है. है ना? So what I need to do is I need another term now which will be b by a whole square. I write this as a x square plus 2 b by a x plus b by a whole square minus b by a whole square. And एक 2 भी था ना यहाँ पे, so I will write 2 also there. तो अब मैंने क्या किया ना, ये जो भी यहाँ टर्म आ रहा था I have added and subtracted that term plus c by a. अब if I look at this aspect बेटा, अगर हम इस aspect की तरफ ध्यान दें, you will notice that this is x plus b by 2a whole square. x plus b by 2a whole square. इसका इनडायरेक्टली मैंने क्या किया, मैं इसको एक कंप्लीट स्क्वायर बना रही हूँ. दैट इज व्हाई इट्स कॉल्ड कंप्लीटिंग द स्क्वायर मेथड. I have made this into a complete square, x plus b by 2a whole square, and then minus b by 2a square plus c by a into a. Is it clear? Now what we can go ahead and what we can do beta is that we can now, because ये completing the square तो हो गया है, so now I can just open this up. तो ये हो जाएगा a times x plus b by 2a whole square minus b square by 4a square into a plus c by a into a. This will be minus b square by 4a. एक a cancel हो जाएगा, this will cancel, plus c, and this will be a x plus b by 2a whole square, right? So it will be minus, if I take minus common, b square minus 4ac by 4a. This will be a x plus b by 2a whole square. Clear हुआ बात? Is it clear? ठीक है. Now if I have to go ahead and if I have to ask you कि बेटा ये जो टर्म था, ये जो मेरा fx था, इस टर्म को, this term, I have rewritten it as this term. इसको मैंने ऐसे लिख लिया है. I have rewritten it like this term. बेटा I am asking कि when will this term be 0, क्योंकि मुझे इसको 0 plug in करना था. So if I solve it, so what will happen? I can take this term on the other hand, a x plus b by 2a whole square equal to b square minus 4ac by 4a. A can go on the other side. X plus b by 2a whole square equal to b square minus 4ac by 4a square. I can take under root on both sides. तो जैसे हम अंडर रूट लेते हैं प्लस माइनस आंसर हो जाता है. सो x प्लस b बाय 2a विल बी प्लस माइनस b स्क्वायर माइनस 4ac अंडर रूट, एंड 4a स्क्वायर का अंडर रूट विल बी 2a. So x will become minus b by 2a plus minus b square minus 4ac by 2a under root, which means minus b plus minus root b square minus 4ac by 2a. जो ये फॉर्मूला था, we have derived this formula. We have derived this formula. ये बात समझ में आती है? अब बेटा क्वेश्चन आता है, the shape of parabola. Shape of parabola. अब मुझे एक बात बताओ, come back to this. हाँ, इधर ही वापस आते हो, वापस देखो एक बार. In order to understand the shape of parabola, अगर मुझे parabola का shape समझना है, तो मुझे एक बात बताओ कि if we have x equal to minus b by 2a, अगर हम x equal to minus b by 2a करते हैं, so this part will become 0 बेटा. और जैसे ये पार्ट 0 होगा, इफ दिस पार्ट विल बी 0, तो ये वाला जो पार्ट है, बिकॉज इट हैज अ नेगेटिव साइन, तो ये वाला जो पूरा पार्ट है, दिस विल बी the value which will be maximum or minimum. Let me repeat it. Let me again do it. देखो, मेरी बात बहुत ध्यान से सुनो. Let me repeat it again. देखो, ये जो है इसका हम स्क्वायर कर रहे हैं. तो किसी भी नंबर का अगर हम स्क्वायर करते हैं वो ग्रेटर देन इक्वल टू 0 होता है. Whenever we square any number, it is greater than or equal to 0. यही होता है. अगर ये स्क्वायर ग्रेटर देन 0 है, माने यहां पे कुछ पॉजिटिव आ रहा होगा, एंड लेट्स से कि a भी ग्रेटर देन 0 है, तो ये भी पॉजिटिव होगा. तो बेटा पॉजिटिव इंटू पॉजिटिव तो कुछ पॉजिटिव होगा, और पॉजिटिव में से जब हम कुछ सब्ट्रैक्ट करेंगे, वील सब्ट्रैक्ट सम नंबर फ्रॉम पॉजिटिव, तो हमें जो आंसर मिलेगा वो लेस देन दिस पॉजिटिव नंबर होगा. इज इट मेकिंग सम सेंस? वो लेस देन दिस पॉजिटिव नंबर होगा. बट इफ दिस, देखो मैंने बोला या तो ये पॉजिटिव होगा माइनस समथिंग. दूसरा पॉसिबिलिटी ये है कि ये जो हम स्क्वायर कर रहे हैं ये वाली वैल्यू 0 आ जाए. स्क्वायर ऑफ अ नंबर इज इधर 0 और पॉजिटिव. तो पॉजिटिव होगा, पॉजिटिव में से कुछ अमाउंट सब्ट्रैक्ट किया. सपोज दिस वैल्यू कम्स आउट एज 10 और ये वैल्यू आई 2. तो 10 माइनस 2 तो 8 हो गया बेटा. 10 माइनस 2 8 हो गया. बट इफ दिस वैल्यू कम्स आउट टू बी 0, अगर ये वैल्यू 0 है, तो 0 माइनस 2 तो -2 हुआ ना. आर यू अंडरस्टैंडिंग इट? तो माने हम 0 में से कुछ सब्ट्रैक्ट कर रहे हैं वर्सेस हम कुछ पॉजिटिव नंबर में से कुछ सब्ट्रैक्ट कर रहे हैं. सो इट इज बेटर इफ आई सब्ट्रैक्ट फ्रॉम 0, आई एम गेटिंग द लीस्ट नंबर. इट मीन्स व्हेन a इज पॉजिटिव, ये पॉजिटिव है, तो ये बिकॉज ये वाला हमेशा पॉजिटिव होता है, नॉन नेगेटिव होता है, या पॉजिटिव होता है या 0 होता है. अगर ये वाला नंबर पॉजिटिव होगा, सो आई विल बी गेटिंग समथिंग, सम बिगर नंबर. बट अगर ये नंबर 0 होगा, आई विल बी गेटिंग द लीस्ट पॉसिबल नंबर. सो वी आर सेइंग कि इफ a इज ग्रेटर देन 0, अगर a ग्रेटर देन 0 है, देन द फंक्शन अटेन्स इट्स मिनिमम. बेटा कब फंक्शन मिनिमम अटेन कर रहा है? एट x इक्वल टू -b/2a. जब x इक्वल टू एग्जैक्टली -b/2a होगा, इसका ऑपोजिट होगा, ताकि ये 0 बन जाए, फंक्शन अपना मिनिमम वैल्यू पे होगा. एंड व्हाट विल बी द वैल्यू ऑफ द फंक्शन? अगर मैं x इक्वल टू -b/2a प्लग इन करूंगी, आई विल गेट द वैल्यू ऑफ द फंक्शन एज दिस. यही तो आ जाएगी वैल्यू ऑफ द फंक्शन, इजंट इट? So this will be the minimum value of the function. So the minimum value of the function will be minus value will be minus b square minus 4ac by 4a. b square minus 4ac by 4a. ये बात समझ में आई? Is it making sense? तो ये हो जाएगा, if I solve this, c minus b square by 4a. This will be minimum value of the function. Reverse is true when a is less than 0. If a is less than 0, अगर a नेगेटिव है, if a is less than 0, तो बेटा just try to think, ये एक नेगेटिव नंबर है, ये एक नेगेटिव नंबर है, ये हमेशा ग्रेटर देन इक्वल टू 0 होगा बिकॉज इट्स स्क्वायर. तो अगर तो ये 0 होता है, इफ दिस इज 0, तो 0 माइनस समथिंग, जैसे ये वाला वैल्यू सपोज 10 है, तो 0 माइनस 10 हो गया -10. और व्हाट्स द अदर थिंग कि ये चीज ग्रेटर देन 0 आ जाए, पॉजिटिव आ जाए, है ना. दैट्स द सेकेंड थिंग. सो नेगेटिव इंटू पॉजिटिव माने नेगेटिव, तो ये पूरा चीज नेगेटिव होगा. नेगेटिव में सपोज इस चीज का वैल्यू आ गया -10, तो -10 और ये भी 10 है, -10 -20, माने ये सबसे हाईएस्ट पॉसिबल वैल्यू है. -10 इज ग्रेटर देन -20. सो व्हेन a इज नेगेटिव, अगर a नेगेटिव है, तो ये या पॉजिटिव होगा या 0 होगा. if this is 0 तो सिर्फ इतना नेगेटिव वैल्यू बचेगा, बट इफ दिस इज पॉजिटिव, positive into negative will become negative. So we have two negative numbers, so it will be a bigger negative number. Bigger negative number मतलब उसका वैल्यू गिर गया एक तरीके से. So if a is less than 0 तो हम एक मैक्सिमा अटेन करते हैं, और मैक्सिमा कब होगा? when this term is 0. So when x is, we attain a maxima when x is minus b by 2a. और वैल्यू क्या हो जाएगी मैक्सिमा की? सेम बेटा, c minus b square by 4a. बाकी सब सेम है, एवरीथिंग इज द सेम. सो व्हाट हैपेंस इज वी कैन से कि डिपेंडेंट ऑन द शेप ऑफ ए, हमें पता चल गया वेदर वी अटेन मैक्सिमा और मिनिमा. इफ ए इज ग्रेटर देन 0 तो वी हैव अटेन्ड अ मिनिमा. मिनिमा माने शेप ऑफ पैराबोला ऐसा हो गया, मिनिमम आ रहा है. व्हेन ए इज लेस देन 0 वी हैव अटेन्ड अ मैक्सिमा. मैक्सिमा माने shape of parabola becomes this. So depending on the shape of on the value of a, we will attain minima or maximum. Is it clear? One question, उससे आपको सब कुछ समझ में आएगा. So I'm just writing a question now. तो आपको मैक्सिमा या मिनिमा पॉइंट बताना है, एंड देयर बाय यू हैव टू फाइंड आउट द शेप ऑफ द फंक्शन. ठीक है. So okay, write down the question. The question is fx equal to x square minus 4x plus 3. Write down कि इसका मैक्सिमा या मिनिमा होगा तो क्या वैल्यू रहेगा, एंड हेंस प्लॉटेड. ठीक है. गिव अ अप्रोक्सीमेट शेप. तो देखो बेटा, x स्क्वायर माइनस 4x. अब हम 4x को कैसे सॉल्व करेंगे बच्चे? हाउ डू वी सॉल्व 4x? यू डिवाइड बाय 2 एंड यू मल्टीप्लाई बाय 2. ऐसे ही करते हैं. और जो भी ये वाला वैल्यू होगा, इसी वैल्यू को यू विल एड इट्स स्क्वायर एंड सब्ट्रैक्ट इट्स स्क्वायर प्लस 3. ठीक है. लेट्स ट्राई दिस. So now if I just notice here what is going to happen, बेटा इसका तो कंप्लीटिंग द स्क्वायर से वी गेट x प्लस 2 होल स्क्वायर, क्योंकि ये 4/2 तो 2 ही है ना. सो 4/2 कैन सिंपली बी रिटन एज 2. 4/2 कैन सिंपली बी रिटन एज 2. ठीक है. सो -4 प्लस 3, तो ये हो जाएगा x प्लस 2 होल स्क्वायर माइनस 1. ठीक है. अब देखो व्हाट इज द वैल्यू ऑफ a बेटा? a इज 1 ना, विच इज ग्रेटर देन 0. ठीक है. तो सिंस इट इज ग्रेटर देन 0, बिकॉज a इज 1 एंड इट इज ग्रेटर देन 0, तो हमें ये समझ में आता है दैट whenever a is positive you attain a minima. So therefore minimum attained. ठीक है. व्हाट इज द मिनिमम वैल्यू? वेयर विल यू अटेन द मिनिमम बेटा? जहां पे भी ये 0 होगा. तो x प्लस 2 इक्वल टू 0 माने मिनिमा हो गया x इक्वल टू -2 पे. और फंक्शन का -2 पे मिनिमम वैल्यू क्या आ रहा है? -1. सो दिस इज द मिनिमम वैल्यू दैट यू हैव अटेन्ड. इज इट क्लियर? क्लियर. ठीक है. सो दिस इज हाउ यू कैन गो अहेड एंड यू कैन सॉल्व दिस क्वेश्चन. ठीक है. So expression attains the smallest value, minimum value at x equal to -2, and the value that at x equal to 2 beta, sorry, this will be minus x minus 2 whole square. ये negative sign है ना. So because this is negative sign, actually this is a minus b whole square. a minus b whole square. ठीक है. तो this is x minus 2. I'm sorry. So this will be minus. This will be plus. So x attains the minimum value at x equal to 2, and the minimum value attained is -1. Minimum value attained is -1. ये बात समझ में आती है? Is this clear? So this is how you can go ahead and you can solve any question for completing the square. ठीक है. अब इसी के basis पे बेटा there is an application which we can go ahead and do. So usually जो हम कॉस्ट फंक्शंस लिखते हैं वो हम the cost functions that we go ahead and we write, वो usually cubic functions होते हैं. But as an exception, if you look into Sitsader and Hammett, it has given a monopoly जिसका cost function जो है वो quadratic cost function है. So what we are going to go ahead and do is that we are now going to, in the next class, work with an example जिसमें हमें quadratic cost function के लिए we will go ahead and we will solve the equilibrium. We'll try to find कि cost function कैसा दिखेगा, equilibrium कैसे आएगा, and supply function क्या होगा. So that is what we want to do in the next class. Okay, beta. Thank you. But in the last class, we talked about the quadratic functions. And today I want to go ahead and I want to talk about the polynomial functions. Right. In particular, I want to talk about the cubic functions. Okay. But kya tha? What was a linear function? A linear function was of the form fx is equal to ax plus b. What was a quadratic function? A quadratic function was of the form fx is equal to ax square plus bx plus c. Now, what will be a cubic function? A cubic function will be of the form fx is equal to ax cube plus bx square plus cx plus d. So when we talk about a cubic function, जो highest power होता है x का, that is 3. You will notice that this power, highest power of x, that is 3. So when the highest power is 3 beta, उसको हम cubic function बोल देते हैं. In general, any polynomial function px can be written as ax to the power n plus bx to the power n minus 1 and so on till some variable, so यहाँ some constant, suppose z, x to the power 1 plus another constant, यहाँ पे हम लिख सकते हैं से plus a naught. ठीक है, या इसको ऐसे भी लिख सकते हैं an x to the power n plus b plus a n minus 1 x to the power n minus 1 plus ax plus a1 x1 plus a naught. This is the general form of your polynomial function. इसको हम general form बोल सकते हैं polynomial function. ठीक है. Now, what we want to go ahead and what we want to do is कि एक बारी हमारा ये general form आ गया, so try to understand that your this constant beta an, it should be non-zero, क्योंकि अगर ये zero हुआ तो ये nth power निकल जाएगा. I am writing the general form of the nth polynomial जिसका highest power n है, जैसे यहाँ पे a cubic function is any function whose highest power is 3. Right? So if this a becomes 0, अगर ये a ही 0 हो जाएगा, so automatically I understand that it will become a quadratic function. If I want this to be a cubic function, I want to make sure that the highest power 3 is there. And for the highest power to be 3 to be intact, I want to make sure that a is not equal to 0. This part has to be intact. Similarly, here beta, if I want x to the power n to be intact, I want the highest power of this polynomial to be n. तो मुझे ensure करना होगा कि an जो है वो non-zero है, right? For example, if n is 4, my polynomial will become a4x4, a3x3, a2x square, a1x, a0. Okay. And for this polynomial to be a polynomial with highest power 4, I have to ensure कि ये जो a4 constant है, this should be non-zero. This should be non-zero. ये बात समझ में? Now, if I talk about the zeros of the polynomial. Zeros माने the, if I talk about the factors of the polynomial, है ना? So what were the factors of polynomial या zeros of polynomial? Anything such that px equal to 0. ठीक है, तो अगर मुझे एक nth order polynomial को solve करके उसके factors निकालने हैं, हाँ, तो it will be an x to the power n, an minus 1 x to the power n minus 1, an minus 2 x to the power n minus 2 plus a naught equal to 0. I will equate it to 0, right? And all those x's which will solve this equation, जो भी x's इस equation को solve करेंगे, all those x's which will solve this equation, but they will be called as the factors of this equation. ठीक है, all possible x's that will solve this equation will be called as the factors of this equation. ठीक है, similarly अगर मेरे पास एक cubic equation होता है, a3x to the power 3, a2x square, a1x plus a naught, those x's which solve this cubic equation become the factors of this cubic equation or the zeros of this equation ये बात समझ में आती है? अच्छा, अब एक और चीज है, let's take an example. So suppose if I tell you find the zeros of x cube minus 2x square plus x minus 2 equal to 0. Because मुझे zeros निकालने हैं, I will equate it to 0. So what I can go ahead and what I can do is, question is asking, find all possible x's such that this equation is satisfied. ठीक है, but question ने थोड़ा सा एक tweak कर दिया question को, and it is also asking you find all possible integer roots to the equation. Find all possible integer roots to the equation. Right, find all possible integer roots to this equation. अब ध्यान से मेरी बात सुनना, हाँ बेटा, क्या करते हैं हम, कैसे निकालते हैं? सबसे पहले हम इस फैक्टर पे जाते हैं, ये है -2, और हम -2 के इंटीजर्स बनाते हैं, माने -1 into 2 is -2, -2 into 1 is -2, 2 into -1 is -2, 1 into -2 is -2. तो इसके जो पॉसिबल इंटीजर रूट्स हो सकते हैं, अगर हम इसके पहले फर्स्ट ऑफ ऑल वी आर फाइंडिंग द फैक्टर्स ऑफ दिस -2. अगर हम इस -2 के पॉसिबल फैक्टर्स निकालें बेटा, सो वी गेट द पॉसिबल फैक्टर्स एज -1, -2, 2 and 1. दैट मीन्स +-1 एंड +-2. ठीक है, ये इसके पॉसिबल फैक्टर्स हो गए. What we can go ahead and do is we can put these possible factors in this equation and see which of them satisfies the value of the equation. कौन सा इन चारों को डाल के देखेंगे हम इस equation में, और देखेंगे कि कौन सा ऐसा x है जिसको डालने से ये equation equal to 0 plug in हो पा रहा है. So let's say I begin with x equal to 1. So 1 cube minus 2 into 1 square plus 1 minus 2. तो बेटा 1 minus 2 plus 1 minus 2, 2 minus 2 minus 2, this is not equal to 0. ठीक है, now let's put x as -1. So I'll get -1 cube minus 2 into -1 square plus -1 minus 2. तो हो जाएगा -1 minus 2 into 1 -1 minus 2. That means this is also not equal to 0. फिर हम ट्राई करेंगे बेटा x equal to 2. 2 cube minus 2 into 2 square plus 2 minus 2. This is giving me 0. This is giving me 0. तो if this is giving me 0, तो हमारा पहला रूट 1 निकल के आ जाता है, that x equal to 2 satisfies this equation. x equal to 2 satisfies this equation. तो अगर बेटा x equal to 2 इस equation को satisfy करता है, तो हमारा जो first root हो जाता है वो हो जाता है x minus 2. Our first root will be x minus 2. So we have got one of the integer roots. क्वेश्चन था फाइंड ऑल पॉसिबल इंटीजर रूट्स, सारे ऐसा x का वैल्यूज निकालना था which would have satisfied this equation. I had to find all x's
which would have satisfied this equation. और मैंने एक x निकाल लिया है. I found one such x which satisfies this equation, which is x equal to -2. Is it clear? अब क्वेश्चन याद है कि how can we go ahead and how can we find the remaining x's? हम बाकी x's कैसे निकाल सकते हैं? That's the next question that we have. And that is pretty simple. But उसके लिए we have to go ahead and we have to learn something which is called as remainder theorem. हमें इसके लिए कुछ पढ़ना पड़ेगा और उसको हम बोल देते हैं remainder theorem. That is something I'm going to do in the next class. We'll continue with this question, but first I'll do the remainder theorem with you. Okay, beta. Thank you. Hello, beta. Good evening, everyone. So, beta, in the last class, we had started talking about the possible integer roots of an equation. हाँ, हमने एक पार्ट किया था जहां पे हमने integer roots की बात की थी. Today I want to begin the lecture by talking about remainder theorem first, and I want to find the remaining roots of that equation. तो एक बारी लिख लेते हैं बेटा. Write remainder theorem with me. Please write it with me, beta. Let Px and Qx be two polynomials for which the degree of Px is greater than Qx. Degree of Px greater than Qx माने क्या कि x का जो highest power होगा, whatever will be the highest power of x, that will be more for Px as compared to Qx, right? The highest power of x will be more for Px as compared to x. ठीक है? So greater than that of Qx, or it can even be equal to Qx, right? Then there always exists unique polynomial so we see that in such cases there exists a unique polynomial. कैसे? Qx and Rx such that Px equal to Qx into capital Qx. बेटा ये capital है, हाँ, don't get confused. ये भी कैपिटल है, ये स्मॉल है. सो Qx इंटू कैपिटल Qx प्लस Rx. बहुत सिंपल है, इतना बड़ी बात नहीं है. जैसे फॉर एग्जाम्पल अगर मैं आपको नंबर्स में बोलूं, सो आई कैन राइट 7 एज 3 into 2 plus 1, right? So माने if I divide 7 by 2, I get the remainder as 1. 2 3s are 6. So 7 can be written as 2 into 3 plus 1. Same holds with polynomials also, beta. Polynomials में भी ऐसा ही होता है that one polynomial is product of two polynomials plus the remainder polynomial. So where the degree of Rx is always less than the degree of Qx. Is always less than the degree of Qx. कैपिटल Qx. यहाँ पे भी यही है कि जो मेरा रिमाइंडर है वो हमेशा हमेशा इट विल बी लेस देन दिस नंबर. क्योंकि अगर रिमाइंडर सपोज 2 से ज्यादा होता, सपोज रिमाइंडर 3 होता, तो वापस 2 सब्ट्रैक्ट हो सकता था ना. आई कुड हैव डिवाइडेड इट मोर. सो रिमाइंडर हैज टू बी लेस देन दिस 2, राइट? तभी तो वो रिमाइंडर हुआ. ओनली देन इट इज अ रिमाइंडर, राइट? सो दिस इज एग्जैक्टली व्हाट होल्ड्स इवन इन केस ऑफ पॉलिनोमियल. ये बात समझ में आती है? इज इट क्लियर? ठीक है. Now what we want to go ahead and what we want to do is we want to go ahead and we want to write it in another format. तो जैसे मैंने लिखा बेटा कि Px equal to small qx into capital Qx plus Rx. ठीक है. If I divide throughout by Qx, so what will I go ahead and get? I will get Px by capital Qx equal to small qx into capital Qx upon capital Qx plus Rx upon capital Qx. ठीक है? I will get this. So now I can see clearly that this and this will cancel out. So I will get Px upon capital Qx
equal to small qx plus rx by capital Qx. Plus Rx by capital Qx. Now, beta, if Rx is 0, माने कोई रिमाइंडर नहीं है, जैसे जब हम यहां करते हैं, if I divide 6 by 2, so I get the remainder as 0. So I can simply write 6 as 2 into 3. So if Qx, if this remainder is 0, ये Rx 0 है, so I can simply write that Px by capital Qx will be small qx. Mane, I'll get Px as capital Qx into small qx. It means I can say that Qx is a factor of Px. Or I can say that Px is divisible by Qx. Px is divisible by Qx. ये बात समझ में आती है? Is it clear? ठीक है, एग्जैक्टली सेम जैसे नंबर्स में होता था. 6 is divisible by 2. 7 is not divisible by 2. You get a remainder of 1. ठीक है. Now, we have to understand that suppose if I tell you, say, my Qx is x minus a. तो बेटा डिग्री ऑफ Qx क्या हो गया? डिग्री ऑफ Qx हो गया x का पावर विच इज 1. So if the degree of x is 1, ध्यान से यहाँ पे एक बारी देखते हैं हम, that for which px is greater than qx or equal to qx, then there always exists this such that, हमने कहीं लिखा है, such that the degree of qx is less than rx is less than equal to qx. ठीक है. What does it mean? It means that यहाँ पे अगर qx है x minus 1, x minus a, तो x का पावर क्या हो रहा है बेटा? व्हाट्स द पावर ऑफ x? इट्स 1. तो rx में x का पावर हैज टू बी लेस देन qx, राइट? सो इट कैन ओनली बी 0. इट कैन ओनली बी 0. समझ रहे हो बात को? आई अगेन रिपीट व्हाट आई एम सेइंग. तो मैं यहां बोल रही हूं दैट लेट px एंड qx बी टू पॉलिनोमियल फॉर विच डिग्री ऑफ px इज ग्रेटर देन qx or equal to qx, there exist unique polynomials small qx and rx such that px can be written as this, and यहीं पे हमने एक condition लिख दी, and degree of rx is less than degree of qx. ये मेरा condition है. Now let's say मेरे पास एक qx दिया हुआ है. I'm given a qx which is x minus a. So I notice that the power of x is 1. If the power of x is 1, तो rx में रिमाइंडर में x का पावर 0 होना चाहिए, और किसी भी चीज का when its power is 0, then that value is 1. So if I go to my polynomial, जो हमने जनरल फॉर्म पॉलिनोमियल के पढ़े थे, जनरल फॉर्म ऑफ पॉलिनोमियल was ax to the power n, right? So यहाँ पे n is 0, power is 0, है ना? तो ax to the power 0 माने a into 1 माने a. Mane, this remainder, it is going to be a constant. My remainder will be a constant when qx will be x minus a. When qx will be x minus a. ये बात समझ में आती है? It will be a constant when qx will be x minus a. तो हम लिख सकते हैं that px will be small qx into x minus a plus rx, where rx is a constant in this case. rx is a constant in this case. Any constant, हाँ, आप वो constant को a भी लिख सकते हो, उस constant को आप small r भी लिख सकते हो, but it's not a function of x anymore. It's a constant. ठीक है. अच्छा, if this constant is 0, अगर इस constant का value 0 आ जाता है, then there is no remainder left. So we can say that x minus a is completely divides px. px is completely divisible by x minus a. ठीक है? It is completely divisible by x minus a. अच्छा, एक बात बताओ मुझे. Tell me something. Let's go back to this equation. What is my equation? Px is equal to qx x minus a plus r. Now, if I put x as a, I'll get P of a equal to Q of a minus a plus r. I'll get Q of a into 0 plus r. I'll get that as r. I'll get that as r. ठीक है बेटा, when will x minus a be a factor of px? कब x minus a px को डिवाइड करेगा कंप्लीटली? जब रिमाइंडर 0 होगा. So if r is 0, then x minus a will divide px, है ना? Then x minus a will divide px. अच्छा, और हमने इस केस में क्या देखा कि what is the value of a I am plugging in, x I am plugging in a, right? तो हम बोल सकते हैं कि what value of x will achieve that? X equal to a. So if at x equal to a, I get the remainder as 0, then I can say that x minus a is a factor of px. ठीक है, तो लिख सकते हैं that px has factor x minus a if and only if when you put a in the polynomial you get 0. यही तो था फैक्टर का डेफिनेशन. कब कोई किसी चीज का फैक्टर होता है? अगर वो वैल्यू प्लग इन करने पे वी गेट द आंसर एज 0, वो पॉलिनोमियल में हम 0 अचीव कर पाए, देन इट्स अ फैक्टर. ठीक है, लेट्स टेक सम क्वेश्चन हियर. सो प्रूव दैट polynomial fx equal to minus 2x cube plus 2x square plus 10x plus 6 has 0 at x equal to 3 and then factorize the polynomial. Has 0 at x equal to 3. 0 at x equal to 3 का क्या मतलब है? माने p of 3 should give me 0. When I plug value of x as 3, इस इक्वेशन में I should get 0. देखते हैं जरा सॉल्व करके बेटा. -2, 0 to the power 3 plus 2, 0 to the power 2 plus 10, 0. Sorry, not 0. X is 3 now. Plus 6. So what do I get? -2. 3 into 3, 9 into 3, 27, plus 2 into 9, plus 30, plus 6, minus 54, plus 18, plus 36, it is giving me 0. माने, when I plug x as 3, मेरा polynomial is getting 0. So therefore, ये देखो, जब हमने a प्लग किया था और 0 आ रहा था, तो x minus a एक फैक्टर बन रहा था. अब यहाँ पे जब हमने 3 प्लग किया, हमें 0 आ रहा है, तो x minus 3 will be one of the factors. x minus 3 will be one of the factors. ये बात समझ में आती है? ठीक है, तो x minus 3 से अब हम इसे डिवाइड करेंगे. We'll divide this by x minus 3. अब एक बारी listen to me very carefully कि ये डिविजन हम करते कैसे, how do we divide? तो देखो बेटा, ये x है और ये -2x क्यूब है. सिर्फ इस एंड इस फैक्टर को वी विल चेक. ठीक है, तो वी नो x इंटू -2x स्क्वायर कैन गिव मी -2x क्यूब. तो हम पहला फैक्टर लिखेंगे -2x स्क्वायर. ये बात समझ में आई? नाउ वंस आई राइट -2x स्क्वायर, तो इस पूरे को we will multiply with -2x square. So when I multiply x minus 3 with -2x square, मुझे मिलेगा -2x cube plus 6x square, and I will write that here. And I will subtract. Okay. So -2x cube, this will cancel out beta. And 2x square minus 6x square minus 4x square plus 10x plus 6. अब हम क्या करेंगे ना, we will go ahead and again look at the second term x and compare it with the second term. But ये second term नहीं है, अब second term ये बन गया है. So compare x with -4x square. So when I compare x with -4x square, क्या होना चाहिए x को -4x² बनाने के लिए, सो x इंटू -4x इज -4x², तो मैंने यहां लिख दिया -4x, ठीक है। एंड ये जो -4x लिखा, आई विल मल्टीप्लाई दिस -4x विद दिस टर्म, तो -4x इंटू x -3 -4x² plus 12, and I will put this here, -4x² plus 12x, ठीक है। तो now if I subtract, इसमें से this gets subtracted 0, 10 minus 12 minus 2x plus 6. अब फिर से I will look at this term and I will look at this term. So I know that x into -2 is -2x, तो -2 आ गया, and I will multiply this -2 with this entire thing, तो x into -2 -2x, -3 into -2 plus 6, and I will subtract and I will get 0. So I can go ahead and I can say that -2x cube plus 2x² plus 10x plus 6 can be written as x minus 3 into -2x² minus 4x minus 2. Beta homework. I want you to factorize this further. We have learned how to factorize this. हमने ये ऑलरेडी पढ़ लिया है कि इसको हम फैक्टराइज कैसे करते हैं क्वाड्रेटिक इक्वेशंस को. हाँ, I want you to go ahead and do that before the next class. ठीक है. So I'll meet you again in the next class and we will go ahead and discuss this further. ठीक है. Okay, बेटा. Thank you. Hello, beta. Good evening, everyone. So, बच्चे, last class में we had talked about the remainder theorem. Today, we are going to go ahead and we are going to talk about the power functions. ठीक है. What is the power function? Beta, any function which can be written in this form. Fx is equal to x to the power r. This is called as a power function. इसको हम एक power function बोलते हैं. R is any integer. माने R can be 0 also, R can be 1 also, it can be -1 also, it can be 2, it can be -2, and so on and so forth. If R is a natural number, अगर R एक natural number है, right, then x to the power R is a product of R x's. It's a product of R x's. ठीक है. माने what does it mean? So just think about it. But if I ask you what is x to the power 3, it means it is simply x into x into x. So how many x's का product? X's multiplied 3 times. X's multiplied 3 times. Suppose x to the power 5. X into x into x into x into x. माने x is multiplied 5 times. Right? But if r is half, तो फिर it will become x to the power half माने √x. अब इसको I cannot write x into something, x into ऐसा कुछ करके लिख नहीं सकता. I cannot write it, right? So therefore we have to understand that when r is a rational number, how can we define this? इसका क्या definition है, इसका क्या meaning है? We need to understand this in detail. ठीक है. ये तो समझ में आ गया that if x to the power 5, x is getting multiplied 5 times. If x to the power 3, x is getting multiplied 3 times. But if x to the power half, तो x multiplied how many times? क्या meaning है इसका? We want to go ahead and we want to understand that. Now, why is power important with rational numbers? क्यों important है power को समझना rational numbers के लिए, right? So sometimes you go ahead and you get some examples which is in this form. For example, कभी-कभी आपने पढ़ा होगा that the flow of blood in your body is x to the power 0.7, where x is weight of individual. ठीक है? Or you would have studied that the surface of a ball is 4.84 volume to the power 2.3 2 by 3. ठीक है? So you can go ahead and you can see that rational powers are used very much in the examples. यहाँ पे भी x to the power 0.7 है, यहाँ पे v to the power 2 by 3 है, या very common example जो हम economics में पढ़ते हैं, Cobb-Douglas production functions, right? So suppose if I tell you output is 2.62 k to the power 0.23 L to the power 0.67. अगर ऐसा कुछ हमने लिखा हुआ है, so we see that this is a production function, but the powers, they are rational numbers, right? So we need to understand कि what these powers are और इनका क्या implication है. But before that, we will be doing certain rules, beta. So if I tell you that I have a to the power r into a to the power s, so when base is same, power gets added. When base is same, power gets added. तो यहाँ पर देखो base a है and base a है. So if base is same, power can be added. Power can be added. Similarly, beta, when I will say a to the power r to the power s, when base is same and there are two powers, power gets multiplied. तो ये हो जाएगा a to the power rs. Right? Similarly, if I will go ahead and say कि a का power 1 by n है, this means we have to find nth root of a. We have to find nth root of a. ऐसा हम इसको लिख सकते हैं. इसका क्या मतलब है? That there exists some x, जिसको जब हमने n की पावर किया होगा, it would have given me a. तो वो x क्या है? It is a to the power 1 by n. Let me give you one example. जैसे I know that 3 to the power 3 is 27. है ना? या यहाँ पे let's write something else. 3 to the power 2 is 9. तो इसको हम दूसरे तरीके से कैसे लिख सकते हैं? That 3 is equal to 9 to the power 1 by 2. 3 to the power 3 is 27. 3 into 3 into 3 is 27. So if this goes on this side, 3 is equal to 27 to the power 1 by 3. ठीक है? 3 to the power 4 is 81. This can go on this side. 81 to the power 1 by 4 is 3. Is it making sense? तो माने now we know कि कहाँ पे rational powers use होती है. Right? This can also be written as 9 with 2 here. This can also be written as 27 का third root. This can also be written as 81 का fourth root. Right? Is it clear? Okay. अच्छा, now suppose if I tell you कि there is a number a जिसका power p by q है. It means that first इसका power p है and then 1 by q है, because p into 1 by q is p by q. And I just told you that powers can multiply like this. अगर दो powers हो, you can multiply. Right? So this can also be written as इसका power 1 by q है and then p है. It also means the same thing. Because if I will multiply 1 by q with p, I will get p by q. And इस चीज को बेटा I can write down कि a का qth power है. Like here, 1 by 4 means fourth power. Right? 1 by 3 means, fourth root. 1 by 3 means third root. 1 by 2 means 2 root. Right? तो यहाँ पे इसका मतलब हो गया qth root to the power p. So it can also be written like this. Right? Okay. Now, ये चीज हम डिफाइन तो कर सकते हैं, but you have to keep in mind that you cannot find root, even root of negative number. you cannot find even root of negative number. माने ऐसा कभी नहीं होगा कि अगर मैं किसी भी नंबर को एक इवन पावर दूं तो मेरे पास एक नेगेटिव नंबर आ पाए. This is never possible, that if you give a even power to any number, you get negative. So, say for example, if I give even power to -3, that means -3 into -3, I'll get 9. And if I give even power to 3, then also I will get 9. तो चाहे नेगेटिव नंबर हो या पॉजिटिव, if its power is even, अगर उसका पावर even है तो you will always get a positive number, you cannot get a negative number. ठीक है. It means that we, अब क्योंकि -3 square is 9, positive number, it means that -3 will be 9 का second root. What it means is कि यहाँ पे जब नंबर आ रहा है, whatever number is coming in this root, it has to be positive, क्योंकि यहाँ पे positive generate हो रहा है, right? So I cannot find under root of -9. I cannot do that. Why I cannot find under root of -9? Because under root means I have to find that number जिसको दो बारी multiply करके -9 आए. Right? And if I multiply a negative number twice, I get positive. If I multiply positive number twice, I get positive. So मेरे को negative number नहीं आ सकता. I cannot get a negative number. Is it making sense? ठीक है. Okay, beta. Now there are many scientific calculators which help you find their roots. अगर आप scientific calculators में जाएंगे, you will be able to find numbers like what is the root of 625 to the power 0.75, or what is the value of 32 to the power -3/5. Scientific calculators in fact help us to find these values. Okay. In the next class, I will go ahead and I will teach you how to use a scientific calculator. कैसे हम scientific calculator use कर सकते हैं? I'm going to go ahead and I'm going to teach you that in the next class. Okay. Okay, so let's move on then. So beta, now that we know ki what is a power function, we can go ahead and we can take one question. Okay. So let Z denote demand for coffee. P denote price. And you're given a function Z is equal to 694, 500 p to the power -0.3. Part 1, write formula in root format. Part 2, calculate demand when price is 35,000. क्या? When price is 35,000. ठीक है. तो देखो बेटा, I have to write this in the root form, right? So root formula माने I have to change this. So देखो, p to the power -0.3 है. It can be written as p to the power -3/10, क्योंकि 0.3 को हम 3/10 लिख सकते हैं. ठीक है बेटा. रूल, whenever there is negative power, you will reciprocate and make positive power. माने p to the power -3/10 को I can write 1/p to the power 3/10. 1/p to the power 3/10. अच्छा, 1/p to the power 3/10 को I can write 1 to the power 3/10 upon p to the power 3/10. बेटा 1 को कैसे भी मल्टीप्लाई करो, 10 टाइम, 20 टाइम, 3 टाइम, कुछ भी कर लो, 1 remains 1. So it will be 1 by p to the power 3/10. It will be 1 by p to the power 1/10 to the power 3. And p to the power 1/10 को I can write the 10th root of p. And then we are multiplying it 3 times. So we can go ahead and we can also write this as p to the power 3 का 10th root. पहले 3 से multiply कर लो, फिर उसका 10th root निकाल लो. Right? So this is how you can write it. Now instead of this, I will put this. So if I plug this in, तो क्या आ जाएगा बेटा? What will I get? I'll get Z is equal to 694,500 into 1 by p to the power 3 and its 10th root. Is it clear? Okay, now calculate demand when price is 35,000. So as I said, I will teach you to use the calculator in the next class. Today, I will just put the value and leave. So 694,500, 1 by 35,000 to the power 3 and its 10th root. I will just leave it here. Okay? Okay, beta. So we'll stop here for today. Okay, thank you.
Sequences and series. In this lecture, we would be going ahead and focusing on sequences, and we would follow it by focusing on series. So, sequence and series, although they go hand in hand, I mean, you would always heard listening to them together, we do have some difference between sequences and series. Sequences is when we have elements not being summed up. So for example, if I give you 1, 2, 3, 4, 5, and so on, I just write discrete elements. This is a sequence. But if I give you summation n, when n goes from 1 to infinity, maybe, or when n goes from 1 to 5, whatever you want. For example, 1 plus 2 plus 3 plus 4 plus 5, then this is a series. So a sequence is discrete. A series is sum. In this lecture, we are going to focus only on what is discrete. So we would be focusing only on sequences, right? Now let's go ahead and understand what is a sequence. Sequence, first of all, is represented by an. It is a set of terms. So you have terms like a1, a2, and so on till an, where n is a positive integer, right? Positive integer means you're not trying to find out a minus 1, a minus 2, no. You're finding up terms like a1, a2, a3 till an. There is another way to go ahead and write a sequence. This is how we can go ahead and represent a sequence, where n starts from k, n is equal to k to infinity. This is the general way of representing a sequence. K can be 1. So then your sequence is from n equal to 1 to infinity. K can be 5. So then your sequence is from n equal to 5 to infinity. So your sequence can go from n from 1 to infinity, from n from 2 to infinity, whatever we want to represent. So a general way of writing is that the sequence starts from n equal to 1 and goes till n equal to infinity. Consider this. This is a sequence. How am I writing this sequence? Minus 2 to the power n plus 1 into 2 to the power n upon n plus 1. This is one of the sequence that I have written. How do I write the elements of the sequence? For writing the first element of the sequence, which is a1, I'm going to put n equal to 1. When I will put n equal to 1, I will get this. Instead of n, I'm going to plug in 1. So I plugged in 1 here. Instead of n, I'm going to plug in 1. So I plugged in n equal to 1 here. Instead of n, I will plug in 1. So I plugged in 1 here. So everywhere, wherever I saw n, I went ahead and I plugged in 1. And when I plugged in 1 at each point, this is what I got in the reduced form. So I got minus 1 to the power 2, 2 to the power 1 upon 2. And when I solve it further, I will get minus 1 to the power 2 is 1 into 2 by 2. So I got 2. So my first element of this sequence is 2. Let's take it forward. I want to find out what will be the second element of this sequence. In order to find the second element of the sequence, I am saying, okay, my n is equal to 2. So when I put n equal to 2, I am finding the second element of the sequence. What do? I say, okay, minus 1 to the power 2 plus 1. I've put 2 everywhere, wherever I had n. So here, I go ahead and I put 2. I put 2 here and I put 2 here. Everywhere, wherever there was n, I plugged in n equal to 2. So then I will get minus 1 to the power 3. 2 to the power 2 is 4. 2 plus 1 is 3. So I get minus 1 into 4 by 3, which means I get minus 4 by 3. Let's take out one more element now, and then I want you to find A4 and A5 yourself. So find out A3 with me first. What will be A3? Instead of n, you will put 3. So here you are putting 3. Here you are putting 3. And here you are putting 3. Wherever there was n, you will put 3. So it will be minus 1 to the power 4. Into 2 to the power 3 will be 8. 3 plus 1 will be 4. So you will get 1 into 8 by 2. 8 by 2 is 4. So you will get the answer as 4. If you notice, what is the pattern that we are getting? We are getting the pattern that we have a positive number followed by a negative number followed by a positive number. So we have positive, negative, positive. Why is this happening? This is happening because of this right here. So I have minus 1 to the power n plus 1. Is it adding some value to your numbers? No, minus 1 is not adding anything to whatever your sequence is, except that the fact that this is helping you decide the sign. When n is 1, minus 1 to the power 2 becomes positive 1. When n is 2, minus 1 to the power 3 becomes negative. When n is 3, minus 1 to the power 4 becomes positive, and so on. So you keep getting positive, negative, positive, and so on. So the only thing that this minus 1 to the power n plus 1 is doing to your sequence is determining the additional sign for your sequence, right? Let's take one more. So this is again another sequence where the elements of the sequence are given by minus 1 to the power n into root n minus 2, where n goes from 2 to infinity. Now, why am I starting n from 2 really? Why? Very simple. Because I want anything inside the root to be strictly greater than equal to 0. When you put n equal to 2, you will get 0. If n minus 2 has to be greater than equal to 0, n has to be greater than equal to 2.
I cannot have this defined when n is less than 2. I will get a complex number. I don't want a complex number. So now, another thing that you have to see is what is this minus 1 to the power n doing to the entire sequence? This is just a sequence which is being determined along with minus 1 to the power n, which is helping you to understand the sign. My question is, will this sequence alternate signs? Yes, because I have this factor right here, which is something that is helping you to alternate the signs, minus, plus, minus, plus, plus, minus, plus, minus. So yes, minus 1 to the power n should immediately tell you that this sequence will have alternating signs. This is the only role of this sequence, that it is going to alternate your signs. So the answer is yes, definitely it is going to go ahead and alternate the sign of your sequence. Let's take the first element of your sequence. To find the first element, instead of 2 in this n right here, you will put n equal to 2. When you put 2 here, what will you get? You will get 0. Now, for the second element, you will, because the first element started when n was equal to 2. For the second element, you will put n equal to 3. So here is your n, here is your n. So everywhere you will put 3. So you will get minus 1 to the power 3, which is minus 1. 1 minus 1 under root is 1. 3 minus 2 is 1. Under root of 1 is 1. So you will get it as minus 1. Try A3, try A4, try A5. For A3, n will be, this is the third element. But the first element started with n equal to 2. This is n equal to 3. So this will be n equal to 4. So everywhere, wherever you see n, you will put 4. This is n equal to 5. So wherever you see n, you will put 5. This is n equal to 6. So wherever you see n, you will put 6. So minus 1 to the power 4 is 1. Minus 1 to the power 5 is minus 1. Minus 1 to the power 6 is 1. 4 minus 2 is root 2. 5 minus 2 is root 3. 6 minus 2 is root 4. Root 4 is 2. So you get minus 1 plus root 2 minus root 3 plus root 4 and so on. So this is the sequence that you're getting. Root 0 minus root 1 plus root 2 minus root 3 plus root 4 minus root 5 plus root 6 and so on. So it is something which is very simple to see. I am just getting root of my natural numbers with alternating signs. Every even number has a plus sign and odd number has a negative sign. So sometimes what is going to happen is that you would be given a sequence. And after they give you a sequence, they will ask you, write the general form of this sequence. That is also something that you can be asked. I have given you this sequence. Tell me what should be the form of the sequence. Well, the form of the sequence is root n. And because the signs are alternating, whatever is the sequence, it is multiplied by minus 1 to the power n. But my n is starting from 0. But let's just go back for a second, please. I said n has to be a positive number, which means n has to start from 1. It has to be 1 or more than 1, right? It cannot be 0. So, can I go ahead and say that this is n minus 1, but my n starts from 1? Now there is just one more thing left. If I do this sequence, this thing is resolved. Root of n minus 1 is fine. When you put 1, you get root 0. When you put 2, you get root 1. When you put 3, you get root 2, and so on. But when you put n equal to 1, here you will get minus 1. When you will put n equal to 2, you will get minus 1 to the power 2, which will be 1. When you put n equal to 3, you will get minus 1 to the power 3, which is minus 1. So your sign would be matched. This is minus. When you put n equal to 2, you will get minus 1 to the power 2 into 2 minus 1 under root, which is minus 1 to the power 2 will be 1. Into root 1, which will be root 1. So this will have plus sign, this will have minus sign, and so on. But this is not the same. Here root 1 had a negative sign. Root 2 had a positive sign. So can I also go ahead and say that this is going to be n plus 1? That's also not going to work, because then you can go ahead and try it again. It can work or cannot work. So we'll go ahead and we'll put n equal to 1, and we will get minus 1 to the power 2 into 2 minus 1 under root 1 minus 1 under root. So you will get 1 into root 0, which will be 0. You'll put n equal to 2. So you will get minus 1 to the power 3. And you will get 2 minus 1 under root. So you will get minus 1 into root 1, which will be minus 1. Then you can go ahead and put n equal to 3. And you will get minus 1 to the power 3 plus 1 under root 3 minus 1. So you will get minus 1 to the power 4 into root 2. So you will get 1 into root 2, which will be root 2. Now things are making sense. 0, minus 1, plus root 2. Put n equal to 4 and check. You can put n equal to 4. You will get minus 1 to the power 4 plus 1 under root 4 minus 1. Minus 1 to the power 5 under root 3, which will be minus 1 root 3 minus root 3. Signs have started matching. Positive, negative, and so on. So which means that this sequence that we just wrote, this sequence can very well, by looking at the pattern, also be written in this format, that minus 1 to the power n plus 1 root n minus 1 and starts from 1 to infinity. You can very well have this format also. There is nothing wrong with this format. This is giving you exactly the same sequence as this gave you. So what has happened in this case? Well, what has happened in this case is that I have gone ahead and I have looked at the pattern and have tried to formulate a sequence of my own, right? A general sequence of my own. So this is what I want you to do in the next case now. So what I want you to do is the following. Now I am giving you some elements of the sequence. These are the elements. The first element is 2. The second element is 3 root 2. The third element is 4 root 3. Fourth is 5 2, and so on. And I ask you to generate a sequence of your own. By generating sequence, I want you to tell me what should be the general form of this sequence. What does each element really look like? That is what I want you to go ahead and tell me. This is what we are talking about. So what can we do in this case? Well, why don't we go ahead and see the pattern of the sequence? A1 is 2 by 1. So it is 2 by root 1 also. A2 is 3 by root 2. A3 is 4 by root 3. Can you detect the pattern? Yes, we can. So whatever is coming in the numerator, leave the root for now. Just think about this. 2 by 1, 3 by 2, 4 by 3, 5 by 4, and so on. Whatever is coming in the numerator is one more than what is coming in the denominator. And then the denominator is under the root sign. So isn't this the general pattern of my sequence? You can find any term. Put a equal to 1. You will get 2 by root 1, which is 2. Put a equal to 2. N equal to 2. You will get 2 plus 1 by root 2, 3 root 2. Put n equal to 3. You will get 3 plus 1 by root 3, 4 by root 3, and so on. So which means that this is the general way of writing this sequence. This is how you can go ahead and write this sequence. Let's try one more example. And I want you to try this first on your own. The first element is minus 1, 1 by 2, minus 1 by 6, 1 by 24, minus 120, and so on. First of all, this should ring a bell. Why? Because the signs are alternating. We just now saw that whenever the signs are alternating, we must have one element which is minus 1 to the power n. The only role of minus 1 to the power anything is to alternate the signs, isn't it? And this is what it is doing. So when n is 1, we have a negative sign. When n is 2, we have a positive sign, and so on. So this is what it is going to do. Minus 1 to the power 1, minus 1. Minus 1 to the power 2, 1. Minus 1 to the power 3, minus 1, and so on. It's alternating the signs. So my sequence will definitely be multiplied with minus 1 to the power n. We have been able to understand this much at least. Now let's go ahead and take this forward. So now what I'm going to do is, I'm going to leave the negative sign. That part is clear to me. I will just focus on the other things. So I get 1 by 1, 1 by 2, 1 by 6, 1 by 24, and so on. And let's say that I'll write the fifth term also. 1 by 120. Now, let's try and find this pattern once, a little pattern. So this is 2, this is 1. So which means that to get this term, I would have multiplied the earlier term with 2. This is 2 into 1. This is 6. This is nothing but whatever my earlier term was, 2 into 1, I multiplied it by 3. We are able to see something. This is 24, which means this is 6 into 4. So whatever my earlier term was, 3 into 2 into 1, I multiplied it with 4. This is 120. This is 24 into 5. So whatever my earlier term was, 24 can be written as 4 into 3 into 2 into 1. I multiplied it with 5. Well, the pattern is formed. This is 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. Which means this is simply 1 upon n factorial. And then I have to multiply this sequence with minus 1 to the power n, because this is what is giving sign to my sequence. So what should be the general way of writing your sequence? Minus 1 to the power n by n factorial. This is a general way of writing the sequence. We have been able to resolve this. So the only way of writing this sequence is minus 1 to the power n
upon n factorial. Now, let's go ahead and take one more example. And this is the example of what is known as a recursive sequence. A recursive sequence is any sequence such that the next term is dependent on the previous term. It is derived from that. So if I tell you that an plus 1 is 2 times an minus 1, this is called a recursive sequence. My third term depends on the first and second term. Let's try this out. Let's put n equal to 3 in this sequence. So, or let's start with n. Yeah, I want to find out actually a3. This is what I am saying. So let's say I want to find out a3. To find a3, I will have to put n equal to 2. When I put n equal to 2, I will get a 2 plus 1 is equal to 2 a2 minus a2 minus 1. So this will become a3 is equal to 2 times a2 minus, and 2 minus 1 will be 1. So minus a1. We know what a2 is. A2 is 4. A1 is 2. So if I know a2 is 4, 4 into 2 is 8, minus 2. So 8 minus 2 will be 6. So I can find the third term by putting n equal to 2. So you're putting n equal to 2 everywhere. Here, here, and here. This gives you 2a2 minus a1. And this is nothing but 6. Try and find a4 and a5. So let's find a5 together. A5 would be put n equal to 4. So a4 plus 1 will be 2 a4 minus a4 minus 1. So a5 will be 2 times a4 minus a3. So 2 times a4 is 8 minus a3 is 6. So this would be 16 minus 6, which would be 10. Now you can literally find any term. The first term is 2, second is 4, third is 6, fourth is 8, fifth is 10. Right? If I ask you, find, let's just try this. A100 minus A50. Well, after I have seen the pattern of the recursive terms, recursive sequence, I found out that the first term was 2, the second was 4, third was 6, fourth was 8, fifth was 10. So 100th would be 200. 50th would be 100. So 200 minus 100, which will be 100. So if somebody asks you find A100 minus A50, you're just finding out the answer very simply by looking at the pattern. You know what your A100 would be, what your A50 would be. You don't have to do this process 100 times. You just have to do it in this manner. This is the way to do it. Right? Now, let's go ahead and take it forward. The next topic that I want to discuss is called limit of a sequence. A sequence can, either be a convergent sequence or be a divergent sequence. If a limit has limit, which means if a limit goes to a particular number, which is defined, not infinity, a number, then it is a convergent sequence. If a sequence does not go to a number, it goes to infinity, plus or minus infinity,
Or if the limit in itself does not exist, if you get something like this, 1 by 0, 0 by 0, if the limit does not exist whatsoever, then it is known as a divergent sequence. So a convergent sequence is only when the limit goes to a particular number. Otherwise, it is divergent. Let's see some properties of this. First, you have a sequence. The sequence is multiplied by a constant. You're trying to find the limit of the sequence. The constant can come out and you can find the limit of the original sequence. So for example, if I can, if my sequence is n upon 1 plus n, and another sequence is 2n upon 1 plus n, and I know that limit n tends to infinity n upon 1 plus n is nothing but, supposedly I know it is 0, right? Or I know that this is 1. We can solve it. Let's just solve it only. This is going to be limit. I'll just divide both sides by n, numerator and denominator. N tends to infinity. This is going to be limit 1 upon 1 by n plus 1. And this is going to be 1. So I know that, my sequence, when n tends to infinity, converges to 1. Then, even if this sequence is multiplied by some constant 2, I can simply say that limit n tends to infinity, 2n upon 1 plus n is nothing but 2 can come out, limit n tends to infinity, n upon n plus 1, and I know that this converges to 1. So this will be 2 into 1, which will be 2. This will converge to 2. This is the property that if a sequence is multiplied by C, then the C can come out and you can find the limit of the actual sequence. If two sequences are added up together and then you have to find limit n tends to infinity, you can simply find the limit of the first sequence and find the limit of the second sequence. If two limits, you're finding the product, then you can find the limit of the first sequence, find the limit of the second sequence and multiply. If it's division, you can find the limit of the first sequence, second sequence and divide. Right? So, whether you are adding, multiplying, dividing, you can go ahead and do that. You cannot do this for subtraction, please. Unless it's a natural, unless you're getting a number, both of the sequences are convergent, you can't do it. What do I mean? Suppose an converges to infinity, bn converges to infinity. You cannot go ahead and say that, okay, limit n tends to infinity, infinity minus infinity would be 0. Don't do that. That is wrong. I'll show you this example, how to approach this question. But don't do it like this, please. Okay. Now, if you have a sequence, this sequence is raised to the power p. So, suppose this is this, n upon 1 plus n to the power p, and I have to find the limit of this entire thing. Then, I can first find the limit of the sequence and then raise it to the power. This holds true. So, if the sequence is raised to power p, for which you are finding the limit, so here sequence is raised to the power p and you're finding the limit for that, you can actually find the limit of only the sequence and then raise it to the power. So, if you look at this becomes very difficult, isn't it? So for example, I ask you find whether n upon 1 plus n to the power 100, whether this converges or diverges. Well, it is very difficult to check to the power 100. But I can use this rule and I can say that limit
n tends to infinity, n upon 1 plus n to the power 100 is equal to limit n tends to infinity, n upon 1 plus n whole to the power 100. And I know that this part converges to 1. So I will simply have 1 to the power 100. So even if I raised this to the power 100, it still converges to 1. Okay. So this is what we are saying. If there is a sequence raised to some power, you can first find the limit of the sequence and then raise it to power. Let's now do few questions related to convergence and divergence. We'll use different properties. We'll take the first question, very, very simple, but most asked question. You're given a sequence -1 to the power n, and you have to check the convergence or divergence of this sequence. How do you do this? Well, when I put n equal to 1, I will get -1 to the power 1, which is -1. N equal to 2, -1 to the power 2, which is 1. N equal to 3, -1 to the power 3, which will be -1, and so on. So what do I get? I get -1, 1, -1, 1, and so on. Does the sequence converge? Absolutely not. The sequence is diverging. It's going to -1, +1, -1, +1, negative, positive, and so on. It is not converging to a particular number. If you don't get one number, then the sequence diverges. So the answer is that the sequence diverges. Let's take another sequence. An is equal to 2n upon n plus 1. See, whenever you get such kind of sequences where the question given to you is in the form of it's in the form of a numerator and denominator, which means it's a fraction, then what you can go ahead and do is you can divide numerator and denominator by the highest power of denominator. So the highest power of denominator is n to the power 1. So I will divide numerator and denominator by n. So, my sequence is 2n upon n plus 1. Let me divide numerator by n and denominator also by n, each element. So I will get 2 upon 1 by n plus 1. And now when limit n tends to infinity, 2 by 1 by n plus 1, this is 2 upon 1 by infinity plus 1. Anything by infinity is 0. So 2 by 0 plus 1, which is 2. So this converges to 2. You can try few elements also. So when you put n equal to 1, what will you get? 2 into 1 by 1 plus 1, which will be 2 by 2, which will be 1. When you put n equal to 2, what will you get? 2 into 2 upon 2 plus 1, which will be 4 by 3, which will be 1.33. Put n equal to 100. 2 into 100 upon 100 plus 1, which would be 200 upon 101. Right? So you can keep trying this for whichever possible number that you get, however large. So 200 divided by 101 will be 1.98. Now let's put a very, very big number. So n is equal to 10,000. So you will get 2 into 10,000
upon 10,000 plus 1. So this would be 20,000 upon 100,001. So you will get 20,000 divided by 1, and this would be 1.99998. So you are converging towards 2. However large number you may have, the sequence is going towards 2. So that is why it becomes a convergent sequence. Let's go ahead and take one more question. So this sequence was convergent. Now we will take one more question here. An is equal to 2 plus minus 1 to the power n by n. Now what students do a lot of times is that we just said that minus 1 to the power n is divergent, right? So just by looking at this, they conclude that any sequence which has this minus 1 to the power n will be a divergent sequence. Well, this is wrong. You cannot say that for any sequence. I will use the same rule. I will divide both numerator and denominator by the highest power of the denominator. So I will say limit n tends to infinity, 2 plus minus 1 to the power n by n will be 2 by n plus minus 1 to the power n by n upon n by n. Limit n tends to infinity. So this is going to be limit n tends to infinity 2 by n plus minus 1 to the power n by n. This is just 1. Now, if I put infinity here, then I will get 2 by infinity plus minus 1 to the power n by infinity. I won't put infinity here. I'll tell you a reason why. So just be clear, 2 by infinity, anything by infinity is 0 plus. See, for minus 1 to the power n, imagine the largest number possible, any largest number. So, infinity just means that it is a very large number, right? If this very, very large number is even, then minus 1 to the power even number, n is even, very, very large number will be just plus 1. Minus 1 to the power 10,000, minus 1 to the power 1 lakh. If it is an even number, then it will simply give you plus 1. And imagine that infinity being a very, very large number, but it is a negative number. So let's say that let's say that it's an odd number, sorry. So let's say that, it is 9999999, whatever. It's a very large number. But if it is odd, minus 1 to the power an odd power will give you a negative 1, minus 1. So this is this, minus 1 into minus 1 into minus 1 into minus 1. So if it is multiplied itself odd times, so these will become 1, this will become minus 1 into 1, 1. But at the last, you will have an additional minus 1. So to the power odd is minus 1. So this means that this is just two values. Either it is 1 or minus 1, depending on whether this very large infinite number is even or odd. But whether it is 1 divided by infinity or minus 1 divided by infinity, anything by infinity is just 0 because you're dividing it by a very, very large number. You're dividing 1 or minus 1 with a very, very large number. So because it is just 0, 0 plus 0 is simply 0. So this becomes a convergent sequence. This becomes a convergent sequence converging to 0. So the answer is that this is a convergent sequence. Now, let's take this next sequence. ln n by n. I am going to use a rule here, and the rule is known as L'Hopital's rule. So let's just write this down. L'Hopital is written as L-H-O-S-P-I-T-A-L. It's called the L'Hopital's rule. And the L'Hopital rule says that whenever you get an indeterminate form, which means whenever you get a form which is 0 by 0, infinity by infinity, minus infinity by infinity, and you're trying to find limit of function by function, then you can go ahead and simply find limit at the same x tends to c of the differentiation of the function. And if this is also infinity by infinity, you can again differentiate numerator and denominator yet again. So you can differentiate it as many times as you require. That is called the L'Hopital's rule. Let's go ahead and see it here. So when I say that I want to put limit n tends to infinity, ln n by n, this is ln infinity by infinity, which is infinity by infinity. Log of a very, very large number is a very, very large number by a very large number. It's an infinity by infinity form. I cannot solve this. So I'm going to use my L'Hopital's rule, which means I'm going to differentiate the numerator and denominator separately. So differentiation of ln n will be 1 by n, separately differentiated. Differentiation of n is 1. Don't use quotient rule. No quotient rule to be used. You're differentiating the two functions separately. Numerator is getting differentiated separately, denominator is getting differentiated separately, and then you're dividing it. So this is 1 by 1 by n by 1, and then limit n tends to infinity 1 by n is 1 by infinity, which is 0. So anything by infinity is 0. So which means this is also a convergent series, convergent sequence, sorry. So this is also a convergent sequence converging to 0. Now, let's take one more type of example. This is the sequence given to you, root n plus 1 minus root n. Now, if you look at this sequence, and if you directly go ahead and you put limit n tends to infinity, you'll get infinity plus 1 minus infinity. Root of a very large number is a very large number. Root of a very large number is a very large number. Don't go ahead and just say that this cancels out and this is 0. No, please. That's not the way to solve these problems. So whenever you get infinity minus infinity, you have to do the following. You have to try and change the sign to positive sign. Now you'll ask me, how can we do that? One way to do it is to multiply and divide this by opposite sign, which means conjugate. What are we doing? Let's see it. So I had to find the limit of root n plus 1 minus root n. And what I'm going to go ahead and do is I am going to multiply and divide by the same pattern, but with a positive sign. So I am going ahead and multiplying and dividing by the same, whatever is given to me, but with a positive sign. Now, this becomes simple. We know that a minus b into a plus b is simply a square minus b square. So this is a minus b. This is a plus b. So this will simply become a square minus b square. It will become root of n plus 1 square minus root of n square in the numerator. This part, which is nothing but n plus 1 minus n. This is what I will get. Isn't it? So my numerator becomes n plus 1 minus n, and my denominator is root of n plus 1 plus root n. So my numerator now n gets cancelled, and I'm left up with 1 upon n plus 1 under root plus root n. Although I don't know what is infinity minus infinity, I know infinity plus infinity is infinity. A very large number added to a very large number will give you a very large number, right? So if I go ahead and I do that, I can say that when now I apply limit n tends to infinity, this is going to be, sorry, this is simply going to be, we'll put plus here, limit n tends to infinity. Whenever you will put infinity inside this, you will get 1 upon infinity plus 1 under root plus root infinity, 1 upon infinity plus infinity, 1 by infinite, which is 0. So this is a convergent sequence. It is converging to 0. But directly you cannot say that because I'm getting infinity minus infinity, so it is 0. No, that's wrong. You cannot do that. You cannot just say here that this is infinity minus infinity. You have to multiply and divide with the reverse sign and then solve it further and then see what is it tending to. Okay. Squeeze theorem. This is another way to go ahead and check the limits. So the squeeze theorem says that assume that there are 3 sequences, an, bn, and cn. Bn is squeezed, it is sandwiched between an and cn. This is bn, it's between an and cn. If bn is between an and cn, and an and cn are going to the same limit, so an and cn tend towards the same limit, their limit exists and they go towards the same limit, then bn will also go towards that limit. So even if you're not able to find the limit of bn, it will go towards the same limit. Let's try this out. I am saying an and cn, they tend towards the same limit L. They go towards the same number L. There is a sequence in between. This sequence in between is bn. Then this bn will also go and converge to the same limit L. This is how you can check the convergence of bn. Let's take this question and see the following. So I'm given an is equal to n factorial by n to the power n. Now let's just find first few elements of it. So I will get 1 factorial by 1 to the power 1, 2 factorial by 2 to the power 2, 3 factorial by 3 to the power 3, and so on. This is what my sequence is going to look like. 4 factorial by 4 to the power 4, and so on. This is 1 by 1. This is 2 by 2 into 2. This is 3 into 2 by 2, sorry, by 3 into 3 into 3. This is 4 into 3 into 2 by 4 into 4 into 4 into 4. Okay. Do we all agree that 3 into 2 is less than equal to 3 into 3? Yes, we do agree to that. 3 into 2 is less than equal to 3 into 3. So this is less than equal to 3 into 3 by 3 into 3 into 3. Denominator I'm not even changing. Denominator is same for both of them.
4 into 3 into 2 is less than equal to 4 into 4 into 4 by 4 into 4 into 4 into 4. Denominator I'm not changing. This is less than or equal to 2 upon 2 into 2. In this case equal. This is less than equal to 1 upon 1. So we have understood that the sequence that was given to us, this is the value of the sequence here, here, here. This is less than this, 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 this. What is the sequence? If I have to formulate a general form for this sequence, what will be the general form of this sequence? 1, comma 2 upon 2 into 2, comma 3 into 3 upon 3 into 3 into 3, 4 into 4 into 4 upon 4 into 4 into 4 into 4. What is the form of this sequence that we are coming to? N upon N. If N is 1, then it is fine. When N is 2, I'm getting to the power 2. When N is 3, I'm getting to the power, so to the power N. And here I have to the power N minus 1. Do we agree? This is the general form of this sequence. You can check it. You put N equal to 1. You will get 1 to the power 1 minus 1 upon 1 to the power 1. You will get 1. You put N equal to 2. You will get 2 to the power 2 minus 1 upon 2 to the power 2. You put N equal to 3. You get 3 to the power 3 minus 1 upon 3 to the power 3, which is 3 to the power 2 by 3 to the power 3. This is 2 to the power 2 upon 2 to the power, 2 to the power 1 upon 2 to the power 2. So the general form of this sequence is this, right? Which of course can be written in a much simplified way, 1 by N. Because all other 2's get cancelled, 3's get cancelled, 4 gets cancelled. So it is simply 1 by N. So which means that the sequence that is given to you, this sequence is An equal to N factorial by N to the power N. This sequence has to be less than equal to 1 by N. This is just something that I proved, that this sequence will be less than or equal to 1 by N. We formally proved it, right? If this is less than equal to 1 by N, we also know that this sequence will be always greater than 0. This is what, the first element is 1. It is greater than equal to 0. So this will be always greater than equal to 0. So this sequence that is given to us is between 0 and 1 by N. Limit N tends to infinity, 0 is simply 0. How many ever times you keep writing 0, 0, 0, 0, 0, 0, 0, the last element will also be 0. It will converge to 0. And limit N tends to infinity, 1 by N will be 1 by infinity, which will be 0. So this converges to 0. This converges to 0. This is An, this is Bn, this is Cn. An is converging to 0. Cn is converging to 0, which means Bn should also converge to 0. So this should also converge to 0. So therefore, if you are given a sequence n factorial by n to the power n, this is a convergent sequence and it converges to 0. It's a convergent sequence and it converges to 0. This is the formal proof of it, that it's a convergent sequence and it converges to 0. Okay, so now let's see. If there is any sequence which in the absolute terms converges to 0, then the sequence generally also converges to 0. So what you can do is, sometimes when you find it difficult to find a sequence which has negatives and positives, you can check the sequence in the absolute terms. If the sequence is converging in the absolute term, then you can say that the sequence is converging. Let's check. So for example, I give you this sequence. Now, if you put n equal to 1, so you will get, the first element, which would be minus 1 to the power 1 by 1, which will be minus 1. If you put n equal to 2, you will get minus 1 to the power 2 by 2, which will be half. When you put n equal to 3, you will get minus 1 to the power 3 by 3, which will be minus 1 by 3. When you put n equal to 4, you will get 1 by 4 and so on. So this sequence actually looks like minus 1 half, minus 1 by 3, 1 by 4, minus 1 by 5, 1 by 6 and so on. Now, this may seem very difficult to work with, whether this sequence converges or diverges. So if you think that this sequence is difficult to work when you have negative and positive signs, what you can go ahead and do is find the limit of the absolute sequence. So we understand that the role of minus 1 to the power n is just to give the sign. If I keep this aside, my sequence is just 1 by n, isn't it? This is 1 by 1, 1 by 2, this is 1 by 3, 1 by 4, 1 by 5, 1 by 6. So if I just don't look at the signs, if I remove the signs, this is just a sequence which is 1 by n. And I know that this is nothing but 1 by infinity, which is 0, and it converges. So if this converges, then if it is converging in its absolute term, this is what I've proved, then it also converges with the alternating signs. So therefore, if limit n tends to infinity, 1 by n is converging, so even with the alternating signs, it will converge. This is this node. If a sequence in its absolute term converges, then the sequence converges. Okay. It is a convergent sequence. Next note. If we have a sequence, a continuous function, and limit n tends to infinity, an is equal to L, then the limit of the function is the function of the limit is the function of L. What is this saying? This is saying that, for example, I have a function. Give me an example of any continuous function. E to the power x is continuous, the best example. I have a sequence which is convergent. So I know a sequence which is convergent is this, right? Or you can also take this as this item. So we proved this one, right? Any one you want, you can take it. This is also convergent because if you divide this on both sides, you will get 1 upon 1 by n plus 1. And when you put n tends to infinity, it will be 1 upon 1 by infinity plus 1. 1 upon 0 plus 1, which is 1. So this is convergent. So I took a sequence which is convergent. It converges to 1. I took a function which is continuous. Now, if I put the value of the sequence in the function, which means if I find e to the power an,
and I want to apply limit to that function. So what am I doing? I am defining a function of an. An is this. Instead of x, I want to put this sequence in the function. And I want to check what happens as n tends to infinity. Then this is simply saying that you can first find what happens at infinity and then put the value in the function. So this is equivalent to keep e as it is and put limit first in the sequence. And because I know that this sequence was converging to 1, this is e to the power 1, which is e. Is it making sense? So understand this. My sequence was n upon n plus 1. E to the power x was a function. The value of the function in the sequence will be e to the power n upon n plus 1. So when you put n equal to 1, your value will be e to the power 1 by 2. When you put n equal to 2, your value will be 1 upon 2 to the power 3. So the sequence that you will derive after putting it in the function will be e to the power half, e to the power 2 by 3, e to the power 3 by 4, and so on. This is the sequence that you're deriving. Now, if someone asks you whether this sequence converges or diverges, it is very difficult to check this, right? Whether e to the power half, e to the power 2 by 3, e to the power 3 by 4, and so on converges or diverges. So what we are doing is we are saying, okay, e is a continuous function and this sequence in itself converges to 1. So this entire thing converges to e to the power, just apply limit on that sequence. And the limit on that sequence gives you 1. So this entire sequence will converge to e to the power 1. This 2.78. Right? This is what we are saying here. Let's take few examples. So I have limit n tends to infinity, e to the power sine 1 by n. Again, e is a continuous function. My sequence in itself can be defined as sine 1 by n. When I apply limit only to my sequence, so this will be sine, instead of n, I will put infinity, 1 by infinity. 1 by infinity is 0. So sine 0 and sine 0 is 0. Which means this part converges to 0. So then I can say that limit n tends to infinity, e to the power sine 1 by n is equal to e to the power limit n converges to infinity sine 1 by n, which is e to the power 0, which is 1. So this sequence is a convergent sequence and it converges to 1. So let's see it. Ex is continuous, sin x limit exists. So instead of applying limit to this entire function, I will apply limit to the sequence and then put its value inside the function and I will get a convergent sequence. Let's take one more example. An is equal to tan inverse n square. So again, tan inverse is a continuous function. The function tan inverse looks like this between minus pi by 2 and pi by 2. You should know trigonometric functions. So it has an upper and a lower limit, right? So tan inverse is a continuous function. When I put limit on the function, on my sequence, the limit exists. Although it's divergent, although it exists at infinity, but it exists. So because limit exists and it is a continuous function, I will go ahead and put limit only to the function, only to the sequence, and then apply it on the function. And once I apply limit only to the sequence and then put its value in the function, I will get tan inverse infinity. And we know that at infinity, tan tends to go towards pi by 2. It converges towards pi by 2. So the answer is pi by 2. Is this making sense? Again, if your function is continuous and limit exists, positive, negative, infinity, limit exists for your sequence, then you will first put that limit in the sequence. Whatever is the answer from here, you will put that in the function, and that would be the limit of the function. That would be the limit of the function. Okay. So this would be the limit of the function. Okay. Thank you.
Now, what is a matrix to begin with? जब भी हम अपने numbers को एक rectangular format देते हैं या एक square arrangement देते हैं, that is called as a matrix. Many books will write matrix in this form because matrix is sometimes thought as different rows coming together and हर row को हम एक vector मान सकते हैं. So sometimes matrix is also written in this bracket, and sometimes they will directly go ahead and use this for matrix, double lines, and then write the numbers in between. So it's nothing to worry. अगर आप इनमें से कोई भी format देखो, you see any of these three format, it implies it is a matrix. Now, see the numbers, how these numbers are written in this matrix. So if I am talking about the first row, देखो, we always go row wise. So you will notice that जब तक row number 1 है, it will be A1, the first, जो हम first number लगाते हैं in the index, it is A1 everywhere, as long as it is the first row. Now, if it is first column, I will put 1 here. This represents column. 2 represents column number 2. N represents column number N. So notice that the first, जो हम यहाँ पे first index लगा रहे हैं, 1, it is for the first row. And जो हम second index use कर रहे हैं, this 1, 2, 3, this is for the column. So the first column, second column, nth column, and so on. And so on, you can do it for any row, na? So if it is the second row, A21, A22, and so on till a to n, right? Each of this element, जो भी matrix के अंदर element आ रहा है, each of this element, each of this number actually, it's called an element of the matrix. हर matrix से related उसका एक order होता है. We have order of the matrix. And what is order of the matrix, beta? Order of the matrix is basically the number of rows that represents M cross the number of columns that is represented with N. So M represents the number of rows and N represents the number of columns. ऐसा जरूरी नहीं है that M needs to be equal to N. No. M और N unequal भी हो सकते हैं. So I can go ahead and I can have a 2 cross 3 matrix, which means I will have 2 rows and 3 columns. I can have a 3 cross 2 matrix, which means 3 rows and 2 columns. And I can have a 2 cross 2 matrix also, which means 2 rows and 2 columns. तो कुछ भी order of the matrix हो सकता है. There are different kind of matrix, and this is very important from the point of view of any MCQ exam. We must know what are the different kind of matrices that exist. Beta, first matrix देखो. The first matrix is called a row matrix. A row matrix is any matrix which has only one row but many columns in it. अगर row एक ही है, it means that I have A11, A12, A13, A14, A15. ऐसे मेरे पास एक matrix है. देखो, there are so many columns ना. Column number 1, column number 2, column number 3, column number 4, column number 5. So there are 5 columns. But there is only one row, na? Row to ek hi hai na? There is just this one row. So if you have just one row, but you have multiple columns, then that becomes a row matrix. Usko hum row matrix bol dete hain. Similarly, let's think about a column matrix. It is the reverse. So column matrix kya ho gaya bache? There is only one column. Ek hi column hai, but there can be multiple rows in it. So I can have A11, A21, A31, A41, A51. Ab isme I can clearly see that there are 5 rows in it. But I can also see na that there is only one column. Column to sirf ek hi hai, but there are multiple rows in it. So we can go ahead and say that this is a column matrix. The next I have, bache, that is called as a rectangular matrix. What is a rectangular matrix? Any matrix which has rows and columns, but the number, the rows ko we are representing with M, column I am representing with N. I don't want row to be equal to column. Agar mere number of rows or column alag hain, if the number of rows and columns that I have, they are different, then I can say that it is a rectangular matrix. ठीक है? Come to the next one, beta. This is called as horizontal matrix. Again, आप shape बनाकर ही समझ जाओगे what is a horizontal matrix. So I am saying that in this, देखो horizontal matrix में it should look like this, है ना? So you can clearly see that means there will be only less rows, but there will be more columns in it. Only then it represents horizontal. और अगर मैं vertical बोल दूं, मतलब ऐसा कुछ दिखता है, मतलब बहुत सारी rows रही होंगी, but column would be less. So a horizontal matrix is any matrix which has number of rows less than number of columns. Rows कम हैं, columns ज़्यादा हैं, then I can say it is a horizontal matrix. There are less rows and more columns in it. But when I talk about a vertical matrix, then as I can see that there are so many rows in it, but there are only 2 columns in it. So वो हो गई बच्चे vertical matrix. Then we have something which is known as a null matrix. As the word suggests, null का मतलब हो गया 0. So a null matrix is any matrix in which all elements of my matrix are 0. एक भी positive या negative element नहीं होता है. Every element of the matrix is 0. Then I can say that it is a null matrix. उसको हम null matrix बोल सकते हैं. Okay, beta. Next is my square matrix. So when I talk about a matrix, देखो ध्यान से, this is my matrix. So I have told you that the number of rows are m, the number of columns are n. If m and n are equal to each other, अगर हम m और n को बराबर रख देते हैं, it means that there are exactly suppose 2 rows and 2 columns. Then it represents a square matrix, right? Okay. The next is called as a diagonal matrix. So a diagonal matrix is any matrix in which we can go ahead and say that the leading diagonal elements are non-zero. तो हम क्या कह रहे हैं कि except these leading diagonal elements, इसके अलावा ये leading diagonal element है, इसके अलावा everything is zero. यहाँ पे भी zero, 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 zero. Everything else is zero. अच्छा, इसको represent करने का ना there is another way. So if I am writing my matrix बेटा, देखो ध्यान से, this is A11, A12, A13, A21, A22, A23, A31, A32, A33. ऐसे करके मैंने इसको लिख दिया है. हाँ, I am saying कि मुझे चाहिए ये नॉन जीरो हो and everything else should be zero. ये zero, ये zero, ये zero, 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 zero. Now note that here whichever elements I want zero, यहाँ पे row का index और column का index is different. You can see now that this is 2, this is 1, this is 3, this is 1, this is 3, this is 2. But you can clearly see here the index is the same 1, 1, 2, 2, 3, 3. It means I want that whenever I and j are not equal to each other, जब भी ये I और ये j बराबर ना हो, when they are not equal to each other, then I want those elements to be zero. And whenever these I and j's are equal to each other, then I want it to be non-zero. So if I have this property being satisfied, अगर मेरी ये property satisfy हो जाती, if this property is being satisfied, then we can go ahead and we can say कि it is a diagonal matrix. तो यही हमने यहाँ लिखा है. Those except in the leading diagonal, every element is zero, then we can go ahead and say that it is a diagonal matrix. Sometimes diagonal matrix को हम कैसे लिख देते हैं? We go ahead and write it like this also, that A is a diagonal matrix and it has these elements A11, A22 till ANN. माने ये जो भी मेरे diagonals हैं, whatever are my diagonals, सिर्फ उनकी values कुछ कुछ डालनी है. Other than that, everything is zero. I only need to go ahead and put values of my diagonals. I need to just fill in this principal diagonal and everything else is zero. ठीक है बेटा, come to the next one. The next is called as a scalar matrix. But before I can explain you a scalar matrix, I need to explain to you what is a identity matrix. So identity matrix क्या हो जाता है? Where the diagonal, it's a kind of diagonal matrix, but these diagonal elements are 1. Exactly 1 हो जाती है इनकी value. I will not accept any other value. Then it will become an identity matrix. So if it is 4, suppose, then it is a diagonal matrix. But if all the diagonals are exactly 1, then it becomes an identity matrix. So agar in exam, suppose, beta, they give you a statement that all identity matrix are diagonal matrix. तो is this statement true? Yes. अगर identity है तो diagonal तो है ही ना, because the diagonal elements are non-zero and other elements are zero. तो ठीक है, diagonal matrix is there. But suppose they give you a statement that all diagonal matrix are identity matrix. तो ये false हो गया. Just because it is a diagonal matrix. तो diagonal का मतलब तो it can take any value ना. I could have had 4 also here. But it is not an identity matrix, right? So just because it is a diagonal matrix, इसका मतलब ये नहीं हो गया कि वो identity भी हो गया. Okay. Now, once we know what is an identity matrix, I can go ahead and I can multiply. तो इसको ना हम we write it like this. I3. See, this has to be a square matrix. Identity matrix का माने मतलब ये हो गया that it is a square matrix. And when I say I3, it means that the number of rows and columns are 3 in it. If I would have written I4, it would have meant that number of rows and columns are 4 in it. So I could have got something like this. ऐसा कुछ मिल जाता मुझे. Just fill in these. हाँ, ऐसा. This would have been I4. So this represents that it is an identity matrix, but it's can sorry, its number of rows and columns are 3. Now, when I talk about a scalar matrix, जब हम scalar matrix की बात करते हैं, then scalar means that your identity matrix is scaled by some number. तो अगर मैंने suppose I tell you that बेटा k is equal to 4, it means that I am scaling जो भी मेरा identity matrix था 1 1 1 0 0 0 0 0 0, इसको मैंने 4 से multiply कर दिया throughout. So each element will get multiplied with 4. So I have just scaled that matrix. So when I say that I am talking about a scalar matrix, ध्यान से देखो बच्चे, what is a scalar matrix? Every non-diagonal element is 0. Just like identity matrix, सारे non-diagonal elements 0 हैं. And diagonal elements are equal. Just like identity matrix, उसमें सब 1 थे, इसमें सब equal हैं. It is a scalar matrix, but aij should be equal to k. तो ये जरूरी नहीं है. This is not necessary that you want aij to be 1. 1 होना जरूरी नहीं है. If aij would have been 1 for all I equal to j, तब तो वो identity matrix हो जाता. It would have been an identity matrix. But when I say that my aij is some k, then this means that this represents a it represents a scalar matrix. It is one form of the identity matrix when it is being scaled. उसको हमने scale कर दिया. Okay. Come to the next one. The next one, beta, is your unit or identity matrix. ये मैं आपको already बता चुकी हूँ. The identity matrix also is sometimes called as the unit matrix. Next one is upper triangular matrix. तो upper triangular matrix को हम कैसे represent करते हैं? Let me show you that first. Beta, just see here. I have A11, A12, A13, A21, A22, A23, A31, A32, A33. ट्रायंगुलर मतलब ऊपर मुझे ट्रायंगल फॉर्म करना है. इट मींस द अपर ट्रायंगल शुड बी फिल्ड विद नंबर्स. उसको हमने किसी नंबर से भरना है. एंड द लोअर पार्ट देखो ध्यान से, सी इट सेज aij is 0 when I is greater than j. I was representing the row index, j was representing the column index. अब देखो 2 is greater than 1. तो when I is greater than j, तो ये क्या बोलता है? What will be your value? It will be 0. So when 2 is greater than 1, I will replace this value with 0. When 3 is greater than 1, so I will replace it with 0. 3 is greater than 2, so this will be replaced with 0. So any matrix which is of this format, कि upper में आपका एक triangle create हो रहा है with some numbers. यहाँ पे कुछ numbers आ रहे हैं, and in the lower side you have all zeros. और इसको हमने कैसे represent किया? We said that aij is coming out as 0. और ये aij 0 कब हो रहा है? When is this becoming 0? When your I is greater than j. ये हमने अभी represent भी कर दिया. That whenever I see an I greater than j, then those elements become 0. That is called as an upper triangular matrix. Bachche, look at the next one. The next one is saying lower triangular matrix. Just the reverse of this. You can just make it yourself. So in the lower triangular matrix, you will see that this part becomes 0 and this part will be non-zero. So whatever name is given ना, जैसे अगर उन्होंने बोल दिया lower triangular matrix, मतलब जो lower triangle create कर रहे हैं हम, whatever lower triangle I am created, creating, that should have non-zero values. If it is upper triangular matrix, तो जो हम upper triangle में वो create कर रहे हैं triangle, that should have non-zero values, right? Then beta we have something which is known as a sub-matrix. अगर हम किसी matrix से कुछ rows और columns को delete कर दें, if I delete some rows and columns and I get a smaller matrix out of it, that is called as a sub-matrix. Take an example. So I am saying that I have this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I am telling you, I delete the second row and the second column. तो जो मेरे को ये smaller matrix मिलेगा ना 1, 3, 7, 9. This is a sub matrix of this bigger matrix. जो हमने वो bigger matrix बनाया था उसका ये एक sub matrix हो गया. It's a smaller sub matrix created out of the bigger matrix. All these definitions can be asked as part of MCQ in your exam. तो इसको पढ़ना बहुत ही जरूरी है. Okay. Then you have equal matrix. तो equal matrix पे कैसे क्वेश्चन आता है? Let me just show you. Two matrices are called equal matrix when each of their element maps. जैसे for example बच्चे, I tell you that this is x plus y, x minus y, 4, 7, 4, 7, 10 and 3. ऐसा कुछ I have created, हाँ? Equal matrix would mean that you will map element to element. माने आपने इसको इससे match किया. 4 is anyways matching to 4. 7 is matching to 7. And this is matched to this. So we can say that, okay, x plus y na, that will be 10. And we can say that x minus y na, that will be 3. ठीक है? Two equation, two variables, solve them simultaneously. So if I add these two equations together, I will get 2x is equal to 13. So x will be 6.5. So y हो जाएगा 3.5. So I have been able to get the values of x and y. So this is called as equal matrix. So in equal matrix, we go ahead and we map. हम check करते हैं element to element. Okay. Now we have something which is known as the principal diagonal of a matrix. Principal diagonal of the matrix हो जाता है बच्चे ये. This is called as the principal diagonal. So any matrix has two diagonals. One is called as the principal diagonal. This is the main diagonal. The other is called as the off diagonal. Principal diagonal has the property that your aij is such that I is equal to j. Okay. So if I just go ahead and I make my matrix A11, A12, A1, A21, A22, you see here now that I and j are equal to each other. So this is forming a principal diagonal. Or off diagonal क्या हो गया? Where they are not equal, like this. This is an off diagonal. Diagonal तो ये भी है, but this is an off diagonal because I and j are not equal to each other. Okay, beta.